Can everyone hear me? Thank you. I knew that I had some good use somewhere. So good morning. I'm talking to you today. It's a pleasure to be back. One thing that I'll also like to add is I am a hardcore Indori. I came into this city when I was 2 years old and went all the way through higher secondary, left only to go to IIT Bombay and then came back. So it is really a pleasure to come here and talk about this thing which has been my passion for about over 30 years, which is propulsion systems. One thing that people are focused on these days is sustainability. The way you look at operation of an aircraft engine, you realize that this thing is making a significant impact on the sustainability issues, which I will define in a moment, and see what we can do to actually make a difference. So let's start with something that has happened in the past. The story that I'm telling you actually started back around 2010 or so about 14 years ago, and has been evolving since then. That should give you an idea of the product life cycle for this thing called the aircraft engines. This is not your iPhone, which becomes obsolete in 3 years, and now you get a new model. It takes an army of engineers, about 1,500 or so, working tirelessly for 5 years, with another 5 years worth of work that has gone on before that, not by that large number. But it takes a long time to actually design and then validate and then certify an engine. So you have to take these things very, very seriously. Now, what you see in front of you here was this thing that Time magazine does. Every end of the year, they go out and make a list of what are the most significant things that might have happened in one particular topic. So back in 2011, they had picked an aircraft engine that was under development at Pratt & Whitney, where I worked, as what they call the most significant thing to happen in engineering. They called it the green engine. Now you see the details a little bit later. If you happen to be over 40, then this is what you want to look at. This is just magnified so you can read it properly. But if you look at what this thing is saying, is they are saying that this was the most significant or most important development in aviation in 2011. And there were some good, tough competitors in this field. If people at Boeing, always my friends, they don't like it when I show this slide, because the 787 had come about at the same time, and that didn't make it, the engine did. So why did they think it was a most significant development? They said this is going to give you about 16% improvement in fuel consumption. So this was the prediction that was made before the engine was designed and certified. 16%, depending upon your point of view, may sound like a lot, may not sound like a lot. So we have to reduce everything to dollars, and then you have an absolute standard. The fuel consumption of the 3 major US airlines, which is American, United, and Delta, is about 4 billion gallons, 4 billion gallons each. So 16% savings is approximately 2 billion gallons of fuel that is saved. That's a lot of money, no matter which way you count it, okay? So people were definitely interested in it. 16% improvement sounds good, but what else? Well, it also makes half as much noise. And if you happen to be living in living quarters that are in the close proximity of airport runways and stuff, you would actually like this. Now, in reality, what might happen is the moment you make everything quiet, then houses get built closer to the airport, and again, the complaints will begin. But it's all a part of that cycle, all right? So now we have the fuel part, and they said that it can do all of this because of some clever gear work. This is where I fall off this wagon. And I'm a mechanical engineer. All of my degrees have been in mechanical engineering. And I will show you why that is the case. The gearbox, if you go and look at just the engine without a fan drive gear system, with a fan drive gear system, the gearbox is about 300 pounds, 300 to 500 pounds worth of weight. And the losses in the gearbox are costing me 0.5% of the fuel consumption. Yet, the engine in overall fuel consumption is definitely far superior. And that's the beauty of looking at the engine or any other product system design in the functional space instead of focusing on, I got these turbine blades and let me see what I can get by putting them together with some compressor blades. So let's look at the life of the aircraft engine. Now, before you start looking at all the things that are bad about it, and tongue-in-cheek, I will show you many things that are bad about it. But we need to pay attention to what is good about it too. And if you look at the things that are listed over here, what does aviation do? Number one, it is an enabler of fast intercontinental transportation. Today, you can go from any point on the Earth to any other point on the Earth in less than a day. You just need the right kind of aircraft and, of course, the right kind of engines. But you can actually do that. This is no longer the case of people from the generation previous to mine. Anytime anybody went abroad, you had to go climb on a boat, and maybe a week or 3 weeks later, you got to your destination. That's not the case anymore. We can do it all in less than a day. The next thing that happens when you have the aircraft engine or the aviation, it provides market access to all over the world. And having that market access allows people to do two things. You get economies of scale. So instead of making 100 of whatever, you are making, say, 200 or 400 of whatever, and the economies of scale come and help you. The second thing that it does is knowledge sharing. What people know in one part of the world almost instantaneously is available to the other part of the world. You know, communication plays a big role in it, but you take aviation to actually move things around. The societal and the cultural interaction cannot be overstated. You get to travel, you get to know people in different parts of the world. You can actually have rational and reasonable conversations with them. And that has a societal benefit. Now, this is all that's good about aviation, but we also have to pay attention to its environmental impact. If you look at the airplane, what's in the wake of the airplane, this is just a rough listing of what you get. It is primarily carbon dioxide, next is water, and then there is less than 1% of these things that sometimes tend to be nasty depending upon your health condition, which is NOx and SOx, organic carbon, etc., etc. Now, the reason why you have that much CO2 and that much H2O is quite simple. You are burning hydrocarbon. It consists of hydrogen and carbon. So when you burn it, and if you are good at burning it, you are going to get CO2 and H2O. And I had talked about these things going back to about 20 odd years ago at one of the annual gatherings of Aeronautical Society of India. And at that time, people were all focused on emissions like NOx, et cetera, et cetera. And I was joking, saying that, well, the next thing that will happen is you will get penalized for being very good, because when you were very good, you were producing CO2 and H2O. And that day has actually come here. So the problem is, if you look at the carbon dioxide and H2O together, these are greenhouse gases. And because they are greenhouse gases, what they do is they actually trap the heat that the Earth is trying to radiate out. And if you trap more of it within the Earth's atmosphere, then the whole heat balance of the system changes. And that causes the temperature to go up. Some people have a misconception that the reason for you get into global warming is because you are burning so much fuel and that heat has to go someplace. No, that heat is actually minuscule compared to the heat that the Earth would give out by radiation. So these are greenhouse gases. They cause a climate problem, leads to global warming that I think all of us are actually experiencing. Then you look at the other gases that you have in the exhaust, which is the nitrogen oxides, sulfur oxides, unburnt hydrocarbon, soot, which is black carbon. They have an impact on air quality. Now, if you are perfectly healthy, young person, you may not care and it may not really affect you directly at that time. But if you have people with respiratory system problems and stuff, this can be really a serious issue. So there are good reasons why we have to go and look at this part. Noise is the third thing or the last thing that you need to worry about. Up until now, when airplanes were just coming into play, people didn't think too much about noise because it was a sign of progress. A logo that used to go on the side of a F-15 engine made by Pratt & Whitney used to call it the sound of freedom. I mean, it was loud as heck, and it had great acceptance. I mean, people go and watch automobile races, right? They are very loud. So it's all about acceptance. What has happened is these days, the acceptance levels have gone down. People's novelty with all the noise and stuff has gone away. And that is leading to annoyance, as well as there is some recent evidence that there are some health impacts of being exposed to noise. Not my area of expertise, but since we are talking about sustainability of the aircraft engine, this sort of lays the groundwork. What are the three things that matter? Okay, noise is one thing, health or air quality is the next thing, and climate is the third thing. I didn't list them in any particular order, but these are the three things that you really have to worry about. So I'm going to start talking about noise and fuel burn because we are short of time. We will be pressed for time. If there is time left and interest, I can continue to the emissions because they fall along the same lines. So you have to look at now the noise and fuel burn. Why are we looking at it? Because the way the systems are being designed today, this is no longer a problem which can be split into three subsystems and handed to three different people to work on them. In past life, the noise people worked on noise and the performance people worked on the fuel consumption and so on. They independently optimized the systems and they just put it together. We can't do that anymore. Sustainability basically cuts across the disciplines and puts you in a position where you have to do all three things at the same time. So it's the interaction between these different requirements that creates a huge amount of problem. So let's look at noise first. Now, we could go in any order. This just happens to be one that suits my agenda. If you are going to build a low noise engine, I learned the hard way that there are three lessons you must never forget. Lesson number one is don't produce the noise. Now, it may sound like kind of a corny thing to say, but that's very true. Because when you produce the noise, you are already behind the proverbial 8-ball. And now you are struggling to just come up with it. Not being able to produce being able to not produce the noise or keep the noise level low is very important. Rule number two, if you have to produce it, please produce whatever you do in modes that are standing as opposed to propagating. Because standing waves, they are going to sit inside the confined space. You can actually put liners and you can kill them. The propagating ones are difficult to deal with because you can't really chase after them. And the third thing is find every square centimeter of space in the nacelle which contains the engine to put acoustic liners. Okay, do not go skimping on acoustic liner because of cost or weight or stuff like that. So what you are seeing over here is the noise of a typical aircraft engine built in the 1990s split into three different ways. Or actually, you have two conditions for which I'm showing you the noise produced by one of the many different components. On the left-hand side, you are looking at what that distribution looks like for a takeoff condition. And on the right-hand side, you are looking at a typical approach distribution. So the sound of the aircraft when it's coming into land looks like this. Sound of the aircraft that's taking off looks like this. Now, what do I mean by this? Sound is not a one-dimensional unit. It may have a one-dimensional unit that I don't like it, but in reality, you have to pay attention to amplitude, which is how loud it is, frequency, because not everybody is sensitive to the same frequencies. The dogs hear much higher frequency than we do, but dogs don't get the vote. And the third thing you have to pay attention to is directivity. All the sound that comes from the engine doesn't just go spherically all over the place. That's actually different sources are directed in different direction. The two sources to pay attention to is, one is the fan, which is big part of the engine that you see in the front as you are walking in front of it. The sound coming from the fan goes primarily in the forward direction because you have shocks. These are running at transonic speeds. The shocks are coming out and propagating in the forward direction. You also have little bit of fan noise going backwards along with the jet that's coming from the bypass. The other thing that you will pay attention to here is jet, the exhaust from the engine, which is the primary source of producing thrust. That is something that you will hear in the aft direction. You won't hear it in the forward direction. So when you are standing someplace and the airplane is coming towards you, you will hear the fan noise, you will not hear the jet noise. If the airplane coming over your head flies and goes back behind you, now you will hear only the jet noise, you will not hear the fan noise. So that's kind of important, and that's what you see here. The takeaway from this is fundamentally we have to pay attention to the fan and the jet. Because if you look at the engine total noise, it's literally just the sum of the jet noise and the fan noise. By the way, those two get added in the logarithmic region. That's why you don't see this blue bar twice as big as any one of those. Airframe, you will notice, is very quiet. And the reason why it is very quiet is it is in a very clean configuration. When the airplane is taking off, you have landing gear that has retracted in. You don't have too many of flaps and slats that are necessary. Those are called high lift devices. When you are coming into land, you need those high lift devices. You do need your landing gear out. And therefore, if you come and look at the approach distribution, you have the fan, which is there. The turbine now shows up. Jet is a lot lower. And the airframe noise is quite significant. So you have to really look at things like putting fairings and taping over all the small holes or whatever you might have to get to a low noise configuration. So fine. What do we do about it? We have a physics-based understanding that tells us that the jet noise scales as sixth power of the jet velocity. And by the way, you will see sixth power, sometimes you will see eighth power, and I think the difference is one is sound pressure level, one is sound power level. So if I want my noise to be low from the jet, what can I do? Reduce the jet velocity. There is nothing else you can do. The jet noise is very insidious. All of it is produced outside of the tailpipe. So all those three rules that I told you, it violates each and every one of them. It produces noise that propagates, and it produces it outside. It's behind the engine. You are not going to be able to take the liners to it. So jet noise is definitely a good thing to actually kill. The other thing that we need to pay attention to is the fan noise, because that's big in both cases. So bottom line is, if I want to build a low noise engine, I require low jet velocity. Now, how do I reduce the jet velocity? Well, lower fan pressure ratio, because in the engine, what you are doing is you are sucking in atmospheric air and you are compressing it by whatever is the pressure ratio of the fan. That goes behind the fan, and then it expands out of the nozzle and produces thrust. So the velocity of the jet that is coming out is a function of pressure ratio across the nozzle inlet to the nozzle exit. And therefore, you need low fan pressure ratio. So basically, you want the fan to have low fan pressure ratio, and you want it to have low fan tip speed, because the fan noise is scaling as another high power of the fan tip speed. Great. So now we think we understand everything there is to understand, and we are ready to build our low cost or our low noise engine. Let's see if it really works. So what I now show you is results of modeling truly predicted, because these things we had put out in 2010 or something. The aircraft and the engine didn't fly until 6 years later. What you will see is an aircraft coming from the left, going at this overhead position at about 2,000 feet altitude and continuing its takeoff. You will see the aircraft flip-flop between red aircraft and blue aircraft. And the difference is the red aircraft is a conventional engine, meaning the fan pressure ratio is about 1.8. And the blue aircraft is the new engine that we were trying to convince everybody and their uncle in the world that you need low fan pressure ratio. So that's an engine with a fan pressure ratio of about 1.35. And when it flips to blue, you will hear the noise for the blue. When it flips to red, you will hear the noise for the high pressure ratio fan. Because the airplane is moving and you are stationary, you will see the quality of sound change. You will hear a whistling sound as the aircraft is coming towards you, which is the fan tone, because it's a pure tone that you are getting out. Going over your head, and as it goes behind you, you will see the noise will change to a thundering, low frequency, booming kind of sound, which is coming from the fan, the jet that's coming out. And by the way, thanks to a non-existing engine program called the Bombardier C series, the engine was successful. The airplane, the people developing it ran out of their credit limit, and Airbus swooped in and bought that whole program out. So the Airbus 220 is really, or A220 is really not designed by Airbus. It started its life in Bombardier, and it is a darn good airplane. So let's see what we hear here. Now, just like there is no longer Bombardier making commercial aircraft, there is no longer United Technologies making engines. corporate entities have been sold 2 times, 3 times over. So now watch this. That's high FIPER. That's low FIPER. You can already see the differences. Now that's overhead. Look at the difference between blue and red. Remarkable difference. Everybody agreed it was remarkable, but nobody wanted to believe it. Well, the belief actually came when in the next Paris Air Show, Bombardier had brought the aircraft over for display. And people were sitting around talking about when is the airplane coming, when is the airplane coming, didn't know the stupid thing was on top of their heads. And they just did not hear it. That's how quiet it was. So now that we are 16 years from the time when all of these predictions were made, the engine is a relatively low noise engine as it was predicted to be. So now begs the question is, okay, we think we understand it, we actually did some calculations, so we have quantified the behavior. So, okay, what's stopping us from building all the aircraft engine with a very low fan pressure ratio? So what I'm going to show you is a plot where conceptually on the x-axis, I'm plotting fan diameter. Really, I don't care about the fan diameter. What I care about the fan pressure ratio. And on this axis, the fan pressure ratio is, you are going for reducing the fan pressure ratio. So the scale is kind of backwards. This is the highest fan pressure ratio engine all the way to the left side. And as you go out in fan pressure ratio, which is the lower fan pressure ratio. So you got that. What happens to the noise as we are going through this process? The noise just keeps on coming down monotonically. And I would hope that everybody in this auditorium at least is now a believer, right? There was a very fundamental reason why that was supposed to happen. And it did happen and seemed to show the same trends. So that part is fine. What happens to the fuel consumption? That's the other thing that we are worried about. Well, if you look at the early history of jet engines, as people kept on reducing the fan pressure ratio because they learned how to make bigger engines, the fuel consumption was coming down. So everybody was happy, right? We had only one direction to go in. Well, that joy didn't last for too long because as you keep on increasing the fan diameter with corresponding reduction in fan pressure ratio, this curve actually hooks up. And that's where you are with state-of-the-art components if you just don't do anything else. So the engine program VPs then come around to the engineering side and say, well, give me some technology. I will pay you. I should have been paying you earlier. Sorry, I wasn't, but now put in more technology. When you do the more technology, all it does is it shifts that hook in the curve to a little bit down and a little bit to the right. By the way, does everybody understand why low fan pressure ratio implies higher fan diameter? Yes, no? Come on, you are research fellows. Anybody wants to volunteer? Anybody minds being volunteered? Well, the answer is simple. If you reduce the fan pressure ratio, you are reducing the jet velocity. If you are reducing the jet velocity, you are reducing the thrust per unit mass of air. And if you kept the same mass of air, your thrust will go down. The airplane, the pilot, and the passengers will not like that. So fan pressure ratio. Thank you for doing that because my presentation will be full of these silly acronyms. Please raise your hand and ask, I have lived in that world for so long, I don't even know I'm using the jargon. So it is, if you look at the jet engine fan, which is the most forward thing that's sucking in air and throwing it out the back pipe, you are looking at the discharge pressure of that fan unit divided by the inlet pressure of the airplane. So that's fan pressure ratio. Okay, so now what are we going to do? Well, the point is, do we really need to do anything? Do we really know that on this curve, we are on the wrong side? Because if life still continues to be where you put the larger size fan, reduce the fan pressure ratio, and fuel consumption is also going down, I already know noise is going down, I don't have to do anything. But we know that that's not the case. We know that that's not the case because of an airplane called the A380. When Airbus had decided to build this super jumbo aircraft, they had asked for the engine companies to produce an engine which needed to be more fuel efficient, more quiet, cleaner, way like a feather. Other than that, we could do anything we wanted. Well, turns out that for business reasons, Pratt & Whitney and General Electric, both US companies, decided to form a joint venture and field one engine with all their corporate knowledge. That was called, the engine was called the GP7000. Rolls-Royce went on to go and build their own engine on their own, so there was no cross connection between the two. But what landed up happening is both the engine proposals went to Airbus, and Airbus says this doesn't work. The reason why it didn't work is the launch customer for that airplane was Emirates, and Emirates didn't want to have anything to do with noise levels that would jeopardize their ability to land and take off from the London City Airport. London City Airport has a QC system, quota count, and what they do is every time your airplane lands or it takes off, their meters measure the sound and they debit so many counts from your account. And when you run out of the quota that you have been given, you don't fly anymore. So that was not going to be acceptable. Basically, if you did not have an engine that was quiet enough, Emirates wasn't going to buy it. So we went here and looked at what did we have to do. There was Pratt & Whitney and GE combined teams. They landed up having to make the fan smaller and increase the fan pressure ratio. I'm sorry, they had to make the fan larger and decrease the fan pressure ratio, which cost them fuel consumption. Because while the engine was quieter, it was not more fuel efficient. In fact, surprisingly, or not so surprisingly, if you believe in laws of physics, both engine companies landed up adding about 6 inches to the fan diameter and losing about 0.5% in fuel consumption. So the laws of physics were no different for them than they were on this side of the Atlantic. So we know there was a problem. The engine was in the wrong place. And we therefore had to go and do something that gives us the ability to solve the problem. So that actually brings me to the functional design prop challenge for the engine. A functional design is when you are looking at the system and you are not paying attention to how many sheet metal parts it has or this or that. You are looking at what's the system supposed to do. And the functional design is your mental plan of how am I going to get the system to do what it is supposed to do. So in this case, our challenge was we need to reduce fuel burn, emissions, and noise all at the same time instead of trading one for the other. My favorite statement in those days used to be, I am greedy. I'm not giving up something to get something. I want it all. And what are we going to do to actually get there? So now we will go and take a look at how does this thing work. So as I told you what functional design meant, we have to now go into this functional space or functional design space to figure out what does the engine look like in that space. So what I have done is I have taken the engine and I have split it into three subsystems. The outermost subsystem that is something that you need is the propulsor. What is a propulsor? It's a made-up word for putting something in front of you that actually produces the propulsive force. So in physical space, for a turbofan engine, the propulsor is the same thing as the fan. For a turboprop engine, the propulsor is the same thing as the propeller. You can look at a marine propulsion unit has exactly the same things. They have a screw that is the propulsor that produces the forward thrust, and then they have a prime mover behind it. So you have the propulsor as the first one, and behind that you have a unit called the power plant. Because fine, you define propulsor as something that's going to produce thrust. Well, it's not going to produce it for free. It's going to need power. So now what do you do? Well, since we don't have very long extension cords, you need an engine to produce that power. You can't just plug it into something and it's going to work. Now people are working on battery-powered aircraft, and that's still far, far away because of the stringent requirements on the weight and the power requirements of an electrically driven aircraft. The power plant itself consists of two subsystems. One is the gas generator. So what the gas generator is doing is it is sucking in low pressure, low temperature air from the ambient, and it is compressing it to run a thermodynamic cycle called the Brayton cycle. And the net output that you have from that is work that's available in form of high pressure, high temperature gas. It's the enthalpy of high pressure, high temperature gas that's what you get out of the gas generator. And then finally, you have the power turbine where you take that high temperature, high pressure gas and expand it through the turbine to produce mechanical work, which is shaft. And what do you do with the shaft work? You drive your propulsor. So that's how you close the system. If you want to think in terms of an analogy, think about a steam power plant. A steam power plant has a boiler which takes low temperature, low pressure water and compresses it. It adds fuel to produce high pressure, high temperature steam. Then you take that high pressure, high temperature steam, expand it through a steam turbine, and that gives you the shaft work. You connect an electrical generator to that shaft to produce electricity. So they are absolutely equivalent. The generator is the same thing as the propulsor. The gas generator is the same thing as the boiler. And the steam turbine itself is the power generating system. If you don't like so many words, we can look at pictures. So this is what a jet engine looks like. Everybody would recognize a bunch of things about it. This is generally speaking hanging under the wing in the aircraft. You have mass flow, m dot coming into the engine. You have the same mass flow leaving out. For the purpose of simplicity, I am ignoring the mass of fuel that is injected to produce the high pressure, the high temperature. And that's because that mass is barely about 2% of the overall airflow going through the core. So it's another factor of 5 or 10 less when you look at the large bypass engines. So the inlet is m dot and v naught. V naught is the cruise speed of the aircraft, and what is coming out of the tailpipe of this aircraft engine is m dot and v sub j, which is the jet velocity. The momentum flux coming in is going to be the product of the mass flow and the must be equal to, what happened? Okay, so going back to it, I have more momentum flux leaving than there was coming in. Ergo, force must be being applied on that airstream. And then I go to the third law where I say force applied onto the airstream by the metallic surfaces must equal the force applied by the metal stream on the air. So that's how I know what is the net force on that propulsive force produced by that engine. I don't need to go inside. I can take this control volume approach. The next thing that I'm going to then do is also pay attention to this click. So now we are going to go and look at inside of the engine to see what is going on. We are hopelessly behind. Okay. So remember, I told you how the engine actually works. I'm now taking the whole process of starting with chemical energy in the fuel to producing propulsive power delivered to the aircraft, and I'm splitting it into 3 steps. And why these 3 steps will become clearer later. The first step is my gas generator. Because if I'm going to do anything with the engine, I need to actually have source of power. And that's where the gas generator comes in. So that's that red stream that you see going in. It goes in, gets compressed, fuel is added, it burns, it expands through the turbine stages, not all of them. Functionally, I want it to go only to the place where the turbine work output or turbine power output is exactly equal to the power consumed by all the compressors in forward. Because now the whole compressor turbine combination has become a gas generator, which is giving me the gas to do whatever I want to do with it. The efficiency of the gas generator is called the thermal efficiency, which is the gas power that you get out of the gas generator divided by the chemical energy that you are pumping in from the combustor. The second step is now you take the gas generator output and expand it through a few more stages of the turbine that are left. That's the power turbine. That is sort of like the steam turbine analogy. And you expand that, the shaft work is now available for use in the third step of power generation, which is how do I actually convert that power into thrust? And that is that stream, airstream that is shown there here in green. It's just getting sucked in from the front by the fan, compressed, and then expanded out of the tailpipe. So the propulsor, which is really converting the shaft power into the propulsive power, has a parameter called propulsive efficiency, which is the ratio of the two as what is available for conversion to propulsive power delivered to the aircraft. Putting all of this together, now I have these 3 subsystems and efficiencies that go with these 3 subsystems. And I multiply them together, and that gives me the overall efficiency for the aircraft engine. Now, why did I choose to split it this way? Because it is convenient to the point that I'm trying to make, and it also tells me how should I direct my energies in terms of design, development, research to give me a better product because they have now been separated. So if I want to have high propulsive efficiency, I need a lower fan pressure ratio, I need a high efficiency fan, and I need to reduce my duct losses. If I want a higher transfer efficiency, I need the low pressure turbine efficiency to be high, and the transfer losses through gearbox and stuff like that should be minimal. And then finally, for those who like thermodynamics, the thermal efficiency is right at the front, where the parameters to actually work on is the overall pressure ratio of the engine cycle, the temperature at the combustor exit or turbine inlet, and the component efficiencies. So we have a choice of these different things that we could actually work on. Let's look at them one at a time. Thermal efficiency is the attribute of the gas generator, because this is strictly the thermodynamic cycle analysis, second law in all its full glory and everything that you have to understand. That's where it plays the role. How are you going to do that? Well, you will need to build the machines with higher overall pressure ratio. Okay, what is higher overall pressure ratio going to do? It will make the engine heavier, and it will also have implications on cooling. So fine, you can go do that, and here is the cost that you will have to pay. The the compressor exit temperature will go up when you go for higher overall pressure ratio. That reduces the cyclic life of the components, so you won't have engines lasting 15,000 hours on the wing. And you will have higher combustor emissions because the temperature of the air going into the combustor actually matters. You will also have a higher weight engine because in order to produce higher pressure ratio, you will most likely need more compressor stages, and they add weight, they are heavy. Opportunities, if you are a researcher starting your career and you are absolutely devoted to working on aircraft engine thermal efficiency improvement, well, higher efficiency turbomachinery is capable of withstanding very high temperatures like 3000 Fahrenheit, because that is where they are going to be needed. So things like ceramic matrix composites and things along those lines would be useful here. The variation of the cycle thermal efficiency with overall pressure ratio is shown here. You can find it in any textbook. It's easy to actually arrive at. The thing to keep in mind is as you go from the overall pressure ratio of say 20 or 25, which is typical of engines in the 60s, to higher and higher pressure ratio, you will notice these lines actually go up, and then at some point they roll over and start to fall down. And that's because the incremental compression work is more than the incremental turbine work that you get with the increased pressure ratio. So in order to work right, you have to go and increase the combustor temperature, which brings its own set of problems. The other thing that happens is, this was from that red curve over there is showing you what is the compressor exit temperature for the overall pressure ratio. So this is the cold section, quote unquote, of the engine. And the temperatures that you are looking at over there are typically 12 to 1500 Fahrenheit. To put it in perspective, if you ever work with an oven in your kitchen, you probably will not run it at higher than 400 Fahrenheit. So this thing is 3 times as hot, and we call it the cold section. Okay, because it's colder than 3000. That's basically the bottom line. Propulsive efficiency is the tricky thing that people had neglected or not paid attention to as much as they needed to up until now. And that was at the foundation of developing this gear turbofan. It's an attribute of the propulsor. How do you actually get higher propulsive efficiency? Is by reducing the jet velocity, because you reduce the propulsive stream loss. Now, why is it that the propulsive efficiency is a function of fan pressure ratio? Or why do I want low jet velocity? The answer is simple. I explained to you the basics of producing propulsive thrust is excess of outgoing momentum flux over incoming momentum flux is net thrust. At the same time, the excess of outgoing kinetic energy flux over incoming kinetic energy flux is loss. Because if you could run around behind an aircraft engine with a windmill in your hand, you could actually produce power. And that power is being thrown out by the engine. So if you designed an engine where that power being thrown out was smaller, the losses will go down. That's why a low fan pressure ratio engine is the right thing to do for higher propulsive efficiency. And the impact is actually quite significant. And it requires a low speed and a low pressure ratio fan, which is good. The cost of this is weight and drag. Why? Because the fan is now much larger in size, so it's going to weigh more. The nacelle which goes around the fan is larger in size, therefore it's going to weigh more, and it's going to have more installation-related drag. So naturally, if you do want to work in this field, what do you have the opportunities to work? First of all, high temperature, you want the lower weight materials, but they don't need to be very high temperature capable. They don't need to go to 3000 Fahrenheit like numbers. They only need to go to about 1200 type numbers. So you need those low temperature materials which have lighter weight. The nacelle weight and drag reduction. So figure out a way where the nacelle weight and drag will not go up proportionately as the diameter goes up. And I will leave it to your imagination to figure out how that can be done. There are ways to actually go do that. So now we can actually quantify this business, right? You can go and write down the equations for the propulsive efficiency by looking at the outgoing kinetic energy minus the incoming kinetic energy. Can I move this? So you can now look at the equations very clearly. The shaft horsepower of the fan is scaling with the square of the velocity or the difference in the square of velocities. And you can actually then calculate what the frequency or what the variation under ideal situations would be. And you will notice world, when we started on this effort, was sitting at 1.7 or 1.8. So say about here, the efficiency was very lower. And we were targeting something around 1.35 to 1.4. So there is a significant room for performance improvement. Theory is good. But what about practice? If you go into this publication called Jane's, that has the operating characteristics of all kinds of aviation systems and subsystems, what we found there is the direct drive turbofans, which is the construction that existed up until now, they show this kind of a trend. So the trend is right. They are a little bit off, but then the top line was drawn assuming that you have 100% efficiency turbines and compressors and things of that sort, which is not the case. So the internal losses account for this. Well, what's the yardstick against which we can measure this performance? So the yardstick for that is turboprop. Turboprops are essentially very low pressure ratio propulsor engines. So it makes sense to compare them. They are at a equivalent fan pressure ratio of about 1.05 to 1.1. But they are noisy. And people have this misconception that a turboprop is not high-tech and a turbojet is high-tech. No, everything is the right engine for the right application. You, as the systems engineer, need to be able to figure it out and convince everybody that's what we needed to do. So what was the job that we undertook at this time? Is recognize that there was a big gaping hole between where the state of the art existed for turbofan engines and where it existed for the turbofan. So this in-between space is what I call the low FEPR turbofan engine. And that is where we wanted to go build the next engine. Okay, so that's the aim. Just along the lines of what we had seen, you have to, it's an attribute of the power turbine and the transmission system. I have now switched over to the third component, which is the transfer efficiency. How do you reduce that? Or how do you reduce the losses, that is? You reduce the power turbine aerodynamic loading and the parasitic transmission loss. Cost is going to cost you weight. The reason why it's going to cost you weight is because you will need more stages to reduce the stage loading of the low pressure turbine or the power turbine. It's fundamentally architecture limited, because what is happening is you have the fan connected to the low pressure turbine on the same shaft, so they must rotate at the same speed. Fan wants to go slow, the turbine needs to go faster. There is no answer that everybody is happy on. And in reality, you'll end up building turbine that is a little bit worse than you would have liked to. You build the compressor or the fan, which is a little bit worse than you would like to. And you got an engine that not the best it could be. So that was the challenge that we actually undertook. And let me quantify that for you for a little bit. This is a chart called the Smith chart. Comes from a gentleman by the name Smith at Rolls-Royce back in the 60s. But it basically shows that if you plot the stage loading, that's delta H over U squared is the enthalpy you have extracted in a stage, normalized by square of the wheel speed. And Cx over U is basically inlet incidence angle. It is telling you that in order to drive the efficiency high, you need to be driving along the directions of that green arrow. The red dot shows the in-service direct drive turbofan LPTs that existed today. The gray dot shows our best attempt at trying to build a direct drive turbofan with today's technology. We were able to improve it, but barely. Okay. So we need to fix that. Some data that shows what do these stage counts really look like. The dots that you see here are real engine, except the one at the top left-hand side, which is identified as Silent Aircraft Initiative Direct Drive Turbofan. This was a collaborative effort between MIT and University of Cambridge, Whittle Lab. And Rolls-Royce design system produced the requirements that came out. Everybody agreed a 9-stage LPT is a stupid idea and we are not going to do it. So what are we going to do? Well, we looked at the direct drive turbofan. It's a flat line with respect to the LPT to fan diameter ratio. But the real reason was as follows. Look, for low noise, low speed, for low noise engine, you need a low speed, low fan pressure ratio, large fan. High propulsive efficiency requires low fan pressure ratio, large fan. This is really great that two requirements are lining up to asking you to do the same thing. Higher propulsive efficiency is always good. High thermal efficiency would also be good, except the problem is it has an adverse impact on the maintenance cost. The engines won't last as long, and it will have adverse impact on the combustor emissions. High pressure efficiency or high transfer efficiency requires low aerodynamic loading of the LPT, and this unfortunately has an adverse impact on the propulsive efficiency. So now you are trading one for the other, which is what we said we were not going to do. Why is this happening? Well, the fundamental problem is the direct drive coupling between the low RPM requirement fan and the high RPM requirement LPT causes you to trade one for the other. And what you see on the left-hand side is a theoretical exercise using the design system that took the direct drive turbofan and ran the case studies, taking an engine with a 63-inch diameter fan all the way up to 81 inches diameter fan. And you see the problem. The weight is growing up like crazy. The 81-inch diameter fan will be about 1,200 pounds heavier than the other engine, and nobody is going to go for that. So what we need is a paradigm shift. We need to recognize that a directly connected LPT with the fan is not something that came from God to Moses on stone tablets, and we are not capable of changing it. This is a choice that we made, and we need to make a different choice by looking at the system the right way. So what you see is a comparison made between three engines where they have been scaled to have about the same fan diameter. So the thrust levels would be comparable. But you will notice that the very left-hand engine, which is the GE engine, the biggest difference between that and the middle engine, which was the Pratt & Whitney geared turbofan layout, is the size of the LP compressor and the size of the LP turbine. So all said and done, we arrived at a configuration which is enabled by the gear system it's the capability of operating in the right design space. By the way, these all plots that you are seeing were made a good 15 years ago. And now that we actually have engines in hand, which is GE has a LEAP engine, which doesn't have the gearbox. Compare it weight-wise to this publicly available data. It's amazing how we were able to actually get to the right answer without having to worry about it. So 500 pounds it would have been the weight differential. And in reality, I think it came out to something like 495 pounds. The turbine efficiency, we landed up going all the way down to the left hand and the bottom left hand side. I'll just skip through this. So here is the problem. This is where we started with the challenge, right? That we wanted to increase the fuel burn, we wanted to decrease the fuel burn and decrease the noise, and we found the state of the art didn't work. Now we are much better informed. We know exactly why the problem is there, and that's the increasing weight of the low RPM LPT. It contributes to the increasing in fuel burn. That's why that hook happens, and that controls quantitatively where the hook will happen. If you do a paradigm shift, which is the green dotted line there, now you will notice that when I moved from a fuel burn optimized device to a device or a system that was optimized for fuel burn and noise, I can actually do it. Some data that is now available after the fact, which is today's aircraft is about year 2000. You will see the footprint of how large the noise footprint at some 75 dB or 85 dB that I don't know. Versus the right-hand side, where same airplane, same airport, but now you are flying with a GTF-powered engine, and you will see that the quality, the footprint of that noise is significantly lower, as is being verified now by the engines that are in place. So in configuration, what I would like to do is, you can read these later, but the bottom line is, remember, the gear drive configuration enables low fuel burn and low noise. Okay, and it comes when you build an engine which has higher efficiency both in fan and in the core will end up getting smaller. And therefore, this parameter called the bypass ratio, which is mass of air going through the fan divided by the mass of air going through the combustor, is high. The mistake everybody was focused on, let me reduce the bypass ratio, increase the bypass ratio, and the efficiency will increase. It doesn't, because bypass ratio is a consequence of the high efficiency engine. It's not the root cause. As you will notice, this thing very methodically, bypass ratio didn't really show up anyplace. So having blown my time constraint significantly, I'm going to stop. And I'm available for any questions, or can also be available for any discussions later on.
So Professor Jayant is going to be here entire day. Probably we can have a discussion in the lunchtime. In the interest of the time, we'll close the talk here. Professor Jayant, I think we can discuss it when anybody's interested. We can actually approach him in the break. Yeah. Small. Thanks for the wonderful talk, Mr. Jayant. Of appreciation from the organizers. So I request Professor Aiki to hand over a memento to Professor Jayant. So this is a Maheshwari shawl. It's a small token from IIT Indore. Thank you, Mr. Jain, for the wonderful presentation. Yeah. No problem. So,
thank you, ma'am. So next we have Professor Annapurni Subramaniam from IIA Bangalore, who will be talking on astronomy and astrophysics education in India. And I request Professor Bhargav Vaidya from Department of Astronomy, Astrophysics and Space Engineering to kindly introduce our next speaker.
but even I think in pictures.
तो लिंक only sir को बंद कर दी नहीं
So you have to join the Webex. So that I mean there are some online people depend on.
Actually, got to this one is.
idea just
Actually, that email is sent. No, there was WhatsApp I sent you recently. In WhatsApp it was there. Is there? It's the last one in this.
No, I think it's there.
In the
internet check internet
here the program sheet. And the first one, yeah, this one, both the same.
Webex again.
Join as a guest.
I'm Jayant.
ये माइक्रोफोन म्यूट रहने देंगे, सब स्क्रीन शेयर इसको म्यूट रहने दीजिए मैडम। हाँ, ये वाला माइक से जो चले जाएगा। हाँ हाँ, माइक और स्पीकर दोनों। माइक म्यूट कर दी ना मैडम, यू टू म्यूट योर स्पीकर मैडम, जस्ट हियर। हाँ, स्क्रीन इज शेयर मैडम। हाँ, जस्ट शेयर योर स्क्रीन।
Is there members coming here? So this is right. Yeah,
Yes,
sir.
make it full screen. हाँ,
Screen, that's already full screen.
ठीक है।
It's okay. Yes. Okay. Please, I'll introduce first.
Try to mute this. Okay.
No, please. Okay, please.
Good morning once again, and welcome to the second talk. So after learning about the propulsion of aircraft in the skies in the previous talk, let's move beyond the sky into the realm of space. It's an absolute pleasure to have with us Professor Annapurni Subramaniam, Director, Indian Institute of Astrophysics, Bengaluru. Over the last 3 decades of her stellar research career, Professor Subramaniam has made significant contributions to the field of star clusters, stellar populations, galaxies, and ultraviolet astronomy. She has played an integral role as collaboration scientist to the Indian space-based astronomy mission, AstroSat, particularly in using the UV imaging telescope UVIT payload. Professor Subramaniam has also contributed to development of softwares for the international project 30-meter telescopes, TMT, where India is an integral partner, and it's also one of the mega science missions. Recently, under her leadership, IIA has also delivered the coronagraph instrument VELC, which is on board Aditya L1. Currently, she is the principal investigator for the proposed next-gen space-based UV optical imager and spectrograph INSIST. She has also been a recipient of several awards. As a leading female astrophysicist in India, Professor Subramaniam has recently been awarded the CNBC TV18 Future Female Forward Award and Devi Award 2024. Professor Subramaniam is also one of the pioneers for promoting night sky reserves for astrotourism in India. Also, along with her passion for stars, she is a connoisseur of music and has been pursuing Carnatic violin. With this, let's welcome Professor Annapurni Subramaniam to take us through the journey of astronomy and astrophysics in India. Ma'am, please.
So good morning, everyone. So I'm here I just kind of slightly changed my title to give you an overview about astronomy, how we do from ground and space. And I am just here to pass on my passion and why I do this to you. It's not only as how astronomy is done to convey to you, but also to have an overall, understanding of where we stand as a country in the terms of astronomy and astrophysics, and also where we stand out in the international scene as well. So you can see the image out here, which is a extremely pretty picture taken from it's a false color image. So astronomy, you get a lot of these pretty pictures from various missions. So we call them as false color images. Most of them are false color images, but you also have this RGB color images which are coming from the ground as well. So when you create an image, what will you do is like you know which wavelength that picture is taken, and then you also have an information of intensity. So you have to do justice to the wavelength you've taken and also the intensity of the image which you've taken in. But in some cases, you cannot do justice to the wavelength because the wavelength you capture is not what I can see, right? Our eyes, human eyes, are only sensitive to the visual range. But there are photons which come in the ranges which are beyond that. So how do you represent them? So you get their intensity, you get their how many photons are you receiving, but you need to show them in a color which is acceptable or receivable by your eye. So you choose a false color to depict that particular intensity so that you understand. So the two images shown here, one in yellow and one in blue, are out of range of the human eye. The yellow is coming from the engineering marvel up in the sky, the James Webb Space Telescope. So this is the image of the Stephan's quintet, the interacting the four galaxies. It's taken in infrared. I cannot see, so it's given in yellow color so that you can see. So the trustable part of it is not the color, the trustable part of it is the intensity. Okay. The other one, which is the blue one, blue light, is coming from ultraviolet. That is coming from our own space mission, the UV imaging space telescope. It is part of AstroSat. Now, why am I telling you this? Is because there's a dire requirement of space missions because the wavelength which you capture on the ground is not either of these two, because the ozone stops it. So you cannot capture these wavelengths using marvelous instruments if you put it on the surface of the Earth. So if you want to capture this, you have to put them above the atmosphere. Now, how many of such things can you put, and what is, can you focus on certain wavelength range because you're doing a complex thing of putting up a huge instrument up in space? Can you do justice by capturing only one wavelength, by ignoring the other wavelength? What is at stake? So the point is that this galaxy, like interacting galaxy, you can see a lot of intensity coming from the center, you can see the patterns, etc., etc. Is that the full story? If you capture only the infrared information, it appears to be it's the full story. But if you capture the ultraviolet light, which is basically coming from either shock of the gas or from stars which are recently formed, then they are not appearing to be from the same place. Like you can see the smiley face you can see here. Yeah, you can see the, yeah, right. So the two galaxies, the blue flux is coming from a completely surrounding region. So either the gas is shocked there, or somehow the gas is expelled and the stars are being, new stars are being formed there. So it just tries to, and the point which I'm trying to drive is that the modern astronomy and modern astrophysics, which I tries to understand the whole process, what is happening in the systems like this, require multi-wavelength astronomy. There are also astronomers in this institution itself who do go beyond this, the wavelength range of beyond ultraviolet to high energy physics, like X-rays, gamma rays, etc. Also onto the longer wavelength range, beyond infrared to radio wavelength. So these two are the other extremes. So astronomy covers the entire wavelength spectrum. Now, the challenge is you need instruments to capture them. You need to find places where you have to have designs to make the instrument. How do you capture the photons? How do you bring it to a focus? What will sense it? So that you can create an image or intensity map in which way you want it. So an enormous amount of engineering goes behind astronomy to actually design, build, test, integrate, deploy, and collect the data and do a lot of software processing to actually get you these kind of pictures. So astronomy is extremely engineering-driven discipline. So how did we start? We started with ground-based astronomy since the time of Galileo. Now, what do we have in the country? Just push this up. Yeah, so this is one of the observatories in the south, which is run by the Indian Institute of Astrophysics. This is the Vainababu Observatory, which is very close to Vellore. This is established in 1960s. And we have two telescopes there, very anciently established, like the 1 meter, which is on the left, which is actually completed 50 years. So these instruments, ground-based telescopes, live for a very long time. So it stands the time of technology changes. You can imagine if it is built in 1960, what would have been the technology? But these go upgrades. I mean, they get upgraded. And there are a lot of things which go along with it. Just last week, if you are on social media, you can just go to the VBO, Vainabapu Observatory page. You can actually see the video of how we have taken out the primary 1 meter mirror down and brought it down. You have to recoat because the glass doesn't reflect. You have to put a coating of aluminum to make it reflective. That aluminum coating doesn't stay forever. You have to keep coating them. So how do you actually do it? So the entire support cell is brought down, then it is on the top of this particular, this particular thing. You have to bring it down, bring it all the way down to, down the mountain to the coating plant. You have to remove all this aluminum already coated. Optical engineers work on it. And then you have to put it in a coating chamber. The coating chamber has to be kept ready, and you have to fire this. Aluminum should not melt, but vaporize and deposit. This is another engineering challenge. Then after coating, you have to take it down, measure the reflectivity, optical, it's a measurement. And then you put it back and align it and make sure that it works. So, it's not only about building an instrument, it's also about maintaining it and upgrading this instrument. So again, the engineering challenges are a huge to make sure that it works continuously. So ground-based telescopes with all the support system have been working for decades and decades, and they have been producing fantastic science results, and that is where we stand before we launch things onto the space. Now, okay, go. Yeah. So we also have another observatory which we established in Hanle, which is in Ladakh, Union Territory Ladakh, and this is the Indian Astronomical Observatory established in early 2000. And the telescope which we initially started off with is the 2-meter Himalayan Chandra telescope. This is on the Mount Saraswat. And then this is the base camp where we have this Hagar, Cherenkov telescopes, gamma ray telescopes, and the recently one MACE. Now this is a very beautiful sky. And it is extremely far away from the city lights, and also at an altitude of 4,500 meters above sea level, which actually half the atmosphere is kind of beaten. So you have only very little atmosphere up there. And also the lower range of Himalaya stops all the clouds. So you have maximum number of clear nights up over there and very little turbulence. So seeing is good. The transparency is good. So you have number of clear nights, et cetera, et cetera. But it's not easy to reach there and, build these facilities and maintain these facilities. And to preserve the sky, we are undertaking efforts to declare this as the dark sky reserve. So we work with the local community because we should not be touching upon the economic benefits of them. So we have to work with the local community and the government to declare, to not only declare, but also to maintain the scientific quietness, the quietness of the sky in the sense of it being dark. Right. So this is the meteor, the Gemini meteor shower. I don't know whether you can actually see the streaks, which are taken time lapse, and you can actually see that the meteor showers are coming from the 2 stars, which are the Gemini constellation. And this is the Milky Way picture taken. Both are taken by Doji Angchuk, and he has applied lots and lots of pictures up in the social media. Going forward, so which of the telescopes we have, most popularly taken from the ground is like the 2.3 meter Vainabapu telescope, which is indigenously built. Actually, it was inaugurated in 1983 and operational from 1985, etc. But that is indigenously built at that time. But now we have the 3.6 meter from Devastal, which is at Nainital, and also a 4-meter liquid mirror telescope, which is operational in Devastal. So these are very big systems, very big engineering marvels, but these are on the ground. Now, going to the space, the advantages I mentioned is that you can cover wavelengths which you cannot cover from ground, and also the images can be sharper, much sharper. Now, there are advantages and disadvantages because if you forget to put a bolt properly, or if you're not tested properly, the instruments up in space will not work. So you cannot forget anything. And while in launch something gets broken, it doesn't work. You have to make sure that it survives the space travel, it also survives the space environment, and also everything works. You cannot go and fix anything. So all the tests and things like that, starting from design to making sure that all the tests it takes through so that all the components are proper, to the launch, and then you have to actually do performance verification, and then you do it. So it's a long time scale involved. So That's the reason why space missions get very prolonged. You can't take a chance. If you think there is something going wrong, you have to take a step back and clear it, and then only you can go forward. So that takes a very long time. Now, but there are advantages. So there are, pros and cons to both of it. So you have to take a stand on what do you want to do, actually. Now, yeah, so these are, as I mentioned, there's a clear demarcation of wavelength beyond the ultraviolet, like the bluer than 330 nanometer. You cannot get it from ground at all, even if whatever height you go. So you have to go to space. Also, the infrared is very important, because when you talk about exoplanets and life outside the solar system, then if you, or within the solar system, if you want to look at, then you need measurements which are tracers of organic molecules or something like that. They are all in the infrared. So you cannot take them because the atmosphere blocks them. So they're all mainly done from the space observations, and turbulence also gives you less clear images. Now, caching in the planning to take up all this multi-wavelength data as well as sharper images, the Great Observatories program of the US and the European Union, they brought up this plan of all these 4 space telescopes. That is starting from HST, then the Chandra, the Compton Gamma Ray Observatory, and the space that is the Spitzer Space Telescope. Now, you must remember that the popularity of HST overwhelms the other. You get a lot of pretty images from HST, etc. But it is a joint NASA-ESA mission. Earlier, HST was always propagated as a NASA mission, but always ESA is there. So later on, the narrative got slightly more modified and the combination came. It is always a NASA-ESA joint mission. And in the same tune, in India also proposed this AstroSat early 2000, but then we started building up a little late. And of course, building a space instrument requires a lot of resource planning. You can't just build it up in any laboratory, because you need a lot of laboratory space and also equipments, in the sense that we built the UV imaging telescope. What is the challenge with it? The the photons does not enter atmosphere because it gets eaten up by the ozone or the molecules. Similarly, if I make an instrument here, if I shine an UV light, it doesn't reach here because in between molecules will absorb. So you have to have a laboratory where you don't have contamination, molecular contamination. And second, if you bring one component and put it in your telescope tube or in where your detector is sitting, or even a holder for your optics instrument, that holder should not be emitting a molecule. Outgassing should not happen when the temperature crosses a certain stage. So anything comes into your laboratory has to be baked. So there are things like the cleanliness mechanisms. You have to have all this prepared. Nobody is there to tell you how exactly to do it. You have to figure out how to do that and set up the system and make it work, because you're not going to make it and deliver it in a month or 2. It takes about 10 years. So you have to make sure that it works for a very long period of time. And also handling things. You need to have handling things, and also be a number of people who can enter, go out and monitor. At any time, the clean room facility should not go power off, like, it should not be shut down. If there's any surge in the contamination in that room, then every component in that lab gets affected. So you have to make sure that it doesn't happen. So it's a lot of challenge. You have to have a separate team who actually is sensitive about it and make sure that they work. And they'll come and tell me, I was a calibration scientist on UVAT. They will not let me into the laboratory saying that, no, you're not required. Prove that you have to go into the room and take measurement. You just not go there to see it. You go there only to take measurement if there is an actual genuine requirement to do it. So such stringent things were put in, which are not generally used to. So you take a little bit of, initially it's difficult to digest, but then you get going with things. Now, what do they do? These instruments can actually capture, the bigger the instrument you have, the larger photons it can capture, or larger number of fainter photons you can capture. So you can look fainter things which are far away. If you have also the infrared measurements, you can also look far away things which are coming from. That's what the JWST is looking at. So with the JWST, we have been able to go up to about a few 100 million years since the Big Bang, and then we are able to see how the galaxies are formed. Hubble's Deep's field is the best of the things we started off with, but now we have images from JWST. This is JWST. This is the first instrument up in space which is got multi-mirror. Now coming to the another engineering challenge. When you look at small telescope, when you think of a telescope, you imagine a tube, right? Because you have a lens there and the light comes to one and then comes to focus here. But when it becomes bigger, how big a lens can you make? The whole thing becomes heavier. So you don't go through lens, you start making mirrors where you collect the light and then fold it and bring the light to the focus here. So a mirror is lighter than the lens, right? Now, how big a mirror can you make? You can make it to 1 meter, 2 meter, 3 meter, 4 meter. How long can you go? So we have up to 8 meter. So casting 8 meter blank, then you have to polish it, get it to the shape, and then also you have to balance it when you're not looking at the zenith. Anytime, any place you have to alter it. So you have a support system. And also coating. Coating plant has to be huge. So all these are investments. Now, if you want to go beyond 8 meters, is that the limiting thing? Is the technology limiting us to go to a maximum size of a telescope? No, the actual approach changes. We have 10-meter telescopes, which are coming from multiple mirrors. So you change from single mirror to multiple mirrors. Now, that change requires support of technology. The sense that you make the mirror into smaller pieces, align them, support them, and they together has to act as a single mirror. So it's a huge complex of technology. Now, the Keck telescopes are multi-mirror telescopes. So that is the same thing. And James Webb Telescope is the first such system in space with multiple mirrors. So you're not even launching one, you are launching 18 of them, 18 mirrors, and then you have to go and align them, and they have to work as single mirror. So it's a huge challenge, and that is what is achieved here. And the coating you have here, you can see it's not an aluminum coating, it's a yellow coating. It's a gold coating. So what basically means that the coating, metallic coating is given for a reflection, and the coating reflects whatever kind of wavelength you want the mirror to bring it to focus. In this case, you are more interested in infrared wavelength, so you have a gold coating. So all these are part of technologies towards giving you a scientific, what is it you want to see, or, the science requirement based. Now, another thing which I didn't want to say is that the instruments which you need in the infrared are very cold. You need to be kept cold. But this telescope has to see the night sky, but at the same time, where is the power coming from? Power has to come from the sun. So solar panels have to be deployed. The solar panels has to see the sun, but the telescope don't want to see the sun, and the instruments don't want to see the sun because they have to be kept cold. So you have to have a huge thermal management inside here. So where do you keep them? Where do you put these telescopes if you put them in space? These are the three kind of different orbits. One is the low Earth orbit, the other is the sun-synchronous orbit, and the third one I'll come later. So first is let me explain what is low Earth orbit. Low Earth orbit is coming up to about 300 to 600 kilometers. That is the height you put it in. The famous ones, the International Space Station, this is 300 kilometers, and it's easy to go, and you don't have too much of fuel to go up to 600. So 300 you can manage, and because you have to keep sending cargo, right? You have to send fuel, like the food, it doesn't stay very long. So you have to keep sending food, people change, etc., etc. The AstroSat is at 650 kilometers. Now, the important thing is you would have seen the International Space Station moving up in the sky. You can also see that because it reflects the sunlight. They go mostly about 16 times per day on the surface. So AstroSat is launched on September 28, 2015 for a lifetime of 5 years, but it's completed now 8.5 years in orbit. And every day it goes 16 times over Bangalore, and that is when the commanding is uploaded, and then the data is downlinked from all, including images, metadata, everything. Now, sun-synchronous orbit is like if you can also see the sun all the time, so the solar panels see the sun all the time, you can also go through this. Most of the Earth observation satellites take that. Now, if you want to see an unobstructed view of the night sky or the sun, these are not the right things to do. Because if you have an equatorial orbit, your sun is here, it goes like this, and half the time it sees the sun, half the time it sees the night sky. So you can see night sky half the time, you can see sun half the time, right? It's not ideal. If you go like this, then the sky is not actually quite, you're not looking properly. So there are issues with that. So where do you put them? There's something called the Lagrange points. So there are two Lagrange points for it's a two-body system. Lagrange points are defined for two-body systems. So this is the Lagrange point, the Sun-Earth system. So Sun-Earth system, if you take it on the line, you will have a point where the gravitational forces are balanced. So that's the L1 point. The symmetric point on the opposite side is the L2 point. So L1 point is in between, and it is actually facing the sun. So that gives you an unobstructed view of the sun. And that's where our Aditya L1 payload is. If you want to see the unobstructed view of the night sky, you go to L2. That is where James Webb Telescope is. But you can't stay there. You have to orbit. So generally, these points are stable, but it doesn't. You can't just stay there because it's like a quasi-equilibrium point. So you have to have an orbit. The orbit is perpendicular to the line connecting the two. So the orbit is like this. So if it's the Earth, this is the Earth, this is the sun. L1 will be here, orbiting like this. So when it orbits like this, your spacecraft is looking at, the instrument is looking at the sun, and the solar panel is also looking at the sun, and you can communicate with Earth. On the other side, L2, you have to have a larger orbit so that your instrument sees the night sky. The solar panels are opposite side viewing the sun, so you collect the light for charging purposes, power. So these are generally, you know how to do that. You have to orbit it. And one more challenge with L1 and of course L2 is that you are actually going around a null point. There's nothing right there. So you have to have calculations with respect to ranges right from the Earth only. Distances has to be measured. And then Earth is not stationary, it's moving. So every time you have moving up in the sky. So if you imagine this particular, in this particular thing, the Earth comes on the top. The L1 would have moved to somewhere inside here, right? So in 1 year, if the Earth goes through the entire orbit and comes back to the same point, the L1 would have swept an inner circle. So the instruments up in Aditya space mission will also be sampling the particles and the magnetic field at this place. So you will not only get the in situ measurements, but also look at the sun. So that's how you design a overall mission requirement, the science requirements, because you can do many things. You can do one thing that is a major aim of the mission, but also peripheral things, which all things you can benefit by the whole travel and the trajectory of the space program. So this is about collecting the data, but this is the last mile connectivity, right? Because you have got the data, but how do you disseminate it? So it's important. When I started my PhD 30 years ago, I have to go to an observatory to collect the data, work there. They only have the system where I can read the data. Only that system will have software which can read the data and analyze, then only I can do the science. Now it is not like that. The data democratization has happened. That happened with the help of archival data, availability of archival data. Not only that, availability of the space where you can actually disseminate the information, and also software, how you do this. So all these are available in here. I don't have a similar slide for ISRO, but that's also available. So AstroSat has a data dissemination center and also a support cell where all the software is available. So in principle, you can have a jump start. Even students at undergrad level, even 12th level students are able to do some amount of research because the data is available, the software is available, and with sample small computers, you can do it. So how even amateur astronomers are able to do a lot of programming, a lot of research, and even people who do something else for their profession career, but I'm passionate about it, I want to do something. Let me do some data analysis on tracing some variables, or I want to detect some crazy looking galaxy, you can do it. So citizen science is also possible with it. So why do we do this? Why astronomy is relevant to our existence? Because it is an ancient science. Astronomy was a life skill, because for existence, you need to know the stars, because then only you'll know the time, then only you'll know the direction. Navigation, it was mandatory, because the navigators need to know the stars, then only they will know the time and space. While you go into the sea, how will you know the time and the location? So There used to be challenges to find out the time and the longitude, etc., etc. Otherwise, it's very difficult. Now, do we need it? We have GPS, right? And we have clocks. Now, how does GPS work? GPS is a constellation of satellites which is up in the sky. But they're moving. They will give you relative position. They won't give you absolute position because they need to know where they are. And that absolute positioning system is still given by not by the stars, because we know the stars move. So their calibration is not enough. So we use the quasars, which are very distant, as this is the frame, the actual coordinate frame. It's not relative coordinate system, it's the absolute coordinate system. Second, we also know that the generality of relativity has to be applied for accurate corrections of the locations. So these are extremely important when we wouldn't know without all this. And even for interplanetary navigation, where you don't have fixed framework, you need quasars. The second important thing is the periodic table. So astronomy is important because how the elements are made. You would have seen that the neutron star mergers. It actually could create certain elements which are not otherwise known how to create. So where else can you create the elements other than the centers of stars, or in terms of this kind of high energy events? So the centers, like the previous speaker was talking about 1,000 to 3,000 degree differences. We are talking about million degrees, right? So centers of the stars are very, very hot. So in the case of the sun, we know that it is actually fusing hydrogen to become helium. You can ask me, why do you think so? I don't think so. Can you prove it? How do we know that the sun is producing energy through fusion? So this was a viable answer because sun is producing energy for a very long time. How can you sustain any energy production mechanism for a very long time? Now we do detect a byproduct of this fusion, which is basically I think everybody's sleeping. No. No, it is something which is actually the fusion is happening, something just darts out, immediately goes out without any, not getting stopped by any of the matter within the sun. Neutrinos, yes. So we have large neutrino detectors, and you actually can Kamiokande detector actually can see the entire the sun rising up and setting because it just captures all the neutrinos coming from the sun. So that is how we know that the nuclear reactions are indeed happening there. And sun-like stars and the bigger stars can produce different types of elements within just by fusion up to iron. And then what happens after that? Who created the rest of it? There's a lot of, when the nuclear reactions happen, you have all those neutrons, extra neutrons there. So these neutrons get captured and become bigger and bigger elements. You can have all these isotopes also created because it's not only carbon-12, carbon-13, everything will come. So you can even measure the isotopic ratios. And so this is what happens. So in a bigger stars, you can have layers and layers of various elements being produced inside. And when these stars explode, all these processed elements get thrown out. And that's how the chemistry builds up. And so we are all part of stardust. So that's also a present-day solar system is coming from because certain stars existed before the sun was formed. And then when the material, huge amount of course, the 74% is still hydrogen. So it has traces of all this, but these are extremely important. I don't know, maybe this is very simple for a certain number of people, but I thought it's good to put it in a general context. Now, to give a brief history of where we come from, the Indian Institute of Astrophysics has a long history. And this also is something, I must say, that history of astronomy in the country itself. Because in 1786, there was a thought of an observatory to be set up in Madras. And in 1792, it was set up in Madras in Nungambakkam. And various observations were done. And then I must also point out that there were a lot of activities which were happening there, which include, the finding the longitudes and latitudes of various places. You need observations. Also setting up expeditions to look at the sun during eclipses, because that's the only time you can see the corona of the sun during eclipses. So expedition was a huge thing then. And in around 1856 or so, I'm missing that year, but there was an eclipse in Guntur, which is also held by the Madras Observatory. And there were measurements of the spectrum of the corona, and they found a line we could not explain. And later it turned out to be helium. That's how helium is formed, to do with helio, to do with the sun. So that's the first time it was formed. But you had to do analysis later to figure it out. So there were a lot of interesting experiments done at that time. Then the observatory moved to Kodaikanal in 1899, and that is still functional. And we are celebrating the 125 years of Kodaikanal Observatory this year. And it became, in 1971, Institute of Astrophysics, and we have completed 50 years. We are under the Department of Science and Technology. What do we do? These are the kind of things we do. We have almost all the stations in the south and up in the north in Ladakh, and space-based, 2 of them. So we have the Kodaikanal Observatory, which is the ancient one, which has been mainly used to look at the sun. So why do you want to study the long-term variation of the sun? Because we know that the sun is active. Sun has activity cycles. It's not that it is constant activity throughout the day. It's an activity cycles. We used to think that sun is a stable system, which is actually more or less stable throughout, but we understand that it is not stable. There are activity periods, and during the activity periods, flares and coronal mass ejections happen. We used to also, in tandem, we also see auroras, northern lights and the southern lights, because the particles, high energy particles, get into our magnetic field. Now, that was all about it till about 2000, but now we have more and more space assets, so we need to protect them, because when you have large number of charged particles, they not only affect the solar panels, but also all the instrumentation on board. They all have to be powered down, because if the extra electrons or something like that come in, then everything gets destroyed, right? So you have to protect your space assets. So it's becoming more and more relevant. And what we've done is that 125 years of data, we have actually we have data for about more than 110 years, and they are being stored in photographic plates taken from 1904 onwards. It was very carefully taken and stored, but in last 10 years, we have digitized everything, all the data, and also calibrated. For us, calibration is extremely important, because I can't measure a flux and say that it is 10% error or 20% error. It doesn't make any sense. So you need to know the calibration well. So that is disseminated. We also have established in the Ladakh the facilities and the 2 space missions. We are also party to the 30-meter telescope program. I'll have a few slides on it. These are some of the pictures of the stations. Now, to talk about Aditya L1 mission, so this is the thing happening right now, because on September 2, the mission was launched, and early January, we reached the L1 point, or near the L1, and put it in the halo orbit. Now, the coronagraph is basically it's like you have the sun, you actually block the disk of the sun, okay? Then only you can see the surrounding part. So the disk of the sun, this is the SOHO image. The disk of the sun is, the size of the disk is shown in the white circle, and more place is also blocked, and then you can see this flares and things coming out. The idea is to see where exactly they're anchored onto this on the surface of the sun, and study why they're coming, etc. As a joint mission here. So this is the activity cycle, which I was mentioning about, from Kodaikanal Solar Observatory. So this is, you can see the data starting from 1904 onwards. So this is the famous butterfly diagram, where you can actually see the activity. The sunspots start from the upper regions and then come towards equatorial regions, and they die. Again, it starts. So this is the cycle. You can also see that the intensity area of the sunspots is not the same in all cycles. Some cycles are strong, some cycles are not. We still do not understand. There's still predictions for what will be the next cycle. Now, emission line in corona, I just want to give you, since it's a physics thing, I wanted to just give you an idea of what is that we can observe in the corona, because corona, as we know, is a 1,000,000 degree temperature. We know that the surface of the sun is only 5,500, but the corona is 1,000,000. So how do we end up getting a very, very hot gas out there? Now, how do we trace this hot gas? It's diffuse. So in general, the gas cools down by collision. You can actually have a collisional de-excitation comes down. So you may end up getting some transitions which you're never aware of, because it's a very diffuse gas. So actually what we are tracing is through ion transition, because why? 1,000,000 degree, what will exist is actually ions will still have a transition. Many of the elements will be completely ionized. So ion, and we are looking at these kind of transitions where this is the expected corona, and we have spectral slits, and we'll get these are the different lines, ion 14, 11, and 12. So it's crazy. You won't see these kind of lines anywhere else. So we need to take a lot of information from the atomic and molecular, this is not molecular, but ionization potential to actually evaluate it. And what are we trying to see? Where exactly this ionization is produced and also the intensity of it. So it will give us temperature measurements, as also temperature handles, temperature gradients, as well as electron density, and also how exactly these propagate, these plasma propagates. So this is important because the propagation is telling you how fast or slow it will reaches the other parts, space weather affecting, etc. So these are important parameters into a model of the heliosphere itself. So this is a very complex instrument, a lot of optical elements, a lot of assemblies, because all these lenses are hosted in assemblies. And the most important thing is in order to see the corona, you have to capture the entire light, but you have to put a hole corresponding to the solar disk and take that light out and let only the coronal light come in. So you can see that I'm collecting the entire light and re-imaging onto a place and put a hole there so that is taken out and only the rest of it coming. So that's a very critical alignment and etc. issues. And you can see this tertiary mirror, it is nothing but to actually take throughout the light and that heat to the space. And it produces a lot of heat inside. Thermal management is really, really difficult. And if the thermal management is not done properly, your image quality will degrade completely. So this is the entire thermal arrangements and etc. And then this is the in integration. So it's on an optical bench for alignments. This is some of the pictures. All these facilities are there in a space sciences laboratory. So setting up this infrastructure is quite a bit of a challenge. Not only the trained people to handle it, back-end engineers are quite a bit important. And the other thing before I stop is the 30-meter telescope project, where it's a 1,300 crore project, started in 2014. But we have already completed 10 years. It is supposed to come up in Hawaii, but then there is some issue with the site there. So we hope to start the project in a couple of more years. India has a lot of contribution in terms of hardware, which is like as I mentioned, this 30-meter, you cannot cast it with one single mirror. It's huge. So we split it up into 1.4 segments, size of 1.4, and the number is 492. So India is going to be polishing about 80 or 90 of the segments. And India is also qualified to produce and supply all the segment support assemblies. 492 to be supported in a segment support assembly, and also it has to be aligned every time it goes up. So it's got a segment support assembly, it's got an actuator which will go up and down. It sense the mirrors which are coming down or colliding. So there are 8 sensors. All these are part of it. And this is a multi-nation project. So these are the things which we are doing. This is the segments. This is a clear, blank. It has to be coated. So coating is also India's job. I was heading the software delivery in the initial stages, so common software, because everything has to be aligned and everything has to talk to each other. Because some component will say, I'll go, I need to know whether the previous subsystem is ready to go, then only I can start my work. So it has to be integrated system. And integration is such that from one configuration to the other configuration of observation, eventually the time given is about 2 to 3 minutes, because it's a huge expensive thing to do, so it has to be highly efficient. So how do you effectively communicate without data losses? So these were several challenges. It's a huge software challenge out there. Segment support assembly, this is the electronics part of it, and we also part in several instruments. Now, we have set up a segment support. So this is a segment with a central hole for the center one, and then the hex cut, because you can produce, this is from the the circular blank. You have to polish it and cut it in such a way that it doesn't leave any strain. It just have to be absolutely perfect. So there's a huge technology involved here to how actually you go about in doing it. And how do you even polish it? Because if you have a mirror like this, it's not a spherical configuration. They're all symmetric configurations. They are non-axis symmetric configurations. They're different. The radius of curvature changes, etc. So then how do you polish it? And how do you know what is polished? You're talking about millimeters, nanometers level. So you have to have interferometric skill sets. You have to actually, by polishing itself, you have to measure, configure, and then again polish it. Otherwise, if you take out even 1 extra mm or 1 extra micron, you're lost. You can't put it back. So not only that, handling properly, measuring properly, establishing all the standards and make sure that everybody knows about it. So running a facility is extremely challenging. Here, this complex things which I show here, this is it's called stress mirror polishing. So typically, if you go to a classical way of polishing a mirror, it takes about 1 year for one mirror to come out. So how do I do 80 mirrors? 80 years? Not impossible, right? So you have to have a mechanism which is coming out in 2 weeks, one mirror has to come out. So it's a huge change, a shift in technology, shift in the way you process it. So what you do is assume glass to be glass as a liquid, and then you have to stress it. So you stress it in such a way that you give stress to whichever part you want. It may not be a symmetric stretch, asymmetric stress, so that the surface you need to polish is only circular. So you polish the surface which is circular, you can measure it without any problem. You can calibrate it with another surface, which is actually a calibration mirror. And then you release the stress. Leave it for 24 hours. The surface, what you get is what you have stressed it to. So the challenge of polishing to a very difficult configuration is transferred to stressing, which you can actually measure. So these are the stress ways you actually stress the mirror, and then that has to be calibrated all the time. So this is a completely different technology. We are actually commissioned, and then now the first production is going on. Maybe in another week, we will be completing the first polishing of a 1.5 meter segment in a week's time for the very first time. So this is an engineering marvel, and we have some similar future projects like the National Large Solar Telescope. This is the land which we have acquired on the bank of the Pangong Tso Lake for a solar telescope. The plan is ready, it is submitted, and hopefully we will get it. And I'm heading the next large solar telescope project. The last one, the spectroscopic project, and the Hanley Mountains are the best ones for the large optical telescope. Since we are already having all these technologies for segment polishing, etc., and the industry is helping us with all the segment support assembly, we should be able to have our own large telescope. So that's the plan. I stop here. Thank you.
We have time for questions.
Yeah. No, don't go.
Yeah, so earlier we used to have interferometric techniques that you have an large interferometer, and you do the interferometry on the entire surface of the mirror. So basically what happens is you have something called an integrating sphere, or not integrating sphere, you have a blank. So you used to have towers. If you come to IIA main campus, you have a huge tower where a 2.3 meter was tested. So you have to take the blank out from the polishing mirror, go there, entire interferometry is done. But now we don't do that. We actually have a handheld measurements, and we measure at various points. Even we have touch measurements for various depth, etc., and then stitch it together. So huge amount of software is used. So it's basically interferometry and stitching it together to get the entire profile. And this is not qualified by us. We have to measure and input all these parameters to software. At what conditions, and temperature has to be constant. Temperature should not vary. Even 2-degree change will actually alter the entire measurements. So we normally take out all the people, make the temperature stable. Early morning you measure it, and input all these things to software, and it calculates all the required parameters and then says whether it is qualified or not. No, not required. We have isolated, but isolation, whatever we have done is enough. It's not on we generally do it on the vibration isolation. For the other things are on optical benches, and there are vibration isolation, but this is not that much of required. It's very heavy and not much of, yeah. Thermal is extremely important. What based? Yeah, okay. The no, actually, the only one which is up in space, which is multi-mirror telescope, is the James Webb telescope. There, the primary was taken just like that. Only the secondary was folded. So you can actually the entire thing, the secondary you could take, but this one folding and taking out is too much of a hassle because you have to actually firmly fix it. So this is not done in that. It's only the secondary which has to be unfolded and taken. Yeah.
Thank you, ma'am, for a very interesting presentation. I have one astronomical event-related questions. We
Sure.
all know that the end of life of a star is pretty spectacular in the form of supernova explosions and things like that. Has anyone seen the birth of a star, which probably is also equally violent?
It's not a spontaneous thing like the supernova or the thing. It's actually happens, but in general, when the birth of a star happens, let me start the answer by saying that not all stars die by supernova explosion. Only the massive ones die by, or rather in the thing, because there's an implosion happening in the center, so that sees an explosion. But in the case of lower mass stars, the death comes, or rather the end state comes as a very slow process where the central core shrinks as a white dwarf, and then the outer envelope lifts very slowly. So planetary nebulae happen there. So only the massive stars happen. But when you look at the massive, the one which is dying as with a event, when it at birth it is actually shrouded within a large amount of matter. So you really get to see them when it has actually come to life. So it's a very short process, maybe less than a millennia, but very difficult to observe because we have a huge wall of this material outside it. So we haven't figured out how to look through it and figure out the process of formation.
Thank you very much.
Thank
I
you, ma'am.
haven't spoken anything about my research here. I've just given an overview as such.
Thank you, ma'am. I now request Professor Abhiroop from Department of Astronomy and Astrophysics to kindly honor Professor Subramaniam. I also request Professor Bhargav to kindly join.
It's already connected.
Program, the here.
Now we move on to the next invited talk of the session, which will be delivered by Dr. Vinay Kulkarni from IIT Bombay. He will be talking on managing career, role, and technology changes. I request Professor Venkatesh Vamsi from Department of MEMS to introduce the speaker.
Good afternoon, everybody. It's an absolute privilege to introduce Professor Vinay Kulkarni. After a fascinating talk from Professor Annapurni, let's move on to the next talk. So, Professor Kulkarni is a technologist with over 30 years of experience, professional experience, with current focus on consulting, guiding, and helping companies, institutions, and individuals to develop competencies and capabilities in the areas which are of so much of interest now: data analytics, machine learning, big data, engineering, problem solving skills, and root cause analysis. Currently, he is affiliated with IIT Bombay as adjunct professor in Center for Machine Intelligence and Data Science. He is also a proprietor for VK Consulting and Training. He is also a member of several boards, Board of Advisors, Center for Applied Artificial Intelligence, IIT Bombay, and Board of Studies, and many more. Without any further delay, I would hand over the stage to Professor Kulkarni. Thank you.
Good afternoon. Just give me half a minute more. Let me set up things here. So, okay, it's fine. Good afternoon, everyone. Am I audible at the back? Okay. So after a series of talks which focused on specific technologies or focus areas, I'll be talking a little bit about managing careers, roles, and technology as a whole. That's the focus of my discussion with you all today. I was asked to talk on one of the technology areas, but I thought, having spent some significant time doing many things, which I will try and list on the screen today, it would be more relevant to dwell a little bit upon this topic. So is this topic of your interest? Would it be of your interest? Can we see a show of hands? Okay, almost everyone is interested in career, right? Okay. So why me? Okay, thanks for giving the introduction, but I like talking about myself. So let me describe myself, and at the end of it, hopefully you will agree with me that I am qualified to talk on this particular topic. Okay. So I am a graduate in mechanical engineering. I did my BTech in mechanical engineering, right? After that, I had this question, what to do, right? What were the choices available to me at that point in time? Go for MTech or any kind of higher studies, or join the company, join an organization. So I choose to go to the industry. Right? I was in L&T for a year, working in the area of pressure vessel design and engineering. And that's where I learned real engineering, if you ask me. Okay. While I was in L&T working on this specific area, the resolve that I should go for something higher, try and do and get more educated in a particular field came to me. And I came back to academia to pursue PhD, and in the area of computer applications in manufacturing. Okay. So actually this clarity, came to me when I was working in an organization. If you ask me, did that clarity exist in me when I was passing out? No. To be frank, I did not have it. How many of you are facing this particular dilemma after PhD what? Okay. I see a couple of hands going up. The others, I suppose, are very privileged. I mean, it would be nice to talk to you about the clarity that exists in your head about what to do after you finish this particular course or this particular phase of your life. Okay. Sorry. Yeah. So completed my PhD and of course got that same question once again, right? But I was very clear. But I also wanted to hedge my options. Okay. Can you be absolutely sure that you will get this job or you will get that job? You will not. Does that create any kind of stress in anybody's mind? Yes, right? So the solution to all this will come up a little while later, but we all face this uncertainty, right? We are not sure about whether we want to go here or we want to go there, but somewhere we have to decide. So I also hedged my options. I had an option to go into academia again as a teacher or as a researcher, but then I chose to go back to industry. And I spent about close to 20 years in the industry. Okay. And as part of that journey, I assumed roles, various roles. Of course, it started off with contributing to technology development, then leading technology development. Post that, and this usually happens in the Indian context, you take on managerial positions, right? Then you take on a business-oriented role, right? So if I look at my stint in industry, all of those things happen. Starting with technology development, technology leadership, being able to look at businesses as a whole, understanding the running of business. Okay, did I have any training for it as part of my career prior to that? No. Does that create stress? Yes. How to handle it is again what we will talk about later, right? After spending significant time in the industry, I saw there was change in technology happening. I decided to get into analytics, machine learning. I mean, not by accident, because we were using these things, and in the industry, I was working with software development, with applications in manufacturing, which was a continuation of my work that I had done in PhD. Okay, in that sense, I have been a bit fortunate. Okay, so this new field, so to speak, kind of started exciting me, right? Analytics, machine learning, artificial intelligence. So around 2013, there was a shift which happened, and I decided to stop my journey completely only in the industry and got into consulting, right? And after that, since then, I have been switching between or doing these two things simultaneously, consulting and academia, right? So now, do you believe that I'm a little bit qualified to talk about career change, role change, and maybe advise you a little bit or share with you? I mean, I can't really advise, but share with you about the journey that I have had and my experiences. Okay, do I have your attention? Okay, great, right. So now that I have told you about me, I would like to understand about you. So take out your phones, and this is a 1-minute poll that I would like you all to take. Okay, and this is linked with whatever we are going to talk about, right? Be true, be frank, because this will form the basis of our discussions. Okay. And at any point in time, if you have questions, note down this. You can just shoot your questions anytime and we'll take them up at appropriate time and answer them. Have you all noted this link? Okay. So what am I going to talk about and what am I not going to talk about, right? So the title of the talk is Managing Careers, Managing Roles, Managing Technology, Technological Changes, and so on, right? But can I really advise anyone on their career options or the roles that they're going to take? We are all extremely different from each other, right? So if I give you that flowchart, the flowchart which I drew or my life journey which I have drawn, is that applicable to you? Obviously not, okay? So am I going to tell you about the benefits of working in academia or working in the industry? I'm not going to do that, right? Because I'm nobody to tell you what is good for you. That you have to figure out on your own, okay? But when I took certain decisions, let us say 30 years back, and I have been through the journey now for 30 years, I can take a step back and look at certain common aspects or certain common problems that we all face, okay? And then talk about those problems and look at how we can resolve those problems, right? So what I will talk about is some aspects which are very general. I will not reveal them right now because they will get revealed as we go along. But in the end, I will summarize and you will see that there are 4 or 5 points that we need to keep in mind. Okay, so be on the lookout for those 4 or 5 points as we get into this journey, right? Okay, so now let us look at the poll and what you all have to say here. Okay, so this is some of the responses. So, what we can see is that most people are between or 60, almost 91% of the people are more than 23 and about 60% are more than 27 years of age. So that is fine, right? Years into the PhD program, most of you all have completed about 3 years. So between 3, 4 and 5, maximum number of people are there, okay? And this is your choice that you have taken. My preferred career choice, academia. Certain people have said industry, very few, as you can see, okay? And not yet firmly decided is the last option, where almost 40 people have expressed their choice, which is what would be expected. I mean, which is what I would have expected, right? So those of you who have extreme clarity about what you want to do, perhaps you are very fortunate, like I told you earlier, okay? For the remaining people, what is it that we need to do? Okay, so I will just take this. And put it here, right? So point number 1, do we plan long term or do we plan short term? Okay, again, it depends on your personality, okay? So obviously the first thing that we need to understand ourselves is what is our persona? What is our persona? Do you all understand the term persona? It is a set of qualities that we are made with. Okay, certain bent of mind, certain experiences, certain events that have happened with us. Okay, some of us may be willing to take more risks. Some of us may not be willing to take too many risks. Okay, to which category do I belong? Do I belong to this category or do I belong to that category, right? And there are no fixed categories over here. So the moot point here is, what is my personality? Okay, am I extremely clear about what I want to do, or am I not very clear about what I want to do, let us say 10, 20 years down the line? Is there anything right or is there anything wrong with either of these? No, you are what you are. And the point here is to understand your persona and then decide or take your decisions accordingly. Okay, like in my case, I can very frankly say that thinking 20 years or 30 years in advance was not possible. So what did I do? I applied the concept of greedy algorithm. Do you all understand greedy algorithm? Grab whatever seems best with the limited visibility of the horizon that I have. Okay. Is there uncertainty involved in this? Yes, there is uncertainty involved in this. But the moot point here is taking responsibility for this particular decision. Okay, I have taken this decision because I am aware that I cannot handle too much of thought process about the future. So hence, given the situation that I am in, and broadly given the path that I want to follow, this is the decision that I have taken, right? So whose decision is it? It is my decision. Am I driven by circumstances? Probably yes, but circumstances have not made me take the decision. Okay, I have taken the decision. So moment you get into this particular mode, your anxiety level or your stress level actually reduces. Okay, so you may have a view of 3 years or you may have a view of 5 years. Okay, like for instance, you may want to go ultimately to academia, but you are not sure about whether you really like industry or not. Okay, so the short-term decision that I can probably take is, yes, I will go to industry, I will see, I will look. So I go back to my own journey. After my graduation, I wasn't sure whether I want to go into research or I want to go into industry. But I decided at that point in time to go to industry and understand what is involved there. And that gave me a perspective. So that brings me to another point. My experience has been that whatever you do actually helps you in the future. And this has happened multiple times that I can put forward to you in the form of a rule. Okay, whatever you do actually comes back to you in a positive way in your future, because that helps you to take future decisions also, right? So what are we saying here? We are saying that uncertainty is a way of life. Okay, so instead of getting stressed by it, embrace uncertainty, incorporate probability into your decision-making process. Okay, make it your decision. Don't play the victim card. Make it your decision so that you own the decision. And the direct benefit of all this is you become more creative because your energy is not wasted thinking about all those 110 other things that you are not in control of. Okay, and at an appropriate time, you make another conscious decision that I continue in this field which I have chosen, or I want to now shift my field to something else. Okay, let me tell you one thing here. The training that we all receive as part of doing a PhD is extremely unique. The only question is how effectively do we use it, right? And again, to reveal my experience, it has given me immense confidence over the years. And as I pass more years, I have more confidence in my own ability to jump into different fields and understand what is going on in that field. Like for instance, since I also act as a consultant, that is one of my roles, you get thrown problems from different fields. They could be from electrical engineering, from chemical engineering, process plant related optimization problems, or electrical engineering, transformer related problems, or even architectural engineering, warehouse design problems. Okay. Am I an electrical engineer? No. Am I a chemical engineer? No. Am I an architect? No. But the confidence that the process of doing PhD has given me is that I know if I spend a certain amount of time, I have the capability to get into the depths of that particular field, understand it, understand the terms and terminology that my customers are talking to me about, and speak in their language. Okay. So the years that you spend doing PhD actually is extremely helpful in building a set of skills. And many a times we are not aware of that, right? The question that comes to your mind is, okay, we have done this now, next what, right? Believe me that you get into whatever you want, you will be able to achieve it. And that is possible because of the years of independent research that you have spent. Okay, so that is point number one. So if I were to write here some things, I would say take 100% responsibility. Okay, take 100% responsibility. And remember this, because once you do that, like I mentioned, your level of creativity will be very high. Okay, I just like to give this example that if you're walking down the road and you find something not correct, maybe a dustbin is overflowing or whatever, right? If you start blaming the municipal corporation or the government, okay, your mental state changes slightly. Okay, you are dissatisfied. You say that somebody is not doing their job, right? Now, at that point in time, if you think about the choices that you have, what can you do? You can either clean it up yourself, or you say that I can very well clean it, but it is not my job. I can get somebody who's responsible to clean it. So whose responsibility is to get it clean? My responsibility. Okay. Or I can make a third choice, saying that I know things are not good or not correct over here, but I do not have the time for it right now. Hence, I choose to ignore it. Okay. So you have responsibly taken a decision, 100% responsible decision of yours to overcome that particular situation. So if you follow this particular path, what happens? Your mental state is not disturbed. No stress is being created in your mind, and you are able to function with full creativity, right? Does this appeal to you? In some sense, try to take 100% responsibility. It is not easy. Okay. And what is applicable for your career is also applicable in your personal life. Think about it. Okay. So keep this in mind and look at how you can take 100% responsibility for your career and for whatever we are going to talk about next, that is roles and managing change and so on. Okay. Now, let us look at preferred roles here. Now, as per this, most of you have chosen academia, research in academia, being a teacher, researcher in industry, tech leader in industry. But obviously, the bias is towards academia or teaching. Okay. Now, what if an opportunity comes and lands in your lap, where you have to make a shift? Okay. And this is where I would like to pose a problem in front of you, right? Suppose a problem gets thrown at you and it requires you to get out of your role in academia and take on a different role. How comfortable are you doing that? Right? What are the choices available to you at that point in time? Saying that I don't want that particular role. Okay. But if I tell you that that role will have a greater impact than if you continue in academia. How will you make that choice? So isn't there a conflict that is getting created over here? Right? Now, why do we get into conflict? Many a times because we are not multifunctional. Okay. And this happens when we get deeper into solving one specific kind of problem. Okay. So what I mean by multifunctional is, do I understand other aspects that are very important to us? Okay. And that is where, I had my next question over here. Okay. So the first question was obviously, what is PMRF? That is just to establish the standard. Obviously, everyone knows what PMRF is. Okay. Now, in the context of PMRF or related to PMRF, what are the other terms and am I aware of them? Okay. Now, why am I bringing up this particular point? Are you setting up yourself to be flexible enough that you can take on other roles other than the ones that you have now chosen? Okay. Is there a guarantee that you will continue to like whatever you have chosen right now? Okay. Now, let me also ask you one relevant question. Everybody is saying that India will be growing at whatever 8-9% growth for the next X number of years. Okay. What does that mean to you? How do you align yourself with the growth of the country or contribute to the growth of the country? What does it mean to your profession? What does it mean to your personal finances, for instance? Right? Is it a relevant question or not? Okay. If I'm going to be in my own well, everybody will pass by. Okay. So how do I make myself flexible enough that I'm able to grab opportunities? So there are certain specific skill sets that seem essential. Okay. And one should make a conscious effort to acquire it. Like ma'am mentioned, setting up of certain centers. What does it require? What kind of leadership qualities does that require? Does it require financial savviness? Does it require people handling skills? Okay. Now, there are two ways to acquire it. One is wait for those events to happen. Second way is throw yourself into those situations. Grab those opportunities as they come along. Okay. The third one is, educate yourself and be ready for it. But, the third one is learning for learning's sake. It doesn't get imprinted in your brain, right? So what is the best way out? While you are pursuing your basic interests, don't let the other opportunities go by. If you get an opportunity to lead certain technology development project, for instance, grab it, and in the context of that, pick up certain skills. How to ensure that the project is financially viable. How to ensure that the project gets managed very well. What are the skills required? Because when you learn these skills within the context of an overall goal that you have, it sticks to you. And then you can reuse it later on. Okay. So the point here is be aware of opportunities, and not only be aware, throw yourself at those opportunities. And that will force you to learn. Okay, that will definitely force you to learn. It will create momentary stress. Like for instance, when I took on a business-oriented role, did I have background in business? No. It took certain amount of time to understand what business means, what one needs to do to ensure that sales happen, there is profitability that is achieved. People do not quit your company and go away. Manage human resources. There are so many things that come into play over here, right? So So only when you throw yourself at these situations can you really learn some new skill sets. And what are the best ways to do it? When I was in this situation, for instance, we had to attend, let us say, weekly or weekly long or a fortnightly long program at one of the institutes like IIM, for instance. So these are known as short-term courses, which introduce you to all these other skill sets that you necessarily need to have if you want to run a business. Okay, but nowadays the scene has changed completely. You have so many non-contact online kind of courses available. So there is much more choice, right? But the basic thing is throw yourself at it. Grab the opportunities that come by and don't let them go. Okay? So when it comes to roles, my suggestion would be to okay, that is how I would like to summarize this particular part. Right? Becoming multidimensional, I have already talked about, but let me get this particular quote here. So being multidimensional means to have various facets, qualities, or aspects to one's personality, abilities, or character. It suggests that an individual is not limited to a single perspective or skill set, but rather possesses a range of diverse qualities or capabilities that contribute to that individual's richness as a person. Being multidimensional implies depth and versatility, indicating that one can engage with different situations, roles, or challenges in a nuanced and adaptable manner. That is very important. Okay. It's very easy to not do all this because we get complacent in our career, in our roles. Okay. But then I will ask you another critical question. How will you give back your training that you have acquired? How will you ensure that that reaches out and has the maximum possible impact on the community, on the society? Okay, do you want to keep it to yourself, or you want to ensure that the training that you have received has a much wider impact? Okay, and will you have that wider impact only if you do what you like or what is needed by and large by the country, by the society, and so on, right? So today, if I have taken on a teacher's role because I feel that it is more relevant. I can share whatever I have understood to a wider set of audience, right? So that is a conscious choice that I have made. Okay. Can I continue to be only a consultant? Yes, I can continue to be only a consultant, right? But I also want to look at a wider impact on society that I want to make. And this is particularly important for everyone. As I mentioned earlier, the training that you get while doing a PhD should not be kept to yourself. Okay, you are capable of doing much more. Understand that, understand your personality, and see how you can make it applicable in a much wider context, which basically means how you can take on a leadership role. Okay. So coming to technology, let us look at what your responses are. I use tools to efficiently keep myself abreast of technology, okay, which is very good. I have used one of whatever, AWS, Azure, Google Cloud, okay. Now, let me give the technology related journey of a person like me. Okay, when I entered college, we had to do programming in assembly language, right? We did programming in languages like Fortran. Then we shifted to C, C++. Then, other programming languages, more recently Python. Okay. And now what is the situation? You don't need to know any programming language. Of course, that you need to take with a pinch of salt, because now tools are available where you don't necessarily have to remember the syntax of a particular language. What is the skill set that you need? Of course, you need to know what programming is all about. Okay. But now you need to have the ability to express your problem in your own language or in a language like English. And then there are tools available which convert your problem statements into code, right? So these days when I talk to students or when I give them assignments, I very, very clearly tell them, I'm not going to assess you on your programming skills, right? In fact, I encourage students to use the large language models and generate code. Many a times I give them the code myself. Okay, where is the challenge? The challenge is in understanding the core of programming. What does programming mean? And being able to read and understand the code that gets developed. And even before that, being able to express the problem in a manner that the tool can understand. Okay, so from assembly language programming to large language model, that is the change that I have seen, at least in my journey so far. Okay. Again, while interacting with students, and with this, I come to a very important aspect of technology. Technology is definitely good, and it improves your productivity. Okay. But at the same time, it makes you blind. Okay. What do I mean by blind? How many of you know machine learning? Some of you. Okay. So machine learning has become so easy these days, right? You have libraries. In fact, you have drag and drop tools where you just drag and drop the data and then you get some models which are fitted to that particular data. And you say that, okay, lo behold, I have created a machine learning model, right? But the question is, how many of the people understand the statistics behind the ML? How many of the people are able to convert the numbers that get generated as output and explain it properly in the context? Okay, the point that I'm trying to make here is whether it is ML or tools like ChatGPT, do we really understand what is behind those tools? Right? Either we do that or we are consciously blind to technology. I have a couple of friends who say that, I will not use UPI. Okay, I will not use UPI. Why? Because, there may be fraud on me. Is that a solution? Is that an option anymore? We need to ask ourselves. So we need to embrace technology, but at the same time understand how it works so that in times of difficulties. So, the other day there was an exam and it was an open book, open internet kind of exam. But the only restriction we placed on students was no collaborative software can be used. Collaboration software can be used. And we had a brainstorming session prior to the start of this particular examination, where the teaching assistants and we sat together and we brainstormed about what could be the different ways in which people could cheat in the examination, right? And that led to the requirement that we should not allow people to use collaboration tools. Other than that, anything is okay. Okay, so we were very clear that we want people to use large language models to generate code as part of their examination, but we don't want them to cheat and copy. Okay, we were surprised, and we had not factored in this particular thing, that people are so dependent on technology that they did not know how to install these tools on their own laptops. So that became a big hurdle, right? So the point is, if you are caught in this kind of situation where there is no internet, for instance, or you could be in a conference room where network doesn't reach. Will you want to be at the mercy of technology? Okay. So our advice to students was, look, make yourself independent of such weak links that you may encounter, right? Which basically means use technology, but also be aware of what can go wrong with the technology and acquire the skill set to take other paths so that your basic work is not hindered. Okay. So here we have, I extensively use LLM tools, and then I understand how LLMs work, right? So not surprisingly, that is slightly smaller than I use LLM tools, right? My question to you is, why are you not using LLM tools? Okay, why are you not using LLM tools? So when I did my PhD, for instance, literature review or literature survey was a mammoth task, right? Probably you will start wondering, how did these guys do their PhD? We had to write cards to authors, post them. That would take a couple of weeks to reach the authors. The authors would send their papers to us. That would take again a couple of weeks. So by the time we discovered the existence of a paper and we got a chance to read them, 3 months would have passed. Right? Can you imagine the situation now? Okay. So now if you look at it, you have tools. I mean, you can download the papers, right? You can download the papers, but that is also not the point that I'm trying to make. Today you have tools which can very well summarize the papers for you. So you don't even have to read the papers. Does it mean you don't have to read the papers? Well, you have to read the papers, but you can get a bird's eye view of that paper, understand what it is, and then get into the depths of the paper. So my question to you is, why are you not using the large language models? Okay. So again, many of my colleagues say that we should not allow students to use large language models. Why? When they go out and they want a job or they look for a job, is it more likely that the person who is aware of the tools and well versed with them, will that person get a job? Or a person who is not well versed with the tools, will that person get a job? And what is our responsibility in this? Giving the right kind of skill set. And this I'm mentioning to you because many of you have expressed the desire to go into academia and become teachers. Okay, do you want to become a bottleneck in the path of the students? Or do you want to embrace change? And mind you, giving access to the internet during exams places a huge responsibility and a huge challenge on the instructor, because the instructor has to then create that kind of paper and then has to evaluate that kind of paper, right? But if I don't do that, am I not failing in my job? And if I want to do it, should I not understand that technology to the core? Okay. So LLM tools use should be as large or even more larger than in size than the last bar that you have here. Embrace the technology. Be careful about it, understand it, and use it. Okay. Again, it doesn't help to be in a kind of well where you are protected from all sides, right? How many of us are aware of quantum computing? I did not ask the question here. How many of us are aware of quantum computing and what it means in the future? It is probably around the corner, right? There is a lot of research happening in quantum computing. Okay. Can we project what is going to happen? What are the next tools that are going to come over and above these large language models that exist today? Okay. How am I, or what am I doing to keep myself abreast of the technologies? Okay. So I'll tell you a simple tool that I use. I know the power of LLMs, okay? And hundreds of news items appear every day for which I have a RSS feed based tool, which gives me a list of topics, events happening all over, all that. And I have a filter which takes input from these articles and converts them into 5 or 6 line summaries of what is happening. Okay, like for instance, so this is probably a 200, 300 page article, so a 200, 300 word article, okay? And there are 100 articles which get generated like this on a daily basis, right? And this is just one of the topics that I follow, okay? How do I make myself more efficient? And this wonderful job is being done by an LLM tool, right? So am I using technology in the right way? Am I keeping abreast of use of the latest technologies? That is a question we need to ask ourselves. Again, not because we want to use the technology or anything, because we probably are responsible to others, to our job, to our students, to the community. And if we don't show that kind of leadership, then probably we are not doing justice to the training that we've had. That's where I am coming from, kind of. Okay. So I'd just like to summarize by putting these 4 or 5 points in front of you. Take 100% responsibility. That will simplify your life, right? Embrace uncertainty. Think about failures. If you don't think about failure, then what is the probability of failure? Isn't this a very simple question? If you don't think about failures, what is the probability of failure? 0%. It will hit you hard. It will be 100%. Okay. Whereas if you incorporate the probability of failure into your planning, okay. I suppose everyone knows about the Johari window, right? We have a blind spot. There are many things which we don't know that we don't know, okay? And this particular window should be as small as possible, which means we should bring all those unknown things into the realm of known, okay? So my suggestion is, when I say take 100% responsibility and embrace uncertainty, I would start by saying, put a number on the probability of failure, okay? Maybe the probability instead of 100% comes down to 50%, but at least you are aware. You have incorporated that into your planning step. Maintain creativity. So now, once this happens, you are very clear about the possibility of failure. Okay, you have put some number on it, that is fine. But you are aware of the possibility of failure. And now your focus should be on how do I reduce that probability? Who's responsible for it? Me, right? So I am responsible for it. I am responsible to ensure that probability comes down to the minimum or even becomes 0. Strive to become multifunctional. Okay. My basic area of research, I am an expert. Some people say that PhD is like knowing more and more about less and less. Okay. And in the bargain, knowing everything about nothing. That's a joke, by the way. Okay. But am I neglecting something? Do I need financial savviness? Do I need people handling skills? Do I need project management skills? And most important, which I haven't mentioned so far, how good am I at communication? Right? How do I understand what see, everybody has a customer. If you are a student, PhD guide is your customer. Okay. Are you understanding what your PhD guide says? Or is your PhD guide understanding what you are saying? Or both of you are talking some different languages? Right? and at least PhD guide and you can break your head over each other in the context of your college or institution. But imagine yourself sitting in front of somebody who's paying you money to understand them and deliver the goods. How important are your communication skills, right? It comes under this multifunctional skill set that you need to develop. Financial skill set, tool skill set, human resources skill set, in addition to your core skill sets that you already have. How do you do it? Throw yourself at the situations, because there is no better way than that to, it's like me saying, jump into the well and you'll learn swimming. Okay, with some training, of course, right? Take leadership roles, you have it in you. Consciously be aware that the training that you are going through is a wealth that you have. Use it, okay? And that gives you certain responsibility. Redeem your responsibility, right? I have done a PhD. What does it mean? What does it mean to be? What can it mean to others? Okay. Now here is one advice. Let people know you from your work, not from the degree that you have. Okay. They should say, oh, this guy, sometimes people discover that you have a PhD. No wonder, I've already seen that person's work, right? So redeem your responsibility towards others, and that's a responsibility that you should consciously take and shoulder. Embrace technology and also dig into it. Okay. So don't say, I don't want to use UPI. I don't want to use ChatGPT. I don't want to use whatever comes up next. Okay. Use it, but don't use it blindly. Right? You will probably never have the time to understand what the technology is all about, but you need to take out time. Otherwise, somewhere it will hit you. Right? There have been so many cases where people have lost money because a QR code was presented to them and they scanned it and money went out of the bank when they were to receive money. Okay, and this has happened with even people who are so-called educated, tech-savvy and all that. Why? Because the process wasn't understood. Similar is the case with machine learning. Okay, I use Python functions, I create the models, but then I am unable to explain what the model is trying to tell me. Right? I use ChatGPT, but I do not know the limitations of ChatGPT. The worst thing that can happen, and which I keep emphasizing to the students, is, moment they are given a question paper, they pass it through ChatGPT. Okay, worst thing to happen, right? Because you are not applying your brain over there. The better thing to do would be understand the question paper, break it down into specific questions, and then if you send those questions one by one to ChatGPT, maybe it will be able to help you, right? So right use of technology in the right way is absolutely critical, and that will not happen unless you dig into the technology. Okay, so that's the kind of sharing that I wanted to do. Now let me see if there are any questions that people have asked. So 1 second. Yeah. Okay, so nobody seems to have asked any questions. So if you have any, what are the opportunities available for student completed PhD in physics, research field? Okay. Hydrogen production. Now, I'll give you a simple answer. I'm not qualified to answer this, right? How will I know? I cannot be a know-all, right? So it is beyond my scope to answer this particular question. Okay. We don't seem to have any other questions. So is anybody having any questions? Maybe we have 5 minutes. Yeah. Yeah.
So I'll take the second one first, that the clients will not be sticking to me and not giving a constant stream of work, right? Why will that happen? If you do not deliver what they expect you to deliver. In whose control is that? It is in your control, okay? So if you are delivering whatever you have promised or what the customer or client expected, then there is no reason why the client will move away from you, because to the client also it is a cost moving from one provider to another provider. Cost in terms of both time and money, right? The first question that you asked about visibility, okay? So that comes back to the aspect of being multifunctional. So unless you throw yourself in that situation, probably you should ask me another question. Okay, when I quit my job, how did I, or why did I quit my job and I was sure that I will be successful in consulting, right? That is a bigger question here. The second question, of course, is what can you do to ensure that you are visible, people know you, and then you get a stream of work. Okay, so learn marketing, learn communication, right? It won't happen by magic, right? So you have to learn marketing. So you have to utilize those channels. Maybe it begins with your friends, people that know you, and you declare to them, yes, now you are open to taking up jobs on your own or assignments on your own. And they're recommending to their organizations or somebody else. So you can use a private channel. And then there are so many other avenues that are available today. You can become highly visible on one of the social media, for instance. Does that answer your question? Right. So, you know, that happens or that happened basically because I was already in the field, right? I was already in the field delivering certain kinds of products and services to people, and you have a sense of the market, what will work in that particular market. And that gives you a starting point to begin with. And then, of course, the question that you asked is extremely relevant. How do you make yourself visible? Okay, so the simple answer to that is yes, you need to learn the tricks of the trades of marketing yourself, right? So the need of the market is what you have a pulse on, right? And that also did not happen by chance. It happened because I was already in the market in the sense of providing products and solutions to companies. And I knew what was the need of the customers at that point in time. Is that okay? Yeah. Thank you very much.
It's really interesting. I just, as a teacher, I would like to know that how do we bring this 100% responsibility sense in students? Because we live in a climate where it's very easy to say that this thing didn't happen because of this particular person or this particular set of circumstances. So I would like to think like a student that how do I become 100% responsible for my...
Not easy, not easy, not easy, except, you know, keep emphasizing this fact. Okay. I have a very big problem in students sticking to their time, valuing the time. Simple thing, like let us say coming for a meeting. Okay, it's extremely difficult in an academic setup to get even a small group of students or people to come to a meeting in time. But then who's responsible for it? I am responsible for it. So be at it. Keep on emphasizing again and again, and you will observe the change. The change will ultimately happen. So you need to keep on emphasizing that, look, this is not okay, and this is how it needs to happen. And saying that students are like this, what can I do? No, because it violates that rule. Whose responsibility is it? My responsibility. Very simple. Yeah. Yeah.
Stay away from getting into that. Because if we reach to a certain depth, then only we'll have something of my own, and it will be such valuable.
Correct. So if you observe, what I also said was, I agree with you that, just because I want to be to understand the stock market, or I want to understand how to run the business and how to manage finances, I just keep on reading about it. Of course, that may help to a certain extent, right? But the best way to learn is, if you recollect what I said was, throw yourself at it. Okay. So many a times we say that, I don't want to do it because I don't know how to do it. What I am telling you is, boss, you know everything. You know how to get into a new field, understand that new field. You have done it in one domain. So you have the capability to do it in another domain also. Okay. So that doubt which you have normally should go away. You should have the confidence when you get out of your institute that I have done my PhD. I didn't know about it 4 years back. Now I know so much about it, right? You give me another problem to solve. Now that problem could be in any domain. It could be in finance, it could be in human resources, it could be in marketing, whatever. I have the confidence that within a couple of weeks, I will develop the skill set to be able to do it. Okay, that will force you to get into the depth of it. Of course. Yeah, but then, if you are not getting into the depth while doing PhD, then when will you? Okay, what I'm trying to tell you is, even if you have spent only 3 years or 4 years while doing a PhD, you already have gone into the depths of certain small domain. Okay, that is a wealth of abstract experience that you have got. So extrapolate that confidence into other fields also. Take leadership positions. Yeah. Did I say that? Did I say that? I will not say you should leave or you should not leave, right? If you don't like your research that you are doing and doing it for doing sake, and if a better opportunity comes, then you yourself will decide to take that other opportunity. Okay. If you are liking the research that you are doing, why will you shift to something else? But I will rephrase your question. Okay, while you are doing a PhD, let us say you get the opportunity to lead a team of people, right? Will you look at that as a hindrance or will you grab that opportunity? Because then that will expose you to your communication skills, your people handling skills, right? You need to understand people's psychology. So treat them as opportunities. Does that make sense? So nobody is asking you to, keep dropping things left, right, and center. So, don't misunderstand me, please. Okay, yeah.
It's now becoming that foreign PhD versus Indian PhD. More specifically in this context, the PMRFs.
Okay.
Sir, if the two candidates are supporting IIT, for example,
yeah,
and both are having the equal capabilities, one in the Indian perspective, and another is the foreign perspectives where they are exposed to some more advanced technologies. But still, sir, the Indian students within the resources which were available to them managed to still survive and now produce something which is very much respected. Now, sir, both candidates are approaching an institute. So, sir, I have visited one website of IIT, I will not name it, but they proudly mention that we have X percentage of faculties from foreign universities. So you will get a world-class experience in this institute if you join. But sir, if we PMRF approach over there, then because of this advertisement, we are at the stake where we will lose entering to that institution because we will not be those persons who will provide them the world-class experience because we have the Indian experiences. Sir, in these circumstances, what is your opinion? How we should present and stand and bring this another perspective that the Indian perspective will also be of that significance and should not be ignored.
I will only tell you one thing that, maybe it gives people a particular platform. or a starting point. Okay, maybe they will be able to jump into the water. Okay, so the foreign PhD will jump into the water and an Indian PhD will also jump into the water. Okay, but finally it is how well each of them swim that really matters. So my point here is that yes, given the current circumstances or the current focus on certain need to have certain skill sets, and I don't think it is basically because you want a foreign PhD or anything like that. It is basically because you want a differing set of ideas so that there is no inbreeding that kind of happens, right? So people are very good to judge about your work that you have done. And if that is of good quality, and most importantly, you are able to communicate it, there is no reason why anybody, I will not call it Indian PhD or foreign PhD, should get selected. Okay. In fact, if you ask me, that has been my experience, right? So let your work speak for itself. You should not now take that mindset of Indian PhD or foreign PhD out of your head. Okay, let that no longer be a hurdle in your thinking process, right? Incorporate, replace it with certain probability in your mind. There is a 0.2 probability that I'll be not getting this job because I am an Indian PhD. Now your focus should be, okay, now what do I need to do to reduce that 0.2 to 0? That will answer your question. Who's responsible? Yeah. See, I mean, I will not speak for what others are doing. Okay, I will share my experience with you. And again, I will emphasize that if you are good, okay, you will get what you want. Now, the question is, how do you communicate that you are good? Okay, so two things are important here. Ensure that you are good, and secondly, ensure that you communicate it well. So listen. Now you want to get into this particular institution that has come out with an advertisement, right? Okay, so why don't you look at an alternative? Shine there, and then these people will call you back. Why do you want to get stuck with the fact that this institution is not ready to take me? Is that a solution? See, many a times we get bogged down by these thoughts, because again, you are trying to place the responsibility for your potential failure on somebody else. Take control of that. Don't let anybody else be responsible for your life. Okay, 100% responsibility. See, my answer to all questions will be 100% responsibility. And it is a mantra that works. Right? Why are you stuck up with this particular institution? Zid le lo na. I will go do something else somewhere, and then they'll be foolish not to take you back if you have done a good job.
Thank you, sir. So
it's a wonderful presentation, Professor Vinay. Yeah, I think, probably you're in I don't know which institute you're talking about, but at least, I can say that IIT Indore doesn't look at which PhD, where he's from. At least, I can say that. Because, in fact,
no, most importantly, I'll say, doesn't matter which institute puts out this advertisement. Okay, you have 1,000 other alternatives available. Yes, so look at the other alternatives positively, but of course,
because we look for good people.
Yeah.
So it doesn't matter where you do your PhD or something. We look for good people. Yeah.
thank you, sir. Now I request Professor Ishwar sir to felicitate the chief guest.
Thank you.
Thanks very much. Yeah, take it out. Thanks very much. So was it useful?
Thank you. Now, yeah, we can proceed for lunch.
Yeah, proceed for lunch. I think there is a poster session. 3 o'clock we'll meet for the post-lunch session. Talk by Professor Kamakoti on translational research, followed by Dr. Dr. Padma Venkat Satish on IP and patenting, which is also very exciting sessions both are as good as this. Yeah.
Suppose இந்த mic இங்க வச்சுட்டா இந்த
Good afternoon, Professor Kamakuti. We will get the session started in 5 minutes because the students are on the way up from lunch. Sir Kamkoti, are we audible?
Sir, this is from Professor Kamkuti's office. The director will be joining on a couple of minutes, sir.
Yes, yes. Are we audible? I think he's going to join first.
Yes, you are audible.
Yeah. So please let us know when Professor Kamkoti joins. We will get started the session.
Yeah, fine, sir.
Please, yeah.
Hello? Hello? Hello?
Good afternoon, Professor Kamkoti.
Yeah, sorry, I was in another meeting with the ministry, so I got a bit delayed.
No problem, Professor Kamkoti. Let's start it since you joined. So
Yeah.
I invite Professor Ayan to introduce you briefly, so that
Yes,
we can
yes,
get
yes.
started after that. Yeah. Professor Ayan.
Yeah. Thank you, Professor Kamakoti. So it's my privilege to introduce you. So Professor Kamakoti is the director of IIT Madras. So he's the man behind India's first indigenous computer microprocessor Shakti, which is a industrial grade processor aimed at embedded application, robotics controllers, and Internet of Things. So to start with his academic background, Professor Kamakoti received his MS and PhD degree in computer science and engineering from IIT Madras. He joined as a faculty at IIT Madras in 2001 and took over as the director in January 2022. He specializes in the area of computer architecture, information security, and VLSI design. He heads the microprocessor development program and the information security education and awareness program at IIT Madras, which is funded by the Ministry of Electronics and Information Technology, Government of India. He is a member of the National Security Advisory Board. He was also the chairman of the Artificial Intelligence Task Force, constituted by the Ministry of Commerce and Industry, Government of India. At IIT Madras, he has served as the chairman of JEE and as the associate dean, industrial consultancy and sponsored research. He has over 150 publications in international reputed journals and conferences and guided many research scholars for their PhD and MS who were in various position and who are doing good, reputed in the community as well. He also has coordinated successfully and delivered close to 50 projects from the industry and government of research and development establishments. He serves on the Technology Committee of National Stock Exchange and Reserve Bank of India. Professor Kamakoti is the recipient of DRDO Academic Excellence Award, Indian Economics and Semiconductor Association Techno Visionary Award, Abdul Kalam Technology Innovation National Fellowship, ACCS Lifetime Achievement Award, IBM Faculty Award, and Vasvik Industrial Research Award. With this short introduction, I'll request Professor Kamakoti sir to enlighten us with his talk on translation research. Thank you, sir.
Thank you very much. And I'm sorry I could not be there in person because today we have the All India Research Scholar Summit at IIT Madras. We just launched it this morning, the first time. We are getting around 200 research scholars who are coming here from multiple institutions, not just the IITs, but IISc, NITs, and other places, wherein we really want to look at, solutions that are much relevant for our country, and that will pave way for a very clear path towards, technology superpower. And that is the interest why we started this AIRSS, the All India Research Scholar Summit. The first edition was inaugurated this morning at IIT Madras. So I'm very happy that this PMRF workshop is happening at Indore. Thanks to Suhas for enabling this, and also thanks to the entire organizing team. PMRF has been a very important program for the IITs and all the other benefits, all the awarding institutions. We had quite number of people who have benefited by this, and we are really seeing a very interesting growth in the way research is being done. More than the money, it adds a lot more prestige. It also has other facets like, going and teaching in other places, other institutions, involving yourself with a little more of social bent of mind. And all these things add a lot more value to the PMRF. So we are very happy that we are successfully completed the first phase, and we sincerely hope that PMRF 2.0 will continue. With this, friends, what is it that we are all Prime Minister Research Fellow? And so what is the vision of our Honorable Prime Minister in the interest of the nation? Now, when COVID struck, that was a big eye-opener for the entire country. So many things have been imported from foreign countries in terms of simple medicines to medical equipments to many other things. And there were also a particular period, many of you know vehicles, two-wheelers like TVS 50, which is the Benz of the poor, okay, the poor of the poorest. Even for these systems, the electronic control unit was not available. So these are all real eye-openers for as a country, where we are looking at different critical emerging technologies, and we are not able to find solutions in the country, and we are ultimately dependent upon foreign countries and the foreign market to basically serve us. Thank God, the vaccine, again, thanks to all the biotechnologists and bioscientists, put in a lot of data analytics, etc., what was thought as a 10-year program to get a vaccine for COVID. We got it within 2 years, and certainly, lot of, not even 2 years, less than 2 years, a year actually, 1 year in terms of serious development. And today we have done 2.5 billion vaccinations, and more than 1.2 billion we have actually exported to other countries. So, friends, when there is a need, right, necessity becomes the mother of innovation, and that is something which, as a country, we have been successfully doing. As a Prime Minister's Research Fellows, what we expect is that you start thinking about what will be our country, say, 20 years down the line. Many of you would have been in the age group of 20 to 30. Now you will remember something which was 10 years before. From 10 years before till now, what has happened in your field of specialization? If you can understand the change, now you can see what would be the change from now on to the next 10 years or 20 years. And if you can get out with that type of very interesting analysis, now you will understand that there are a lot more things that need to be done in terms of solutions, right? These are not going to be just papers. I'm very careful in my word, just papers. Of course, you need to publish, but this has to lead to solutions that work and solutions that scale, right? So, because we are now looking at a billion population, right? So we are looking at solutions that will scale and the solutions that should work and scale, okay, right? So this is something that we need to keep in mind, and we need to see what is the impact this technology will have on a common citizen. And that is also something very, very important. When you select your problems, when you select your research problems, when you select even the topic of your research, I think that must be aligned with what the society needs today. In that way, the Sustainable Development Goals 1 to 17, as prescribed by the United Nations, actually form a good starting point for you to start planning your career. Friends, I strongly believe that in the next 10 years, recycling job, basically aligned with the Sustainable Development Goals, will supersede or will be more rewarding than the now traditional coding job, right? So there'll be a lot of emphasis on sustainability as the climate starts changing and as the humans start facing issues. We must come out with solutions that will help them sustain their living. So that is where there will be a very great market for sustainability, will also bigger solutions will emerge here. So we need to look as the recipient of this prestigious fellowship, you need to look at our country's need. And I personally believe that local relevance will lead to a global recognition. We need to be locally relevant for a global recognition. So what does local relevance mean? So I'll give you some examples of problems that had gone on from, say, an ideation to innovation into a startup. And that hopefully will raise some sort of an enthusiasm or give you some very interesting case studies of how this can be explored. So I'll give you two examples from IIT Madras. One example is a septic tank cleaner, a robot that cleans septic tanks. Today, the Honorable Supreme Court has very clearly said that manual scavenging must be removed from the country. A human being should not be used for manual scavenging. There are people who lost their life because of manual scavenging. So all these things were very, very clearly articulated in one of the judgments of the Honorable Supreme Court. Now we have a solution for that, which is a robo, which you can, it's also portable, and you can take it to the spot, and it can go and clean any septic tank, clean any blockages in sewage, etc., etc. So this is something extremely useful and important. And this particular problem, though it sounds very simple, it has at least three to four patents, and 2 to 3 research scholars have worked to get this whole idea. So though the problem is very well easily defined, the solution has been extremely complex in this entire process. So this is something that that's a very interesting example of an immediate social need. Okay, this is about running day-to-day life. I will now take something which is slightly away from running day-to-day life. Is that today we are now in 5G. The 6G will be a hybrid communication model. There will be some amount of data that goes to the satellite and beam back from the satellite, and then there can be some, there can be certain there can be certain transmission of data that happens on the terrestrial network also. The 6G will be a combination of satellite communication and terrestrial communication. So some part will be used for transmission to the satellite and beaming it back to the Earth. And after some point, it can also be through a fiber cable, which will take it to the necessary destination, etc. So this is something that we are envisaging. So if you want to do this type of hybrid communication, where we are looking at satellite and we are also looking at wired communication, there is a need for us to launch certain low Earth orbit, 350 kilometers around from the sea level, low Earth orbit satellites in the near future. And assuming, so there is some statistics which basically says we have 120,000 satellites are necessary in the next 5 years, assuming each year has some 56 weeks, or let us say, to be very conservative, say 56 weeks. So now we have, say, 5 years, it is around 300 weeks, right? That means in 300 weeks, if we have to make 120,000 satellites, so per day, per week, I have to make 400 satellites per week, because that will translate to 120,000. So per week, if I want to do 400 satellites, and today we are looking at, say, let us say we work 7 days a week. So per day, I have to make 50 satellites. Each satellite will have 4 engines. So per day, I have to make 200 engines. So this is a sort of, the budget proposal that is there for low Earth orbit satellites, which can be primarily used for 6G communication down the line. Now, how do we send this? So every day I have to send, say, 4 satellites. How will I print the rocket engines for it? Somebody has to carry the satellite. It can't just go on its own to the low Earth orbit. So that means I need what you call as rapid launch facilities. The rapid launch facility also means I need to make these rocket engines that can carry it. And today, rocket engine will take around 3 months to come to a final shape. If you do in a normal way. Now, when we go and have a slightly different outlook, where I go and 3D print these rocket engines, then we can do it much quicker. So, friends, IIT Madras has a incubated company which 3D prints rocket engines, and that basically it's called Agnicool. And these 3D printed rocket engines can be quickly assembled to make a rocket in which the satellite can also be loaded and the satellites can be launched. So 3D printing of the rocket engine, where each engine is printed within within a period of 48 hours. So 2 days they print the engine, but the detail for this delay is also the whole thing can work much faster. The details of this delay, reason for this delay can be the availability of these printers. So if I'm going to put, say, 10 printers, I can even print 40 engines at the same time. So this 3D printing of rocket engines, the first ever patent in the world, one of our teams from IIT Madras has got. So what I'm telling here is an example of a translational research, and that has actually yielded patents, papers, etc. But very importantly, it gives you a working solution that is scalable. I did mention about the delay. So now if I have one, the delay will be quite significant, because we need to make, say, 200, 300 per day. So how do we do that so put some 10 engines, 10 3D printers, and each one can make print 4 rocket engines per day. So we can print off, say, multiple rocket engines in a single day. So these are all some very interesting solutions and solution to problems, specifically in what we call as the critical emerging technology. So friends, so today we need to, if you buy a mobile phone, I'm sure all of you have, and you spend, say, some 100,000 rupees, 20% of it, 20 to 30% of it goes to the vendors as royalty. So around 30,000 rupees is for royalty. And if the royalty is increased for a particular segment, then many of the rural India people cannot even buy these phones. So given this, it is very, very important that we need to have many patents done. And these patents are going to protect your idea and also give leverage to the country. Suppose I am holding a patent and somebody wants to take that patent for hiring or take those patents. We own these patents and somebody wants to take those patents to make product. Now, that will be very, very important, because now we can control what could be done, what could be delivered, what could be told out, etc., etc. So we really get into the market. So patenting is extremely important if we dream of a Viksit Bharat 2047, a very progressed technical technology superpower India in 2047. It's very, very important that we start very seriously looking at these aspects. Now, last one that I really want to talk about before I open up for some questions is, how do we go about this entire process? So I'll give you the case study of IIT Madras. Somebody comes out with an idea. We have something called an entrepreneurship cell. This cell will basically take that idea. Look, there'll be some mentors from the faculty who look at it, what is new, etc., etc. Then this idea is being sent to the industrial consultancy and sponsored research cell. A patent cell is there. So the patent person will look at this idea and basically take it through an AI-based tool. And the AI-based tool will take the idea and search all potential databases, patent databases across the world. And if it doesn't find a match, then it comes back and say, okay, this patent is fine, we can go and file it. If it is actually infringing on other patents, it will also tell you which patents it is infringing, so that you can actually make a informed decision of revising your proposal. So in this way, this patenting itself is going to help research scholars to come out with multiple ideas. Because I submit an idea, if the engine is going to give you several competing ideas that are published across the world, so you get to know more and more about that area by filing such type of patents. Okay, so this is very important. Once this is done, then they are moved on to the Center for Innovation, where this idea essentially gets transformed into a design. After that, there is one more incubator, pre-incubator called Nirman, where these the design goes from ideas going to a design in the first stage. The design essentially now becomes a prototype in Nirman. So these are places where a lot of mentorship happens. After that point, there's an incubation process. We have 5 incubators at IIT Madras. One is the mother incubation cell, which is overall responsible for the incubation activities. Then we have one more incubator for cyber physical system, one more for health technology innovation center, and then we have one for bio incubator, and then we have one for the overall one for the rural technology based incubator. So 5 incubators are there. So yeah, idea comes to the E-cell, they allow them to patent it, then they send them to C5, the Center for Innovation, where this idea basically gets translated into a design, and then the incubator converts, the pre-incubator converts this design into a prototype, and then finally this translational research part is taken by the candidate to the next stage of incubating through a company. And then we have the Gopal Krishnan Deshpande Center, which will mentor these companies and take it forward. So the entire what we call as E&I stack, the entrepreneurship and innovation stack that we have created here. And this is what is necessary preliminarily for for innovation to happen in the country. And unless innovation happens in the country, we will all be technology dependent, and the dream of becoming Viksit Bharat will become a very difficult task. So this is what I thought today I could present to all of you. If there are some questions, I'll be very happy to answer that. Thank you very much.
Time for a few questions. Yep, there's a question from there. So please tell your name and institute and then department and ask question.
Hello, sir. Good afternoon, sir.
Yes.
Yeah, I'm Aman Srivastav, PMRF from IIT Kharagpur, from Civil Department. Sir, I have a master's from Sitara IIT Bombay. And sir, I found that the platforms like rural development centers have a potential to bring the applications from core branches like mechanical, civil, electrical, etc.
Yes.
And then, sir, I again came back to the core branch of civil engineering, and I am able to bring the impact from my civil engineering works in rural areas as well. Sir, I mean, Bombay, Kharagpur, and Delhi, I can see there are dedicated branches where masters and PhD programs are available. Sir, I mean, IIT Madras is, I guess so, not having master's or PhD program so far, dedicatedly in rural development center, etc. Sir, what is your mission in this regard, and how would you like to bring this?
The IIT Madras has what you call as a rural technology based incubator, where these many startup companies which actually cashed on the rural technology has come here and graduated. We have GUVI, which is actually a teaching startup that made a teaching platform for rural India with multiple languages and other things. So I don't know can you just repeat the last part of your question?
So, means like masters and PhD program can be introduced. I mean, it's high time that
introduced in what?
In rural development technology, rural development center.
In rural technology, you want us to introduce a master's and PhD. PhD is actually possible. There are a lot of people doing PhD in on children and on many aspects of child life, right? So that is already happening. But the other question of I don't know, but the other question of trying to say that there should be an MTech program and PTech program on this, basically on the rural technology. I think that we need to look at very carefully, because whether it is rural technology or urban technology, it's, the engineering is the same, right? I don't, of course, I may not see certain things used in Chennai. For example, it's very hard to see a tractor, but I see that left and right in my village. So the type of things that we can put there in a rural environment might be different from an urban environment. So this is also one very interesting observations that we need to keep in mind. But trying to have a full-fledged MTech program in rural technology, right? Do we have the material? That's the question, right? So we need to have some strong material, because once you give an MTech in rural technology and there is no MTech in rural technology, where will we give MTech in rural technology, but then there is no job offer or job description for this. What will happen to this MTech student? So these are some very important concerns. We also see that many of the PSUs are very sticky about what we put in the degree certificate. And so they may say, though he's a well-trained civil engineering student, but then if the degree doesn't state that, then it's going to be a difficult task. So I fully understand that what you are making is a sort of multidisciplinary type of proposal, but certainly it'll need manpower to basically champion it. And I'm also sure that as a system, it does not. It needs to progress much more to become a separate MTech in rural technology or a BTech in rural technology.
Thank you, sir. Thank you.
Yeah, one more question.
Thanks for the talk. My name is Rakesh. I am from Mechanical Engineering Department, IIT Bombay. So I have a quick question, like what is the time frame for the issue of a patent from the application to the receiving the patent? I know the scenario previously, it was around some 2 to 3 years, but I would like to know from you.
Yeah,
what is the
so
present scenario?
today we have something called expedition, where you need to pay 4,000 rupees, and the total cost for it is total time for it is 18 months. So just to tell you today, I'm very happy to tell you this year's grant has touched 366 today, because this financial year, for the April 1, 2023 to March 31, 2024, we are still having a month. We have touched 366 today. So that's one patent a day grant wise, and this also is something around 300 plus our patent filing. So today you get it within 18 months max from the date of you filing. There is a process which will make it within 13 months. You will get the whole patent awarded, or the decision will be conveyed to you, whatever award or not award.
Okay, sir. Thank you.
Yes. This clause is called expedition clause. I want every institute to basically, it's no pretty cheap. It's only 4,000 rupees. So I strongly suggest that people must take the expedition route to see that that patents are given out at the correct time.
Thank you, Professor Kamakoti. I think following your talk, there is a detailed talk on IP and patenting by Dr. Padma Satish, sorry. So she'll be talking about all these probably. Thank you for quickly clarifying that, Professor Kamakoti.
Yes.
Any other questions? Yeah, Professor Kamakoti, I have one question because it's good to see the progress you stated about this 3D printing of the activities that is going on IIT Madras. So what kind of ecosystem or what kind of curriculum you're providing so that these students are coming up with such innovative ideas?
Yeah,
so how do you...
the point is that we have this C5, which is Center for Innovation, run by the students.
Yeah.
And that essentially basically has some 10 to 12 clubs. And we are now just working on the curriculum task force. And we are also trying to bring an entrepreneurship route for people who doesn't want to do studies and who doesn't want to, they have ideas, they have multiple ideas, they want to consolidate the idea and take it forward. So we now have a curriculum in which 40% electives can be just drawn from out of the department. Only 60% of the course, total course, will be with the department. The remaining thing can be out of the department. So this is also something that we are looking forward that we basically use for some of our entrepreneurship and different things. Like people would like to go in different routes. One want to go to industry, just settle to earn some money and go off. One want to go to academia, spend a lot of time growing beard and just coming back and then doing a PhD and then coming back as faculty. And then there's another path which says, they would like to just not bother about studies, but they want to basically become entrepreneurs. So these three, we are seeing the distinction. And for people who want to become entrepreneurs, we are trying to get a curriculum. Now, IIIT DM Kanchipuram, Professor Sudhir Varadarajan, he's heading a committee which is now doing training for innovation and entrepreneurship in institutions across the state. So this is very, very, very important there for us to take it forward. Yeah.
So probably a follow-up question to that. So anybody comes up with an idea, so there is a small grant or something you provide to them?
Yeah. So essentially for the incubated startups, we provide some initial grant plus space plus mentorship, etc. And so for this particular training of trainers, which we are trying to do with Sudhir Varadarajan's team on developing next generation entrepreneurs and leaders. That's the program that is funded through the Malavia mission. We are trying to basically see that when the ideas come to some crystallizing stage, there are many angel investors who would like to put some money here and take some equity in return. And that is now currently being enabled.
Thank you, Professor Kamakoti. There's one question, last question. Is it possible to take a question?
Yeah, sure.
Yeah, please. Yeah. Introduce yourself and then speak.
Hi, sir. Good afternoon. I'm a PMRF fellow in Mechanical Department, IIT Indore. So I'm very happy with this fellowship, and I think this is about a great initiative to support and encourage students to do PhD in India. But what I'm seeing here also, lots of us after PhD, whatever I'm seeing for postdoc, they are preferably they want to go outside India. Maybe it's USA, Japan, whatever. So there can be one initiative so that we can stay in India and do even my lots of professors in IITs, they did their postdoc from outside. Right, sir? So
okay. I am a director without a passport.
Good, sir.
Yeah. I know that.
We have examples here who have been completely left out. See, abroad gives two flavors. In my days, when I saw even my class, I studied in a self-financing college for my BTech, B affiliated to Madras University. Even in my class, those IITs people do get into abroad seats. But even in a private college with the first batch, right, we were seeing around 95% of the students went abroad. Out of 60, only one wrote GATE, two wrote GATE, and one succeeded and got into IIT, and that's me. So out of 60, 58, around 55 went abroad and 3 went to management and 2 continued in India. So this is the statistics of a self-financing college in 1989. Now that things have changed today. Like now we have only 5%. If I just look at the graduated class in the last 3 years, only 5% of those graduated class have a abroad address. All the others have Indian address. So this is from our alumni database. Okay. So this is one part. The next thing that you have been asking here is about alluring. At those days, we did think that people are going abroad, teaching, etc. But when we started looking at critical emerging technologies today, when we want to set up some semiconductor fab, etc., I found that establishing a semiconductor, I work in the area of semiconductors, establishing a semiconductor fab is something like there are some 20 to 25 very serious steps. And in each of these steps, we had people who have worked in the globe and have that expertise. So what we thought was as a brain drain actually turned out to be a brain gain, right? In some sense. So this is something that we need to keep in mind. The exposure abroad can certainly enhance the value of the faculty, which I believe. But they must come back and start contributing for the country, for the development of the country.
Thank you.
Thank you. Thank you, Akash. Yeah. So there are no further questions. So let's thank Professor Kamakoti for enlightening us on the translational research and the activities that is happening at IIT Madras. So Professor Kamakoti, we have a small token of appreciation for your presentation. So this is can be shown, right?
Yes.
Yeah. So this is a Maheshwari shawl.
Oh, wow.
It's made in local weaver. So we are going to send it through the PMRF team who are here so that they can hand it by tomorrow actually.
Sure,
Yeah.
sure. Absolutely.
Yeah. Thank you, Professor Kamakoti.
Thank you.
We also have a small memento from IIT Indore.
Oh,
so
thank
this
you.
also going to give it to them by tonight.
Sure, sure. Thank you.
Thank you, Professor Kamakoti. Thanks for your time.
Thank you.
Yeah.
Hello, sir. Hello, sir. We are not. You are not audible.
Okay.
Sorry.
Am I audible?
Yes, sir. Thank you.
Okay. So it's an intangible property, which is a creation of the mind. And just like how you can own property and you have a mechanism for, claiming the ownership, it also has value and ownership like tangible property. And then what the intellectual property right is the legal right given to protect the interest of the creator or the person who has actually created this intellectual property. So just like, you have registered your property in a certain way with the registrar, etc. Same way, there are lots of legal frameworks which allows you to own an intellectual property through various forms of intellectual property rights. These are called as IPRs. So what are the kind of IPRs? I'll explain some of them in detail later, but just to give an idea, if you have an intellect which is treated as a property, a right is given as the intellectual property right. And if you have a creative expression that you would like to claim ownership on that you have created, the right associated with such kind of creativity is called a copyright. And if you have created an invention, which has got some unique features, I'll come and explain to you what they are. That's got a right called the patent right. And any aesthetic appearance, a creative aesthetic appearance, like a certain design of a cup or a saucer, which is very unique and innovative, those kind of intellectual property or creativity are given a right called the design right. And if you put in certain efforts and create a quality with which you want to be associated with, like IIT Bombay, for example, or IIT Indore, these are brands. So these are all, immediately you can say that what it contains. So these are called as these kind of recognition given to such kinds of, activities or efforts, and the quality that comes with it are given a right called the trademark rights or the service mark rights. And sometimes you want to have very proprietary knowledge or information which you want to keep secret. Those are covered by a right called the trade secrets. So these are basically some rights which come along with intellectual property. Why protect intellectual property? I mean, now it's very good to talk about IP, academia, etc., but why do you want to protect IP? Because it gives you a reward that you have created something which is unique, which is innovative, and you are the owner or you are the creator, and as a result, the legal framework, the government would like to award you something or reward you something. How? By giving you a monopoly to those rights. And it encourages innovation, because if you sort of, you do something and you can claim that it is owned by you, you can do a lot of things. Just like if you own a home or you own a car, you can do a lot of things with that, and then you get sort of incentivized that yes, it's worth working towards owning a home or owning a car. So there is an encouragement for innovation by giving you an ownership, and avoids reinventing of the wheel. So it's not very simple. I mean, you can't just say, oh, I own a patent, so it's mine and nobody can touch it or something like that. There are lots of legal frameworks, but it also, just like literature search, patents and other IPRs are available in the public domain. So the general researchers who have done something, the other researchers can look at it, read at it, and then keep following it and doing some other enhancements or advancements, not reinvent the wheel. It's basically like non-patent literature, what we call. Patent literature is also a very important aspect, which allows you to see and understand what is already existing and what you can do better and advance further. Global competitiveness, obviously any ownership you have, then you are able to share it, you're able to sort of, get acknowledged for it, and it brings in competitiveness. And when you have a portfolio of such IPRs, that shows your expertise and your ability to sort of, have knowledge and, strength in that domain. And that will also allow you to get awards, you get investments, you get funding. If it's a business, you get more investments. If it's academia, you get more funding for research, etc. So there are lots of benefits for which you need to protect the intellectual property that you have created. Why intellectual property in academia? What is the role of academia? Train skilled manpower, take up education, and of course, research and development. Not just basic research, but also applied research. So what does this result in? It results in scientific knowledge, ideas, and innovations. What do you do with this? You don't just generate and sit on that. It's important to reach those research outputs to the public and also capitalize on the intellectual creativity and assets, as I said, for various reasons that I mentioned earlier. Hence, in academia, IP is very important during teaching. You have copyrights coming in during teaching material, research, which are covered by various products and processes covered by patents, outreach activities. When you go outside, you have to see what you own and what you share with others. R&D collaboration. When you're collaborating with a partner, be it another academic partner or an industry, how do you handle who owns IP? How do you handle these ownership matters? That is important. Technology transfer. So if you have an own technology and you're trying to transfer it to some industry or an entity, then you have to understand what are you owning, what are you giving, and what are you expecting out of it. So these all become very important in academia, just the way in businesses, it's also important. Entrepreneurship, which now like every academia, like in all of you, you may have developed something very important and you may want to create a business out of it. You may want to have a startup out of it. That time, the IP becomes very important to understand, to see what you've generated. Is it protectable? Who owns it? How can we take it further? How can we give back money or, revenue generations or sharing of revenues? All these are very important in the academic also environment. And as I said, like earlier, it provides incentives, ownership, it gives you monopoly, allows beneficial linkages with industry, and it's a recognition for the creator and the university to attract research funding and promotes entrepreneurship. These are very important, maybe cliched, but these are very important aspects for IP becoming so important in academia also. So just to give you an overview of all the various intellectual property rights, which are typically used in a technical institution, there are many. So I'll just give you a list. The intellectual property is basically divided into industrial property and artistic creative works. That's covered by copyrights. And the industrial property is covered by patents, designs, trademarks, trade secrets, geographical indications. I'll give you a brief on what this means. Protection of new plant varieties, layout designs of semiconductors for ICs. These are all various kinds of rights, but typically in an institute, we would use patents, designs, trademarks, copyrights. These are the main things that are usually seen in institutions across. Okay, what is the legal framework that I mentioned? Each of the IPR has a certain criteria for protection. When I talk about patents, I'll let you know that. Then there is a period of validity. Typically, no IPR. Why is legal framework there to give you ownership? So that after a certain period of monopoly, it becomes open to the public, and the public can work further on that, use that to advance technology and move forward. So there is always a period of validity and geographical limits. You cannot say I own a patent globally. So a patent has certain criteria whereby you can own it only in certain jurisdictions or certain areas, certain country specific country-wise. Then enforcement features. What are the do's and don'ts that you can do with it? Like if you own an IP patent, what can you do with the patent? Or how can you benefit out of it? How can you restrict people out of it? So these are all covered in the legal framework for the patent kind of things. And the ability to license and transfer and various other legal implications like, infringement. What would you, if you don't do certain things, how can it become invalid? What will happen? All these things are covered by various legal framework for these IPRs. Just to give you a brief, there is a World Trade Organization, and then there's a World Intellectual Property Organization, which is a global specialized agency of the UN, administers various treaties and harmonizes national IP legislation and procedures, also provides services for international applications of IPRs. So this, if I start explaining, each of this can be covered by specific sort of, talks, but I'm just giving you a gist. I'm more than happy to make this talk available so that you can use it and understand, and any questions, you're more than welcome to ask me anytime. And in India, you have the Copyright Act, the Design Act 2000, then the Geographical Indication and Goods Act, then Information Technology Act, the Patents Act 1970, which was amended later on, the Plant Variety Act and the Semiconductor and IC Act, and also the Trademarks Act. So these are the main acts which are so-called the legal framework which govern the various intellectual property rights that are given to the creators or the owners. Okay, so now coming to, sorry, I may be a little fast, but please do ask questions if you have any doubts or any time, please ask questions. What is a patent? Very important. Each of these words mean a lot. They have a lot of meaning associated. It's an exclusive right granted by the government to the creator or the owner to own or use an invention for a specific period in a particular jurisdiction. So you can see all the points have been covered. It talks about a monopoly to a creator or owner, and he or she can use the invention for a specific period in a particular jurisdiction, in a particular country. It also means they can exclude others from using it. That means they prevent others from using the technology or the IP that has been generated by these creators. What is it given for? It's given for an invention which is a new product, machine, apparatus, or an article, or a process, method, or manner of manufacture, or a substance or a product produced by manufacture using the process. So this is what it's given for. And what are the main criteria for patent, for getting a patent? Novelty. This is one very important, what they call as, completely new. This should be completely new and not part of any existing public domain information. No technical solution should have been published or a product obtained through the technical solution be in the market, or the technical solution otherwise be known to the public. That means there should be an absolute novelty standard. So what does it mean? Suppose you want to file a patent in India, let's say, and you do a search and you find that there is some patent which has been filed in US. Now, that means your novelty is being compromised. That means it is already available in the public domain. So your patent cannot be filed or granted. So you cannot file a patent application. Same way, if you yourself on your work, you have published in a journal, or you have made a presentation at a conference or in a symposium, let's say, and tomorrow you suddenly, out of like all the discussion, you find that yes, it's got innovative aspects with criteria eligible for patenting. So let me go and file a patent in the Indian Patent Office. When they do a search, it goes through what is called as an examination. When they do a search, they would find that it's already published in the journal and by you yourself. It may be by you yourself, but that would be treated as so-called prior art or existing information, and so it will be treated as ineligible under the novelty criteria. So please remember, it's very important all the time, like in academia, publishing is very important. It is possible to publish, but it's very important to file for a patent application so that you can claim towards protection and then go and make a publication in any which way that you are interested in making. The second one, which is a little subjective, but the most important criteria on which a patent can be granted or not granted, of course, other than the novelty, is the feature should involve a technical advance as compared to existing knowledge and should not be obvious to a person skilled in the art or familiar with the subject. This is called as non-obviousness or an inventive step. That means you cannot, I'll give you an example to drive home the point what non-obviousness means. And then it can be incremental. So nothing like no invention needs to be like a disruptive or brand new invention. It can be small incremental enhancements, incremental improvements. As long as somebody skilled in the area or a person who's expert in the area cannot immediately decipher, yes, this is very obvious. So this is what you have to try and prove when you file for a patent application and when you try to defend a patent application as to how yours is inventive. And the third criteria, which is of course important, is invention must serve an industrial purpose. So you may develop a technology which is very good, very nice, very important, and very unique, but it may be very, very expensive compared to the existing technologies. So that has got not much of a utility value, right? So that may be grounds for the patent office to reject a patent application. So it has to have a proper industrial utility. Yes, yes, please. Yes, please. Publication. Not at all, not at all. Because, so this is also, there have been case studies on this. So let's say you file it today, okay, and then you you submit your publication also, and it comes out, say within 2 months. Okay, this in fact, like Professor Kamakoti said, do an expedited examination. Suppose you didn't do that. This gets taken up after some 18 months if you didn't do that. 18 months later, when the examiner does the prior art search, he would find your own publication, right, as the prior art. So then they will see the date of the publication and the date of filing. So that would help them to say that, okay, it was not prior art on the date of filing. So your date of filing of the application is a very important matter. Okay, so some examples, day-to-day examples of patterns is something I like to sort of share because, you know, at least to get a connect. The safety pin. It's just a small piece of, or a thin piece of steel wire, right, with a pointed edge. It's very commonly known, very routine, nothing very big about it. But somebody thought of twisting it in a certain manner, putting a clasp on the top, and that has given a very unique kind of a product, the safety pin, which has tremendous value and tremendous use. So it's an incremental kind of an innovation on an existing piece of steel wire. So that has been given a patent application. The same way, even simpler is the gem clip. It's just it's just a long piece of wire. You just twist it. In fact, like he said, you know, Professor Kamakoti, what is it? Need is the mother of invention. There was somebody who wanted to join certain papers together, and they were trying to put some clips or something, some piece of wire. And in the process of twisting the wire, they came out with this unique way of twisting, which allowed them to hold papers together. And then they improvised on it, made more advancements and all that, and then they filed for a patent application, and this was granted a patent. So you can imagine how much benefit he derived out of it by getting a patent, using it, and allowing others to use it for a fee through a licensing model or a transfer model. He has given it to various entities to be able to use it and then give part of the benefits back to the inventor. And in the process of this, you've also seen so many new varieties. There are so many innovative and novel kind of gem clips which have come. This is the most basic. So that's what the patent allows you to improve and improvise and come out with more innovative products in the society. The can opening mechanism, the Velcro. The Velcro has a very interesting story, you know, of a shepherd who went in the Swiss Alps with his dog. And there were small pieces of what they call as burr, you know, the bushes had these small hooks kind of things which was sticking to their fur, the dog's fur. He could remove it and he could put it back. So this got him thinking, and he started looking at, you know, he created some small nylon bristles and then did this kind of a thing and then came in with a Velcro finally, and that was patented. And it has use in space and as very low-key, your shoes, everything, and up to the space level, it has use. So it's just to give you a connect, like how simple kind of thought, simple kind of innovative creativities or thoughts and ideas can generate, you know, like such kind of products which are capable of being protected by a patent application. Post-it pads, barbed wire, all these are day-to-day examples that you would be able to relate to, saying that how these have been granted patents and made benefit also in the long run. What are the rights conferred by the patents? To make, sell, use a product or a process and exclude others from using the same. It is granted to an applicant who can be a creator or inventor, like an individual person, or an owner. The owner can be you yourself, or if you have assigned it to somebody, that person or that entity can be the owner. And they can practice, they can give license and transfer to others through appropriate agreements. And also you have the right to initiate legal proceedings against infringement or unauthorized use. So if the government has given you a monopoly, tomorrow you see your own product being used by somebody, you can file a case in the court and then take them to task and, you know, get some damages and all done. This is very common in various of these, you know, semiconductor industries, the phone area. Every area you'll find infringement. So these are like bread and butter of a lot of attorneys, you know, these kind of infringement and damages. Term of protection, 20 years. So you get a monopoly for 20 years. Jurisdiction is territorial. If you file a patent in India, you get only a patent and the protection in India. So it doesn't mean you have a global patent or US people can't use it. There may be your competitor who can use it in the USA without asking you, without getting any inputs or, you know, any kind of a license from you because you have not filed it there. There are, of course, a lot of global agreements, mechanisms by which you can file foreign applications. These are again long, detailed ones. Can give you a lot of information on that. But essentially, it is jurisdiction based. You have to file in every country you're seeking a protection in. Just an example of how a basic looking, you know, stitching sewing machine has now improved into very complicated machines and handheld kind of machines also. Like I said, there are criteria for patents, but still, even though you may meet those criteria, there are certain inventions which cannot be filed for a patent. And these are like frivolous inventions, use of which is contrary to public or moral, like morality, against morality, discovery of scientific principles like Archimedes' principle, Newton's law, etc., method of agriculture or horticulture, process for medical diagnostic treatment. Many of them are listed. Just to give you a basic mathematical business methods, some of these are actually a subject matter of another IPR. They are not protected by patent, but maybe they are subject matter of a copyright kind of a thing. Any presentation or invention which is duplication of traditional knowledge. There are a few of these kind which are not possible to be patented. Patent protection process, briefly, filing process. You have to file an application in the Indian Patent Office. Somebody was asking me today about the early filing, and Professor Kamakoti also said. So you have to file with various, it's a document with fulfilling all the criteria. There are global agreements, as I said, which allows processes for seeking protection across various, countries that are called Convention Foreign Applications or PCT, etc. So these are all available on the net, and you can read all this in the ipindia.gov.in site. So what is this document? What do you file? You have all the forms which are administrative requirement, but you have to have the technical specification or the techno-legal document. What does it contain? It has a title, of course, of your invention, bibliography, literature, what is available already that you have overcome, what field your invention pertains to, and what is the background. As I said, what is existing, what is the lacuna available, and how your technology is improving it or bettering what is existing. Give a detailed description of all the invention with all the information, including drawings, diagrams if you need. One very important aspect is when you file for a patent application, you get protection for what you are disclosing completely. If you hide something, you will not get protection for that. So that is why, when you talk about IP management, you think about what to do. You have to weigh between a patent application or a trade secret. Do you want to keep it confidential so that it gives you a benefit and nobody knows what your technology is about? Or do you want to give a complete disclosure so that you get monopoly and anybody can use it through a license from you? So claims. So in a patent specification, you have to give what is called as claims. So you have to claim what invention you have made. And this is the heart of the patent and scope of your invention, which you are seeking a legal protection for. Protection is accorded to only what is claimed. So for example, if you say a furniture with 3 legs, you are claiming something for a furniture with at least 3 legs. Now, with at least 3 legs can mean a stool, it can mean a chair with 4 legs, it can mean a table with 4 legs. However, if you said a chair with 3 legs, then your protection will be limited only to a chair. A chair with 4 legs will not come under your patent protection. So somebody can develop or manufacture a chair with 4 legs and not need to come to you for any license. So you have to be very careful what you're claiming so that gets accorded a proper protection and an abstract, of course. So to take care of your novelty, like again what Professor Kamakoti said, as part of the process, you have to do what is called as a prior art search. That means to understand and to find out whether there is any invention which falls on the invention that you have developed. There are many free searches, on the Space Nest, Google, Indian Patent Office, various free searches are there. And also there are paid searches. So academia, typically what they do is they try to purchase paid they call it as prior art search facilities. And then they run the invention through that prior art search to see that there is no invention which is the same as yours. So that is what is called as a prior art analysis to ascertain the novelty. So when you do this and you're very clear that you have done this and then you submit the patent application, your patent will not get rejected because of a novelty problem. So that is why. And if they do reject, you can prove and you can also defend as to why yours is novel. So this is a very important matter for academics. When you're trying to file a patent, you're trying to disclose your invention, to do a prior art search. Okay, so this is again a very important slide from again the academic point of view, from our experience, what we have seen, the due diligence for patenting. What are the due diligence that we should take for patenting? The research output should satisfy legislative criteria. Your research outputs may be very good for a publication, but you have to ascertain that it meets those 3 criteria if you want to file a patent for your research, if you want to file a patent also for your research. Identify inventors. Inventorship is very important. My next slide will talk about it, because just like in publications you have authors, in patents also you have inventors. And why inventors become very important? Because when you license your patent to an entity and you get revenues in the form of royalties also, they're all shared between the inventors. And when you talk about 1 rupee also, coming in, then all of us become very strong and very opinionated, and we feel we have contributed the maximum to such inventions. So inventorship is very important to cover. Conduct prior art search. Avoid public disclosure. Like you said, whatever you do, please file. So just to give you a brief going back, there are 2 main kinds of patent application. One is called the provisional application and the other is called the complete application. The provision is when you have just gotten into an idea, you have not done too much of demonstration or too much of analysis or POC or something like that, but this is very unique. You have done a novelty search and it's not available. So you put a small document down and just try to stake claim on your invention with a date stamp by filing what is called as a provisional application in the Indian Patent Office. It's a small document. You don't need to give too much details, just the title, basic information. You don't need to also document the claims. However, within 1 year of such filing, you have to ensure that your invention meets the patentability criteria, and you file what is called as a complete patent application in the Patent Office, including the claims. It has to be to the same invention that you documented, but you have to also write all the claims that you have generated out of it. And the other one is directly you can file a complete patent specification, which covers all the aspects that is required by the legislation. Review the problem addressed and the unique features of your solution. It can be incremental, as I said. Identify advantages. Analyze the economic and commercial applications. That's very important. What aspect of the invention needs to be protected? Is it the process, or is it the product that is coming out, or is it the process and the product using that process? So you have to analyze these and then decide which aspect of your invention needs to be protected. And full disclosure is important, because because this patent application and the patent granted is put in the public domain on the Patent Office and all the various journals. So whoever looks at it needs to be able to reproduce it. Otherwise, it can be a reason for them to invalidate or oppose the grant of the patent, and your patent is likely to be rejected even after a grant. So please you have to be careful that these kind of points are taken care of. Inventorship, as I said, determining who's an inventor is a legal requirement, and they should contribute to the concept of the invention, and it should be a subject matter of at least 1 claim of the patent application. It's very different from authorship in publications, where any small contribution can be can be treated as equivalent to giving an authorship in a publication, and you have a primary, secondary, and many authors thereafter. But here it's not so. It's got a legal implication, the inventorship to a patent application. Wrong inventorship can even invalidate the patent also. Copyrights. So this is the other important, intellectual property right, which is an exclusive right given by law to authors to have their authorship in creative works acknowledged and protected. Protects a form of expression. As I said, you may have created a very interesting story in your mind, but unless you put that story down on a piece of paper, like when the pen touches the paper, and there is a document, there is an expression, there is a writing, there is a story written, you cannot claim ownership on that. So it protects the form of expression. Examples are journal articles, books, films, paintings, media presentations, computer programs, lyrics, everything. So many of them come under the ambit of copyright protection. And it is a bundle of rights. So it gives you the reproduction rights, derivative works, adaptation, broadcasting, distribution, recording rights, translation, performance, public display. All these rights are called as bundle of rights in copyrights. And typically you can get a global, protection globally based on various international treaties. Protects economic rights and moral rights. This is just to share with you, this is a bit of a weak right, because you can put I see the symbol on your, let's say you've got a publication or a story written, and you can put your symbol and the year. But some people can easily copy that, make small tweaks, and then, create it as a new copyright. So same way with software. Software typically per se comes under the ambit of copyrights. But it's very easy to change a few codes, a few lines, and then sort of, give up that copyright. So it's a little bit of a weak right, but it doesn't have so much of a process as you have for patents. You need to file, you need to fill this kind of a thing. There are such small forms, but copyright also exists just by virtue of putting the copyright symbol there. That is also a way of sort of, claiming ownership on that. Term for copyright, again, 60 years from death of author in dramatic and musical literary works. For films, etc., it's 60 years from the date of publications. There are exceptions, fair use, etc. In academia, this is very important because there are faculty members who give a lot of lectures to their students. Many a time, and these are sometimes recorded lectures, live lectures, they give reference to various, like graphs or documents or information that they have taken from other people. So always the best practice is to seek approval from the person who owns the copyright to such things. If not, at least show the due diligence by sending mails, showing that you've tried your best to get the approvals, and give all the reference possible. Mind you, for teaching, because it is an educational kind of a thing, it may be covered under fair use. But if you're doing outreach, for example, or if you're conducting, educational programs outside in a private sort of, scenario, there you're actually getting some sort of a gains out of it. And that is not treated as fair use. So there explicit approvals, or if it needs, you may need to pay money also to the actual copyright owners. So you have to be very careful what kind of activity you're doing. Yes? Depends on how much of that material you're using in your presentation. So, like for example, I'm taking Mickey Mouse. Now I can't go, of course it's out of thing, but I can't go to Disney and ask them for that. So this is, and I give a reference, it's from Google, right? So some things are okay. But if it's a chunk, like you're almost reproducing the whole, let's say a publication in a form of a presentation. You're just converting an article in a form of a presentation. So there you'll give the reference, no doubt. But if you're taking a lot of material, it's important to seek approval. And as I said, if you're teaching in a not-for-profit academic environment, that may be considered as fair use. But if you're going outside, you're giving a lecture and then you are sort of, there are these various training programs, let's say, and education programs, which are more on a commercial basis, then it is important that you seek, explicit approval. So there is slightly a weaker right called the Creative Commons. So because of this copyright worry, so a set of inventors and, people got together and created what is called as Creative Commons. This is a public license which enables free use of an otherwise copyrighted work with limited restrictions. Means in the beginning itself, they will say CC, and there are various types of licenses. It allows you free right to share, use, and build upon a work as long as you give attribution to that original inventor. Like you said, here you can give, like suppose they put a article, like as I've given an example, patenting versus publishing dilemma. This has come out in Nature communication document. It's available on the net, and it's available under the Creative Commons Attribution 4.0 international license. So there are some 5 licenses, each of which has some small indications like how you can use it, whether you can use it and develop it further, or whether you can use it just as this, and everywhere you have to give attribution to the owner kind of a thing. So that comes under what is called as a Creative Commons. There are actually, as an example, IIT Bombay, it got a lot of funding from a foundation, and the foundation was very keen that all this should go into the public domain. So putting it into the public domain doesn't mean you own it. Somebody else may use it, your own, things they may use, and then you would have problems thereafter. So they knowingly put it as a Creative Commons license. So they gave the CC and which attribution, which license can be included. They put it in the public domain, with that legend. So that became an important matter, that people can use it freely with these kind of limitations. Yes, but even see these, like for example, CC, if you want to use for your own use for various things, you can, you can get this CC thing and do it. But suppose you're making in this CC, you have certain licenses which says no commercial, non-commercial use. So you cannot use it for commercial purposes. But if you want to develop it further, let's say, and it's like you're using the same document, you're adding some more, like some feedback on it, or some kind of opinion on it, some kind of an editorial on it. You can do that without needing to go back to them. So it is more not just recognition, you're actually, it is recognition, but you're also not stamping on their, any benefits due to them. If you derive some benefits, you have to go back. But if you're not deriving benefits, you're just working further on that, then it is okay enough to give them that attribution through various methods and then go further in it. Absolutely, absolutely. What about books? What about cinemas? What about movies? I mean, what about everything, music? So this is all very, copyright's a huge kind of an area to work. There's a huge amounts of royalties are given. So what happens to lyricists? Or what happens to singers? So they can't get, songs are all over the place, right? So what have they created? They have created some kind of societies. They've called some music or, some performers societies, etc. So they get registered like a union in some sense. And when their songs are used by various entities, money comes in and they have an arrangement through which their royalties are due. So there are all these mechanisms, well-established mechanisms in place for having these royalties. Hi, yes, please. No. When you submit a preprint, a publication to a journal, typically you assign your rights to them, right? The journal owns your publication, if you see, because that's why many a times you don't get your own reprints. You have to buy your reprints sometimes. So you have to pay charges. So even then you can't use your own. You can't put it on your website without getting their permission. So that is a different matter. In publishing kind of a scenario, journal publications by and large, in fact, I'll come to it later, like where there is a policy, IP policy of an institute where they claim ownership. They specifically waive ownership to books and to publications because they know it has to be assigned to the publishers. So that is the kind of a thing you'll have to look at. So that's not Creative Commons. Design rights, it's given to a creative activities which is related to an ornamental or aesthetic appearance. This should be no technical intervention, but only the looks. Like, if you take the scooter, you would immediately say, yeah, it's a Vespa scooter. Just by the shape, it's not like what is happening inside. It's not the innovation of the machine or, the engine system or anything, but it's just the sheer shape. The shoes that I'm showing you, immediately your mind will go to Crocs. Right? There are imitations, no doubt. That's all matter of, again, infringement. But this is as given very clearly, says, yeah, it's a Croc shoes. So that way, the Beetle car. So these are what are given, rights for aesthetic appearance of an article, not technical. This is very important to keep in mind because many people say, I want a design patent. I want a patent for my design. So it's not a patent for your design. Your design will get a design right. Your patent will have a technical intervention associated with it. Trademark. This is for a sign capable of distinguishing goods or services of one undertaking from those of another. And it is marked by a logo, name, slogan, symbol, shape, color, sound, jingle. All these are so typically associated with a particular organization or a particular business that immediately and you know what kind of quality they come with. Like, McDonald's. So like, okay, I would like to go here. You may not like it much also, but you know that, okay, it's McDonald's, so I don't want to go to it. Same way, MasterCard. This is a service mark because it provides service, credit card services. CII. Again, it's a service mark. Urban Company. So these are all service providing agencies, which are actually, they can be recognized through the logo. And these logos can be filed for an intellectual property protection called the trademark or the service mark. Geographical indication, just matter of interest. It identifies agricultural, natural, or manufactured goods originating from a definitive territory, like the Darjeeling tea or your, Agra Petha, the Tirupati Laddu. They has a certain quality, certain origin, certain group, or certain, kind of organizations which sort of develop that. And these are given a GI tag, what they call as a GI tag. Okay, so I talked about individual IPRs. Now, your innovation or your sort of technology that you want to you have developed and you want to take it further can be covered by what is called as a basket of IPRs. Again, example is the Coca-Cola. So you have the Coca-Cola bottle, which is, protected by the design right. The Coca-Cola name is protected, the name and the logo is all protected by the trademark. And then the advertisements, all the various ways it has been depicted, the creative depictions is protected by copyright. And of course, the most important is a trade secret. Coca-Cola secret is still not out, and it has all the monopoly by virtue of the trade secret that it has protected so carefully. And it has also got a license of the can opening mechanism that is filed, that is protected by patent, for which they have a license. So this is called a basket of rights. So same way, if you develop let's say a sensor. So the sensor is boxed in a small box, your miniaturized. First, when you develop the proof of concept or the pilot, it may be some very massive thing, lots of gaps, lots of, little crude in looks. Slowly, you'll try to make it small, make it compact, make it effective. And then you put it in a case, you simplify it. So that case with the sensor kind of a thing, if it's very uniquely placed, it has some, a very aesthetic looking thing, it can be protected by a design. And the innovative sort of, packaging or labeling and all can have a copyright. Then you can put your own logo in these sensors to claim ownership, and that can be protected by a trademark. So, and if there is a good mechanism, the sensor has some very unique mechanism, it can be protected by a patent. So your technology, this becomes important when you want to start a company or you're in a company looking at these aspects. You can look at all these various basket of IPRs that can govern one particular technology or one particular innovation going into the commercial scene. Okay, so yes, please. Trade secrets. Okay, trade secrets are two things. India doesn't have a Trade Secret Act as yet. It is outside. And it's as long as you keep it a trade secret. So there is no, because that's the whole point. Like I think Coke has it for I don't know how many years, hundreds of years. As long as you keep it trade secret, you continue to get that protection. No, because you don't show it to anybody, right? You have it in your own. So only when somebody violates, you have to prove what efforts you have taken to keep it as a trade secret and how it has been violated. Suppose, your employee, for example, went out and then, he or she took the thing away, the secret away. Then you have to just prove when you're trying to file a suit against them, like how they have violated it. Yes, please. Hmm. 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 Okay. So as long as you're not putting a KFC logo and it is very clear that people don't come to you saying that, oh, this is a KFC taste, not, it is definitely the same as KFC taste. And KFC comes to know of it. Then they will see what it is. They will analyze your product. Okay, they will see if it's the same thing and if you are an employee. So then they will go through the whole thing of you have to prove that how you didn't have access to that trade secret and how you did it on your, because by now people have analyzed Coke, right? The Coca-Cola formula or the Coca-Cola liquid. They must have done all the analysis possible. Yet you have the Pepsis, you have the Campas, everything, but still nobody has come close to Coca-Cola. So that is why you don't get too many of such examples. This is one of the very unique examples which has retained for so long, and the period, nothing has changed that. Yes. And they will also have to, so you may even say that they didn't protect it well. Because trade secret is you have to show efforts for protecting that secret. So they would put it in a vault and they have certain, various levels of security of access, etc., they will have. So they have to actually prove how they have, made efforts to keep it a trade secret. If it's like lying all over the place, it's not a trade secret, right? It's like confidential information. When I share confidential information with you, I would put it on record in a legend form, or I would have an NDA with you, non-disclosure agreement, that whatever I say should be kept confidential. Tomorrow, if you breach it, I will have to say that, look, when I gave you all this, I did all this due diligence and checklist. In spite of that, you have actually defaulted or you violated. Okay. Correct. Yes. 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 Either that, or they will say, we will give everything, you don't do anything, you just be a franchisee and give it out. Like, like a post box kind of a thing. Here's my material from KFC. I'm just saying, I don't know the details, but then you just sell it. You're not supposed to make it. Yeah, you just assemble it together, but all the other things I would give you. So those kind of, they would have detailed agreements to that effect. It usually falls on the defender, but it can be, other way also. So it depends on ways, case to case. So it depends on the agreements, depends on the actual IP, those kind of things that come. So it comes in. Trade secrets, I think it depends on we are not very used to trade secrets, right? For us, it's more confidential information. So I think it falls on the owner to say that you have protected. So we've read this part that they said you have to show efforts that you have made to keep it a trade secret. So you have to prove that definitely. So, okay, this is the second part of my talk. Again, first we talked IP, then IPR. What do you do with this IPR? How do you handle this in academia? So why do you want to do IP management? Like you can just file a patent and then nothing happens. You have to complete the story, right? How do we sort of take the story further? In R&D, what kind of research do you do? You can do basic or applied research. You can take such research based on expertise or interest or the need, like, COVID time, there was a need for various things. So a lot of research happened based on need. And as part of academic programs, like the typical PhD research or an MTech research, and with student participation, so you can have, if it is an academic program, you can have students. You may have teams of faculty, student, and research staff. It can be funded by government or industry or by various organizations, national, international. It can be through industry collaboration, either through a contract kind of an agreement, here is this, do this part and give it to me, or through a partnership that you both do something together, develop something new. And it can be unrestricted, like, a lot of government funding are totally unrestricted, do what you want, generate IP, own IP, follow all your policies. Or it may be very specific terms and conditions. In industry may say, whatever you develop, I want that IP because I have funded you and I will give you upfront so much money. All IP should come to me. You shall not use it for some things later on. You shall, like, the trade secret kind of, the employee exit kind of comes. All these kind of things are possible. So various outputs based on what kind of research you do, various outputs come up. And what are the main outputs? Skilled manpower, as I said, and publications, major things, it's this. Then IP, and what kind of IP? You have products, you have processes, you have knowledge, know-how, solutions. There can be early stage, proof of concept level, hypothesis, or lab demo. Usually in academia, you don't have, more than early stage. You are talking about technology readiness level of 3 or 4. And that's why Professor Kamakoti said the efforts that are being taken for translation research support. And you can have industry partnerships, and output is industry partnerships, technology transfers, entrepreneurship, and of course an impact to society based on R&D outputs. And so you need a framework and policy for R&D management and administration. Why is this needed? Because role of IP, as I said, is important in teaching, research, outreach activities, in R&D collaborations, license, entrepreneurship, etc. Who are the stakeholders? There are many of them. There are faculty, there are students, there are researchers, there are university where you work in, there are partners, industry or otherwise, funding agencies, government. When they fund you, they may want certain rights. They may say that whatever you develop, you can do what you want, but you definitely give one right to the government for using it for various activities. Be it in the medical area, be it during like the COVID or, any kind of emergency, they may have certain requirements coming up. So you need to derive benefit from IP generation and its use. You have to assess the innovation. What is it? How strong is your IP? Is it something very unique, something new, it's got valuable, or is some small amount that may or may not stand the test of time? Then market potential. Is yours something very valuable in the market? Is there a need? How strong is the competition? What is the commercial viability? As I said, yours is very early stage and it's at a lab level or an academic environment. You don't have very strong scale-up kind of activity, scale-up and availability. So it may completely go down when you go to that level. Or it may be such simple technology that it can be scaled up very easily. Product designs, for example, as I said, pins or anything, you can create that. It reaches to a strong, high level very easily, and all you need to do is get it manufactured. But some technologies which are very like in the aerospace and other areas, bio kind of an area, you may need to have a lot of, time for maturation and analysis, regulatory approvals, for example. So many things. You may develop something, but if you need to take it to the market, you need regulatory approvals. In the medical area, you need to do clinical trials. I mean, various approvals followed by clinical trials. So all these you'll have to assess during the time when you generate IP. And accordingly, also you have to seek protection. Do you want to protect it? What kind of protection you want, etc., etc. And then there are strategies, because I've not touched upon the topic of cost, but legal framework, ownership, protection, all these are, because they are legal, it's very expensive, very demanding, and can be time consuming and frustrating. The end is very good, no doubt, but then you have to go through that process. So because it is expensive, you have to decide on strategies. Do you want to put it in the public domain? Do you want to put a CC so that, you don't get money, but you don't allow others to make money, but you make it available to the public. So, you fulfill all the requirements. So that kind of a thing. And how do you want to commercialize it? What kind of return of investments do you envisage? So all these, and above all, there are people who have created. So how do you incentivize the creators? These are all thoughts from the university, from the systems point of view, not just the individual. So how do you incentivize the innovators? Because of all this, you need to have an effective management from concept to commercialization and beyond, and have processes for IP creation, ownership, protection, utilization, deployment, awareness, and incentivization. All this should be covered in your IP management kind of activities. So what are these components? Mainly, you should have an institute policy. It's very important to have an IP policy, a startup policy. And then it also, what are the kind of framework that you have for IP generation and protection? Mentioned about legal support, what kind of legal support can you have for agreements, contracts, filing, etc. And the kind of mechanisms and processes that you have for technology commercialization, again, incentive recognition, all this should be covered in your IP management, in your policy, startup policy and the institute policy. In the policy, you would usually have a vision and mission statement. And who is covered? Typically like an IIT or an institute policy would have its faculty, its staff, its students, its researchers who visit the campus, who are full-time campus, who are coming through collaboration. All these are typically covered in the policy framework where the policy is applicable. And as a typical kind of a statement, it says the institute is owner of IP generated by its personnel using significant resources. That's what usually is the institute sort of policy framework. And collaborative R&D outputs are governed by specific agreements. In respect of copyrights, the institute is the owner of creative works, like, for example, technical, like if you develop a software or an algorithm which is used on a certain system which can be commercialized, institute owns those technical solutions. However, there are exceptions also, like, for example, thesis. A student and their faculty supervisor write the thesis. So the copyright in the thesis is usually given to the student and or the supervisor. The institute doesn't claim. Again, same thing with books, with teaching materials. When faculty member develop teaching materials and the institute doesn't own it because it's owned by the faculty member themselves. However, being in an institute, you cannot sell it. If you want to do that, then you go through the institute framework, like a continuing education program or mechanism that way. You have to then work around the institute framework. So due diligence, important that IP policy is in place and every person is made to accept it. So there are mechanisms like faculty, by virtue of their appointment and adherence to the statutes and all that, they are already bound by owning or buying, like agreeing to all the policies of the institute. For students, it's very important when they register, you have just the way you accept IT policy, you should also be able to accept IP policy. Now, why is it important? See, if you as an individual develop developed something and you want to take it out, you cannot use the name of the institute or the parent organization or the faculty member. You will be nowhere. Whereas when you have the framework of an institutional owned patent or owned IPR, that helps you identify industry partners, identify mechanisms of being able to transfer it well. So it's important to be able to assign it so that the institute provides you the support, help, processes of filing, protection, etc. And then as an institute IPR, it can go out in much better and easier way, faster way. So yes, acceptance of specific terms of R&D count. So suppose you are as PMRF, you are involved suddenly in some consultancy or some industry funded project of a faculty supervisor. There would be specific terms and conditions of that, and you have to be able to be bound by it. So at IIT Bombay, we would make sure that there's an online mechanism. We would request the faculty member to adhere to the terms and conditions of the agreements that are signed with industry partners, and in turn they get their student and staff members to agree to that through declaration. So this is very important because suddenly some IP will come up and nobody would know who owns it, what happened, where are the paperwork. That should not happen. So it's always important to do all this upfront. And use of institute lab notebooks. As I told you, inventorship is very important. So 2 of you like colleagues or 3 of you colleagues are working in the, like again, Professor Kamakoti said, there was a matter of 4 PhD thesis, which went into that, one technology that had to be developed and that went into a startup. That time, who contributed what? So institute lab notebooks with the institute logo and sign off by your professor or somebody else would help few years later when you're trying to file for something, saying that how to document and to record who contributed to what. So there is no sort of, dispute, there's no worry. And that also allows you to have an inventorship percentage. Default is equal, but sometimes, one person may have contributed much more and just finished a PhD and a new person would come just to the tail end of finishing small parts. So you don't need to give equal rights, right? So you can have a mechanism by giving higher weightage to the person who has done more and a little lesser weightage to the new person who has just completed the thing. So lab notebook usage is very important. This is very much for all of you, that you have to have proper documentation recording, preferably signed by your supervisor very regularly, so that all these are well documented. And again, in an institutional framework and level, they have evaluation mechanisms, filings, legal resource they provide in the form of attorneys, take up some part of the cost, and also, get involved in the deployment by identifying industry partners and talking about, sharing the technologies, talking about licensing, etc. The institute comes into this picture and also looks at revenue sharing arrangements. So what happens when you assign your rights to the institute policy also talks about the sharing of revenues received through technology licensing or entrepreneurship or any benefits that are given to the institute by virtue of these licenses, how it is shared back with the inventors. So in IIT Bombay's case, 70% of the shares goes back to the inventor team. So if you don't have an agreement, it's equally shared, or otherwise based on the agreement, it is shared accordingly. So a lot of such kind of things become important from an institutional framework. What are the due diligence in R&D and IP generation that you should take care of? Please review prior art through patent search along with literature search before initiating research. Don't only do a non-patent literature search, please do a patent search also. Document the work, as I said, use lab notebooks, understand claim to inventorship. Have transparent discussion and agreement regarding all IP related issues with the team, with your supervisor and your colleagues who are involved together. Read and understand the IP policy. When in doubt, seek clarification so that you are comfortable that you know what you are involved in. And read, understand, adhere to the terms of any agreement governing a research work. And due diligence in IP disclosure. Please avoid any public disclosure and disclose accurate and detailed information on the invention, including source of funding. Like, are you funded? You are right now PMRF funded by the government. There was a time when part money used to come from industry. So what are the terms of funding, especially IP related terms and funding for such kind of situations? You have to understand that. And many of you at times would have come with UGC funding or CSIR funding, ICMR funding. Some of their IP terms are very different, although they're all government. So you need to be aware of what IP terms you are working under. And then is the IP generated directly or through collaboration? So you have to have proper communication and consent at all stages. Name of inventors, you add one and suddenly you decide, no, he or she is not involved, so remove it. That is not possible. You have to go through a proper process of involving everybody and making it very transparent. And affiliations of inventors. Today you may be here, but you may go for an internship to some place and you may develop some IP there. It may be an academic institution, it may be a business entity. So what happens, and when you develop IP there, what happens to your status in the institute? So the institute, because you are still affiliated with the institute during that period also, although there is you have been permitted to go there. So these issues will have to be kept in mind, and proper permission, NOC. Like we've had in IIT many times, BTechs and MTech come to the institute for internship, summer internship. They develop something very novel. They are treated as inventors. Then what? So we tell them to get a no objection certificate from their parent institute upfront, so that when this patent is filed, we don't need to include that parent institute as a collaborator or a joint owner. It can be only by this institute where they interned. Okay, so all this is management. What next? Briefly, status of technology developed are research findings, very early stage, and they may be mature, but more often than not, they're very early stage. They may need validation, trials, etc. So what do you do? Do you put it in the public domain based on all these kind of analysis? Do you give support for translation because it has got good value, but it's early stage? So with translation, it will move and become mature. Can you give it to industry to collaborate it for further development and monetization or commercialization? Or develop it, get an industry saying, I want a custom made. You have developed something broad, I want very custom made. So can you customize it and give it to an industry? So that's also a possibility. And then deploy towards government needs and programs. So if you have something, then you say, okay, well, just work towards this and give it to the government and move on. Can you license it? Can you start a company? So these are all the decisions you can take based on all the analysis. And what are the main 3 ways of reaching the IP or the IPR to the society? Collaborative development and licensing with industry partners, direct licensing of IP generated in the academia, or start a company by the inventors. So these are the 3 main ways by which the IP can go out. Lots of information are there, but I think due to lack of time, I will stop there. I'll just talk about incentives, sharing of revenues received from technology licensing. Then you also the institute is supposed to disseminate. I think IIT Indore has done a very good job of disseminating the technologies that they have developed. By this you reach industries. They become attracted, they become very curious. They can come back and understand, and then get into a collaborative understanding and take the technology further. And recognition through awards, through motivating all the innovators by looking at technology development awards, cash incentives, giving them grants for taking it further. All these are recognition of their innovations, and motivate student participation by supporting many initiatives. Awareness, again, you create entrepreneurship courses, IPR courses, conduct workshop, etc. Continuous interaction and dissemination is what is very important in this field of IPR and management in academia. So important to understand the implications of IP and IPR. Role, responsibilities, and benefits as student researchers, you need to know. Carry out meaningful R&D with all due diligence. One line, because of all these aspects, do innovative, good R&D, but carry out with due diligence and with meaningful kind of purpose. So thank you so much. See, as I said, design is only for aesthetic appearance. So you cannot get a design right for a technical intervention. So, that is what is important. So design right is very different from patent right. Patent right is given for an innovative product or a process. That means it has to be novel and non-obvious. There have to be an inventive mechanism there. You have to have an inventive mechanism which allows you to say that it is new and it has an intervention, means it improves a certain thing. Whereas design is for an aesthetic appearance. So you cannot say, I showed you a chair, right? A chair and a table. You cannot say a chair and a table together I want to protect this with a patent because it's improving just the chair. Right? You can also say this just a chair and a table, it's improving, because what happens in patents, certain things cannot be patented, I told you, right? So two existing matter, a combination of those two cannot be patented. For example, you have an umbrella, you have a light inside it, right? And you want to patent an umbrella with a light. That cannot be patented because two existing, not just a combination of two existing information. So that cannot be patented. Whereas a chair and a table, attached in a very innovative way with a user friendliness, ergonomic and all that, that can be protected as a design right. So there is a difference. You cannot protect this for claiming improvement on sitting. You can only protect it saying that it's innovative in its shape and its design. That is the difference between the two. Not patent, it has another, right. It has a Semiconductor Integrated Design, Integrated Circuit Act. So it protected under that.
Through that layout, he can understand, like he can come up with the schematic from that layout itself. And he can develop another layout which performs the exact same functionality, achieving the same performance. But the layout is different. For a patent, but he can achieve the...
He may not be able to get a patent because your patent will be shown as prior art. So because you have filed, right? And let's say it is published and then the other person does it. So when the examiner looks at his application, he would see yours is already in the public domain because it's a published matter. So he will look at that novelty criteria and the characteristics. And if he finds that yours is already saying what you're saying, it is happening, then that would get rejected by virtue of the novelty problem. They will look at functionality. They will see their mindset is very clear. Non-obviousness, novelty. So novelty they will catch. And then after that, they will see, is it obvious? Like what you're saying to me, it seems obvious. If you have something and just to use, the way he's done, it's an obvious kind of a activity. So then that will go off on both counts. Many times patent objection comes on these two counts. Utility is very easy to cover, very easy to cover. Always novelty, which is easy to prove that no, it is not what you're saying, it is novel. I mean, it is exposed or in public domain. Inventive is always very subjective. So you have to prove beyond doubt how yours is inventive. So it will get squashed on these two counts. Yes. So CC, right? Because I didn't get time, I didn't put all the various licenses. You can go there and see what license it is given, that CC, attribution 4.0. So you read that, you can work within that framework. So it says attribution, non-commercial, no change, use as is kind of a thing. Then there is something say you can change as long as you give credit and you don't commercialize it, non-commercial use. So depending on the license gives you all the things that you can do with it. With that framework, you can use it. So CC allows that. There are about 5 licenses that are given. Like one is the simplest and the other is most restrictive, but definitely easier than the copyright.
Some things which I feel obvious may not be obvious for the other person.
Yeah.
And whatever, whoever decides that, so there might be a conflict with them also.
Yes, so that's what I said is very subjective. So you have to show what is existing, what is yours which is different and better, and how somebody in the same domain could not have thought of it. That is where the whole crux is. Like as I said, a small piece of pin, once you show the gem clip, it's very easy. Array, this is no big deal. You just twist it and it is working. But nobody did that except that one inventor. This is very easy, I'm saying, but you have to there are certain criteria. So when it comes for objection, you have to go and defend it. and say that how yours is different. You can't say nobody could have thought of it. You can't write that. But how yours is unique, how yours is inventive. So there is an inventive step. So this is again a little bit of techno-legal kind of a thing. So the attorney usually would come and help you. And at times you may need to even go there for a meeting. You may need to go meet the patent officials to explain. This has happened even in the IIT Bombay scenario. This has happened that you have to go there and explain to them, and then they get convinced, and then they may even say, okay, we are not happy with the way you have written, amend it in this way. Then we will accept it. So you have to go make an amendment, and then that works. Yeah. I don't know. Is it a patent? I don't know. It is a patent. I'm not sure about that. So they would have, see, the way to do it is that whole contraption is unique. They'll have to show, prove. It is like, I know you're saying there's an eraser, there's a pencil, and stuck this together. But if they could prove, some of these things are different, there's art and also writing. So if they were able to prove that this whole thing as a single unit is unique, not because of this combination, then it would have been patented. But I doubt it has got a patent. I'll check it, but I'll doubt it would have got a patent. So this kind of, these kind of things, just combination of existing material, if you put them together, these are not subject matter of patent because it's not unique. Although it's like innovative, right? But they say this is some things under the act, it's very clear that it cannot be. A, B together, A plus B. That's what I'm saying. That if you are able to defend how that single unit is not just a thing together, but it has another characteristic, which is non-obvious, then it would be a subject matter of patent application, patent grant. Yes. You can say, like, for example, if you create something, it has applications in a certain area, right? So when you start a research, you already know where it is going to be applied. So you talk about applications. You can have it can be in some, the sewage treatment plant, for example. So it's got application in sewage treatment. So that kind of a thing, you may not have done all the aspects. That's why you're disclosing everything so that somebody can take it further, make it into a proper, viable product, and then put that into that application. So these are you just need to give those kind of applications that you have in mind. That's another thing. So if you say, you have developed a technology with this application, if you just restrict it to that application, then other people can use the same technology for other applications without coming back to you. So you can say can be used for applications such as, like sewage treatment. So which means in case it can be used for something else, let's say, that also gets covered in this because you have not restricted it to the sewage treatment kind of a thing. It can also it can open up for others. So these are like the art of writing some of these, the claims and the specification. See, they don't help, but they have processes. You disclose an invention, they do a prior art search, and then once they're okay with it, they may ask you if there is, some prior art thrown up. After that, they put you to the attorney. The legal attorneys are there. They have a panel of attorneys. So even in Indore, that's what happens. You talk to the attorney, they will ask you a very pointed question because many times academics think on a publication point of view. But publication and patenting, the drafting and the writing is very different. Patent has only focus on, is it non-obvious? It is, novel. That's the main thing. So they will help you so when many times what happens is even in Bombay, IIT Bombay, publication draft would come to the office, that would go to the attorney, and that would be completely revamped into a patent specification because of, as I said, some conference is due or some publication is coming out. So immediately we would file a provisional application and thereafter revert the whole thing into a patent draft. Sorry, I had to go. Sorry, I know.
One last question.
Two different patterns. So, such as I said, this jurisdiction based. So when you file in India, you get protection in India. You file it in the US, you'll get protection in the US. In Europe also there is one, Europe. And after that, there is, different countries in Europe that you have to file it in. So it will be different pattern. The invention will be the same, but the protection is accorded in these different countries. Design, I've seen in the 3 months, 4 months, sort of it comes up. It's not very, because they have some journal in which they do the prior art, whether such design exists. And if so, they will come back and tell you, and then you just go through one or two iterations and it is done. In fact, the attorneys themselves have these kind of searches and they would help you do that. Thank you.
Thank you, ma'am. I request Professor Ishwar to felicitate Professor Satish.
Thank you.
At least you. So we'll take 10-15 minutes break and come back here. Okay, short break. So one thing, before that, I'm closing on the poster sessions. I would like to thank certain people. I think I would like to thank the NCC coordinator, Professor Kamakoti, as well as the team lead, Professor Deepa and his team. Actually, Professor Deepa, for all of them, NCC committee, because you have seen the NCC committee, for actually giving us an opportunity to host this symposium at IIT Indore, and also Professor Joshi for handholding us throughout the process to site from selection of people and then charting the program. And then most importantly, there are certain people like team of, you understand, a lot of people are running around in the last 3 days. It's actually a past 1 month of work. People have put a lot of efforts in actually shaping of the program. And then again, all the speakers I would like to thank, and most importantly, the volunteers. I think I should give a big round of applause for them, because they have done phenomenally great job. I think they were not sleeping also for the past few days, but I think they're done phenomenal job actually, especially. Yeah. Anyway, I think at some point of time, you'll also able to organize. I think you'll feel that as well. Our administration section as well, like coming down to our Dean Student Affairs, because I would like to place everything on record so that, it'll be on the YouTube link as well. So Professor Srivatsan and his entire team. Srivatsan is our Dean Student Affairs, and entire hostel team and dining team that put a lot of effort in the last few days. And then similarly, we have Dean Education Outreach team, which is led by Devendra and all these people, Aditya, and all these people are still talking to people, and then they're arranging and several things for the guests. And most importantly, you guys, I think you travel a long distance. I'm pretty sure. I think big round of applause for you guys actually. I'll tell you. Yeah. So that's what. And then the PMRF team that is sitting there, I think Praveen, Bhargavi, and all these people, I think they're always there for us, because so they've been, handling, we are just handling at nodal coordinators, we're handling around 50, 100 people, but they take care of 3,700 people, and that promptly responds to any email, any phone call. They're always there, not in terms of this organization I'm talking about. Any PMRF query comes, they're always there. And otherwise they get back to us very quickly as well. This is opinion of not mine. I think all the nodal coordinators echo the same opinion. I think thanks Bhargavi, Praveen, and the entire team of PMRF IIT Madras. Okay, so without further ado, I think it took a lot of time for the poster. It's very difficult for the judges because they felt that, it's extremely difficult to evaluate the poster sessions because all of them are top quality, because we know that you guys are the best. And then finding out at least one, because we are actually given a dictum that we have to only get one for each of the broad area. So it's become difficult for us to find one number, but we have to at least arrive at one. So that's the reason I think all of them are very close. And probably it's like a JE rank, right? 19.9999, whatever, it's like something like that. So probably I think this is the unanimous agreement happened across all the panelists for each broad area. So this is, I don't know whether I can put it here, right? Yeah, okay. So this is from civil engineering, earth sciences and architecture, ocean and naval engineering. Anupama, is she here? Yeah, you can come here. So okay, you'll get a memento, but right now you'll not get, but you can just come here. We can take a picture actually. You can have a picture right now. Yeah, come on the rest. So you have next mechanical engineering, Devjit Kundu. Next we have electrical engineering, Yashwant from IIC. And we have biosciences and biomedical engineering, Nidhi Mittal from IIC. Then we have chemical engineering and textile engineering, Gautam Narayan Tumulu. Is where here? So material science and metallurgical engineering, Gauri Hemant Wagmare. You have material science. This is what is the science. Okay, computer science and engineering, data science and mathematics. Guru Bachchan from IIT Jodhpur. You have physics. Bharati Rani from IIT Jodhpur. So your chemistry. Asha Sweetie Thomas from IISc. What is she left? What is that? Interdisciplinary areas in science engineering, including Sharmista Majumdar, IIT Jodhpur. Okay. That's it. Yeah. I think all of you guys can stand up here. We can take a picture.
Congratulations all. Do well.
Yeah, there is one. We'll all get the certificates uploaded in your PMRF portal so that you can download the e-certificate from there itself. So that, I mean, we don't want to have a hard copy here. So all of you will get a certificate signed by director and then coordinator as well. So that will be uploaded in your own individual PMRF portals. If you have any queries, you can ask. And if you have any feedback, you can come and share as well. Okay. Yeah. If there is any feedback or if there is improvement that can be done in the next year PMRF symposium, that can be taken care. So that's I precisely wanted to check with you. Yeah. Yeah. If anybody would like to share something.
Just share your thoughts with us. Oh. If you would like to share your thoughts with us regarding your experience at IIT Indore, please welcome him. Round of applause.
So I'm feeling very fortunate that I am also getting this stage to express my feelings like other talks. So this is my first PMRF symposium, although I'm very old in the PMRF family, and but I look very young. And so first of all, when I heard the name IIT Indore, I thought why this institute was selected for conducting the PMRF symposium. But as soon as I entered in this hall, and I'm pretty sure everyone will agree to this, इतना शानदार hall, sir, मतलब now I personally feel, and I mean everyone, sir, everyone has the same opinion that this is very wonderful hall. And अगर PMR symposium यहाँ नहीं होता तो फिर कहाँ होता? So and that's why I thought, like, if I'm from IIT Kharagpur, so if this would have been at IIT Kharagpur, मतलब इतना सुंदर तो नहीं हो पाता शायद. Achha, yeah, my friends online are also visiting. They may be, do not take my name, please, at IIT Kharagpur. Okay. And yeah. And more specifically, the volunteers, I have troubled them a lot. So it has never happened that I sent a WhatsApp message to them and they never replied. So I contacted many of them also in person when I communicated with them. And means like whatever I am using, that what that I represent this entire committee which is sitting in front of me. So they were very prominent and very committed to their works. They were very humble also at the same time, sir. Usually, sometimes people lose their humbleness while handling these many things. So salute to them. And finally, to our family, I'm very happy that I found so many great faces and great personalities here who are doing very good works. And sir, means like it is a very great means like step that has been taken by the ministry or the organizing end to conduct this symposium. So this is something which gives us a break from our regular PhD life. We all understand like how difficult and challenging sometimes to do research, and when we are not getting papers, we are getting rejections. Then coming to this platform and then talking to others and finding similar people, then it gives us hope that, okay, I'm not alone in this ocean of knowledge. There are many people like me who are also not getting the publication. So it's fine. So finally, I would like to thank the entire organizing end of this PMR Symposium, IIT Indore faculty, and all those reviewers who were there, who patiently listened to us yesterday and today also. So I'm really grateful to all of them, and I'm really grateful to all these people. You all are my friends. I owe you. Thank you. Jai Hind.
So Deepa, you want to say something? You're online?
Yes, I'm online. Am I audible?
Yeah.
Okay.
Yeah, you're audible.
Good evening, everyone. I'm really sorry that I couldn't stay back with today. There was, a meeting here I had to attend. But then, first of all, I would like to place on record the initiative from Professor Ishwar and the organizing team. I would say a very big round of applause is due to them right now. They came forward for, volunteered for organizing the symposium. As you know, the previous year, last year, we had the symposium in IIT Madras, and we really wanted this symposium to be a culture where the PMRFs can interact between them, create interdisciplinary, encourage interdisciplinary discussions, have the bonding between them, have this sense of brotherhood or sisterhood, whatever you call that as, right? Between yourselves, like the student who just said that, you always get lost, you tend to get lost in your own research, and you feel that sometimes that, you are in a problem where, you are only facing that problem, and such events will bring you, when you come together, you will realize that everybody in research is facing such, small bottlenecks, and it gives you a confidence that in the end, everything is going to be fine, right? You will see successes very soon. And I congratulate all the PMRFs who have won the poster awards. And I'm sure that these were only metaphorical, right? It is not that one work is less important than the other, right? So all of you are doing great. And I just also wanted to, convey the gist of the feedback that I got. I interacted with several scholars yesterday, is that, a comment from our side, from the national organizing team, is that first of all, we are always accessible. So please feel free to contact us in case you are having any trouble with the operational issues of the PMRF. The support team is there. Ms. Bhargavi, the PMRF project manager, and Praveen, who is there, right? So please feel free to contact anytime. You don't have to necessarily go through the institute coordinator. It is through the institute coordinator. It is always better. But let us know if you're finding any kind of difficulty. That is one. The second thing is that about the reviews. A lot of discussions happened over the PMRF annual reviews. So I would say that please take it as a positive experience on how you're getting feedback on your work every year rather than at the end of your PhD, right? So please take that as a positive experience, and anything that you think that can be changed within the guidelines, we are happy to bring about. And so those were the two points that I had to make. And once again, it was a really wonderful experience in IIT Indore. fantastic hospitality, magnificent halls, lecture halls. Yes, like the student said, I didn't get the name of the student who spoke. He truly expressed everybody's view. If not here, then where, right? So we will circulate the PMRF symposium. We will rotate. So next year, NCC will come up with a decision on where the symposium is going to be. We'll try to keep it as diverse as possible. And hope you all enjoyed this event, and please give us feedback about how to conduct the symposium, also how it will be more useful for you for the days that you're spending. Please do send us the feedback also. Thanks again. One more big round of applause to the IIT Indore organizing team, and especially to Professor Ishwar. Thank you.
Thank you, Professor Deepa. Thanks very much for the continuous support. Thanks a lot. Yeah.
Good evening to all. I'm Sonu from IIT Patna, and this was my third symposium. I guess only 3 symposiums were held in PMRF. The first was in IIT Delhi, which was online. Second was in IIT Madras, and third was at IIT Indore. Second, मैं IIT Madras ने मिनिस्टर को बुलाया था, मिनिस्टर ऑफ एजुकेशन स्टेट. बट मैं ये कह सकता हूँ कि यहाँ का सिंपोजियम वहाँ के सिंपोजियम से बहुत अच्छा था. यहाँ पे मिनिस्टर को नहीं बुलाया, but still it was very nice. I am happy that they included a cultural program into the academic event, much packed academic event. और खाना भी ठीक ठाक था, सारे अरेंजमेंट अच्छे थे. सारे अरेंजमेंट अच्छे थे. I am thankful to everyone. I just want to request Professor Deepa that please make contingency grant guidelines centralized. It's very painful that every institute is having its own guidelines, and we are, suffering from it. For example, they don't include flights into claims. We have to travel in trains for 36 hours. That's very painful. So if it is centralized, it would be very nice, because some institutes give flight reimbursement, some institutes don't. So that's actually not good. It would be nice if it is centralized, and it would be easy to us to attend every conference everywhere. Thank you so much. This is it from my side.
Let me respond very quickly. Can you tell me your name and your institute?
Sonu, IIT Patna.
You're from IIT Patna. Okay, yeah. Great. So thanks for that feedback. But you're requesting us to do something which is not approved by the Government of India norms, right? So we are also constrained with certain norms that are put in from the ministry and the Government of India. In fact, what we are trying to do is to give each institute, or enable each institute to have the freedom to choose their own rules, right? So that we are not constrained by one single rule, right? So in case of research grant, it is not contingency grant actually, it is a research grant. It's a grant that you need to be using for your research purposes. And I request that you please talk to your institute coordinator and come up with the guidelines for your own institute, which is acceptable by PMRF. Right? Each institute, and if you want sample guidelines, we are happy to share the example guidelines from IIT Bombay or IIT Madras or IIT Indore, who would have made their own guidelines. Each institute is actually enabled to make their own guidelines. So that is how we are. That is how the funds are approved. So there is no way we can change it. I'm so sorry that this blanket approval for flights, as per Government of India rules, it is not approved as per my understanding.
Yeah. So caveat here, Since it's right, you are comparing the improvement in the PMRF organization from the previous year, just because of the feedback what we received from IIT Madras, right? So they because of the feedback what they could not have done, so they actually told that this should have done better, this could be better, this could be better. That's what actually the initial discussion when we wanted to organize, we went back to Professor Deepa and they told what could we make better compared to the last year. Then actually she came up with this what we made a mistake here. Probably it could be improved, it could be improved. So that's what we acted upon. It's not that, I mean, their contribution also here is there to organize the scheme actually, right? That is the objective also, right? Every time next year it will be much better than this one. That's what we wanted to, every year wanted it improvement in the organization as well. Yeah, thank you. Comments? No comments?
One appeal I have to all the PMRF scholars, if I may, because we are talking about research grants, please spend your research grant.
Yeah.
Do not accumulate it at the end of the last month of your PhD. Please use your research grant for research purposes.
Huh? Please also update in the portal. That's what Praveen is saying. He's looking at the portal actually. That's important.
Please update your publications, your
conference
conference publications, etc. in the portal. Yeah. And if you know, all this is published, this data is published live in the portal. So, you know, for the entire country to see. So for those who have the questions on, you know, why give this large funding to a few scholars, the answer should be there in the portal. So any achievement that you make, please update in the portal.
Anything else? Yeah. At least. Okay. Anybody PM has 40% women candidates are there. At least actually one should speak, right? As 22 voice speaks, right?
I'm probably representing all the women out there.
Yeah, that's what I'm talking about, fellows. Yeah. It's good.
First of all, thanks a lot for this wonderful opportunity and bringing, students from across the country on a single platform. I'm Kavya Shri from IISc. I mean, she can hear me, right? So yeah.
Yes, I can hear you.
Yes, ma'am. So I had, on behalf of a lot of final year PMRF students, we actually wanted to bring upon a small request. I don't know if it's small or not, but I understand that this is for a limited tenure and it's difficult to sort of extend it beyond the 5 years that we're given the amount for. But some of us might have contingency left over, or you also understand that it's very difficult to finish on dot. Say, if it's July 31st, it's very difficult sometimes for most of us to, wrap up by then and then submit our theses. PMRF being one of the very well-funded scholarships, it would actually help a lot if, even if you can provide half of that fellowship after for about like a 6 months or 8 months for us to, survive on, because even in IISc, I think we don't receive any support from the institute after the tenure, like 5-year tenure is over. And many of us are from lateral entry, so we end up getting like for 4 years of PMRF fellowship. And after which we are literally on like zero money. So if we submit the thesis and by the time we actually do the defense for the next, if it happens in over like 4 or 5 months, we are literally on zero money and we have to like live on our savings. savings. It would really be helpful if you can even provide half of the active contingency amount, or like the active research grant or active fellowship for us, to extend it for the next 6 to 8 months at least, for us to wrap up and then, write up our manuscripts and so on. Thanks a lot. That was one request that I had wanted to.
Yeah, thanks for this input, or I've heard this feedback from a lot of you yesterday also. But I'll tell you our side of the story, and you can tell us how to solve the problem together.
Sure,
right?
yeah.
So like any other project, PMRF is a project.
Yeah.
Okay. It is not a grant in aid that continues for, it's not like an MOE fellowship, right? PMRF is operated as a project, and the project has definite goals, milestones, deliverables, and a definite budget.
Sure.
And this budget is pre-approved by the government, right? So any change in the budget, see, 50% or 100% of the fellowship would mean that finally there's an implication on the money. Right?
Sure. Yeah.
So this being a pre-approved budget in year 2018, right? Any request for changing this is not approved by the ministry, because it's not budgeted.
Sure.
Right?
Yeah.
For example, we had a couple of, not for the fellowship extension, we had a couple of requests that were made earlier on funds for conducting some outreach programs at the granting institutes, or funds for even operating the PMRF in the granting institutes, funds for increasing the, it's quite, probably you don't know the other side also, that, the PMRF scholars are funded very well, as we know, but then the reviewers, the money that we are giving as honorarium to reviewers is really a small token. It is only a very small token. So we had tried to see if we can increase. All of that, it was not approved simply because it is not a budgeted, it works on the budget. So what we have done going forward is that for the next phase proposals, we all work based on the learnings that we have, right? So for the going forward, we have put in some, all these learnings are going in, but unfortunately, that will be only for the future. For this current scholars, we are kind of a little constrained because of that. We can still keep requesting the ministry, but like any project, it is like your research project, right? Your research project, there is a definite fund, definite budget. And you see, I'm sure with your guides, you may have worked with research projects. They allow extension of duration, but without implication on budget. There will always be that line, right? Without any additional budget. So,
I mean, if I may just add to that, like even I think some of us will have some amount left with our research grant, and if you are at the end of the
so the
finishing up
grant,
this thing, if we can,
if there is, I'm not mistaken, there is some flexibility in the research grant. Praveen will apprise you about the guideline.
Sure.
But I think the flexibility is in terms of after you submit the thesis, there is a certain time for which you can still use the research grant.
Yeah.
Right. So there was a guideline that we got it approved from NCC recently about it. So we can circulate that guideline as soon as this meeting is over.
Sure. Thanks for considering this. Thank you.
Yeah.
Hello, ma'am. My name is Anupama. I'm standing as a representative of the PMRF scholars from IIT Madras. So I wanted to request you to have a uniform, decision on the conversion of PMRF to HTRA after the PMRF tenure has ended. Why I'm speaking is because many of my friends are doing experimental research, and due to various constraints also, it was difficult for them to complete within the limit. So the conversion from PMRF to HTR is not being done uniformly over the departments, which is a bit strenuous for most of us. So if you can do something about it, we'll be so grateful. I wanted to use this platform because I got this opportunity to represent my friends here. Thank you.
Thank you again for this feedback. But again, PMRF is an independent project and we are only a coordinating agency. We do not have any, so to say, power to dictate what institutes should do with their money. Right? So some of you have come from the MOE funding. Some of you may have moved from CSIR funding. Some of you may have moved from NBHM, Inspire. There are several funding sources which you may have been funded before PMRF, right? We at IIT Madras is only doing it's a coordinating agency which is operating this PMRF project, okay? Like what I said earlier, I would like to repeat that we have no authority to say that institutes should do this way. You understand the difference, right? Even to IIT Madras, I cannot say that IIT Madras PMRF scholars should be paid HTRA because that is bound by the Senate rules of those respective institutes, right? So unfortunately, we are a bit constrained on that. We can only recommend that, you may want to consider them for HTRA, but what each institute wants to do with their own money is bound by their own Senate rules, right? So there is, unfortunately, what happens after PMRF, we will not be able to dictate.
Thank you, ma'am.
Yeah. Professor Ishwar, there is a hand raised from an online participant.
Hello.
Yeah, you can unmute yourself, Balamurugan.
Hi, sir.
Please.
This is my one suggestion. I'm also in final year of PMRF scholar. If you conduct this symposium for all the scholars, even if they are getting 2 or 3 grade, if you conduct for them all to offline, then we can able to see the presentations of that who got first. Then we can able to see. Now we can't able to see the posters of the who got first ranking. We also got 2 and 2 ranking, but we are not able to see how we can improve ourselves like that. If it is in, we also came in offline, but one can give presentations, but others can just participants, they can in offline, then it is better for us.
That's a very nice feedback for going forward. But I have a question to all the award winners. If you're open to share your posters, we can put up in the PMRF portal so that everybody can see what the and the links to your work. So if that is acceptable to all the, because I just want to make sure that sometimes the posters may contain information which is not unpublished or information which is IP protected. If that is not the case, I request that our office can coordinate putting this award-winning posters up on the web page so that everybody can see. That is for this round of symposium. But going forward for the next round of symposium, I'll request Professor Ishwar to comment on the feasibility of inviting all the PMRFs to the symposium. Yeah.
I think, what happened is that it's more like a logistic issue. See, we have 3,000 PMRFs. So if you look at the way typically we're having it in somewhere in February, March, right? Last time it happened in February, this time it happened in March. So most of the IITs are actually have issues with the hostel crunches. Very difficult to accommodate so many number of people actually, that's number one. That's the reason we actually had given an online link to everybody so that anybody can join it, like the way Balamurugan's joined actually, right? So every IIT has the same problem, I'll tell you. It's very difficult to accommodate all the people. One. But number two is that if you call it's good that you learn from that, as Professor Deepa is pointing out. Professor Deepa, actually we can do a flash poster otherwise, a 5 minutes or 3 minutes poster session with with everybody, all the recommended with commendation people, so that they can actually have this flash poster session on their website, individual websites or the PMRFs, so that the other people can learn from you actually, at least. Because that's what happens in many of the conferences where you have to do a 3-minute or 5-minute poster. Right, so that again, you have to not disclosing the kind of work which is already unpublished, or which is actually sensitive to what you want to disclose or do not want to disclose. That is a good suggestion, I believe, actually. Yeah, if not the entire poster, they can do a glimpse of their work and their this one, so that others people can learn. Somebody is in 3A, they can actually learn from you and they can get into the higher grade in the next review process. Yeah. But also presentations like some selected all conferences do have some selected work as presentations as well. That will make it more interesting. It is interesting, but the problem is very difficult to get an audience. Right? For even plenary talks itself, there are only hardly 30-40 people are there. So you're talking about individual possibility. When you present, you and your friends, 5 people only will be there. I'll tell you. This is the bottom. I'll tell you, this is a fact. The fact of the matter. But anyway, I think it's better we can actually have a broad area wise. Probably we can actually have some breakout sessions when in parallel session at one time, so that probably we can have a recommended with commendation, and then probably your other people can join. But the only thing is that getting people will be a difficult, is what my proposal.
So just a quick comment on that. Last time when we organized, we had broad area wise sessions. The sessions were organized into broad area wise. So even the posters that were presented would be of those specific broad areas.
What exactly what's your name? Moira, right? He's asking is, why can't you have a 10-minute or 50-minute talk for each student?
Oh, for the student.
At least, rather than, at least some students, not each student, some students, some students, so that, they can actually also get to present rather than just in terms of posters.
Right.
Yeah,
I would say that your such talks will be appreciated in your own technical conferences, where the entire community is listening to you. Whereas here, it may be little like what Professor Ishwar pointed out, it may be little difficult to get the entire audience interested in that.
Hello, ma'am. My name is Vanika. I'm from IISc. So I have a very specific question pertaining to my condition. I don't know how many of the people will be able to relate to it, but I am a October 2020 joinee. And I joined as a CSIR fellow because of COVID. We joined 2 months late. And I've been getting my fellowship from October. But I got upgraded to PMRF in August 2021, because of which there is a 2-month gap. And my upgradation from 70 to 75 and then 80 is also happening in October. But the tenure of my fellowship is 31st August. So I don't understand how to and whom to talk to about.
You send us, and this is a very specific issue looks like. So please send us, so you will have the PMRF project manager, Bhargavi, sitting there. You can directly talk to her about the rules. Bhargavi, can you wave and identify yourself?
Yeah, I found her.
Yeah, so she would immediately give you a solution. But in general, if there are such issues, please write to PMRF support.
Okay.
Any such issues that you are facing, you have a question, please write to PMRF support at smail.iitm.ac.in.
Okay. Thank you so much.
Thank you.
Hello, ma'am. Hello, everyone. I'm Ketan here from IIT Hyderabad. I belong to a design department, and I got this PMRF fellowship at the end of my first year. So first year generally we used to be a where you do the coursework. I knew this that PMRF comes with certain rules and regulations that it will be given only for 4 years with your masters. But then eventually when you understand this, it becomes only for 3 years if you have already done your masters from IIT and with a lateral entry. So it was just a request, since I know that the PMRF 2.0 is looked into, and if it can be looked the new sets of regulations, for maybe there might be a lot over here, who might be facing this issue. Because what happens is, like, at the end of third year, that is where somewhere in my domain, you are able to come up with certain solutions, which later you will be turning it into a final project, which is a deliverable one, which makes a statement kind of thing, and I'll be able to convert it into prototype or something. So at least you need 5 years or 4 years, a good time with this. So if this can be looked into, that was a request. So 3 years is like gets
Thanks,
very
thanks for that
difficult.
feedback. Thanks for that
Yeah,
feedback.
ma'am.
And just to reassure you, our revised guidelines are recommending extended duration, but I don't want to commit on that because we don't have an approval from the ministry yet.
But
So
then
this
that will,
concern is taken care.
but even the PMRF 1.0 students will be.
I can't comment on that because we have not approved, we have not received any approval from the ministry. So it is too premature to say all those things.
Okay, ma'am. Thank you so much. But do consider.
Yeah, it is already considered. It depends on how much, to what level of approvals are we getting from the ministry.
Good morning, ma'am. Good evening, ma'am. I'm Shomodeep from IISc. So I have a question, like those who come to this PMRF scheme with a master's degree, they get the fellowship for 4 years, that is till the end of the 4th year. And those who come with a bachelor's degree, they get it for till the end of their 5th year. So what is the reason for differentiating between these master students and these bachelor students? Is why we get 1 year less? I'm an MTech graduate.
Yeah, so like what I said, we are only operating the guidelines given by ministry, right? So these guidelines were formed when the PMRF was initially conceived. So you should have asked this question to Professor Desai, who was here yesterday, who was one of those members of, team which conceived the program. But the general response we get is, after your 12th standard, it is 3 year plus 2 year plus, total number of years of education, which can be given as a scholarship tax-free. There is some constraint on that, right? So those coming with a BTech, MTech have completed 6 years of education. So 4 more years are supported for PhD. That is a response I get when I ask the same question, because I also have the same question to the ministry, but that is the response we get. So going forward in PMRF 2.0, we have changed this recommendation. But again, as I say, please do not take my word on this. It depends on how much approval we get from the ministry.
Thank you, ma'am.
So the reason why for this is, bachelor's is 4 years or 5 years integrated program. They get 5 more years for completing the 10 years of education. It's 10 years of education after your, 12th standard.
Thank you, ma'am.
Hi, everyone. I am Pratik. So I'm basically from this college, IIT Indore, from the astrophysics department. So before getting the PMRF fellowship, I was a CSIR fellow. And related to CSIR, PMRF is quite new. It's no comparison. So it's obvious that there will be many, many problems. And just to give a specific example, when I was a CSIR fellow, I didn't get the fellowship for the first 10 months. Okay, so it was a very big issue. So things are very complicated, but that's the situation. And I just want to address that we are you guys are very bright mind. And after this PhD, the things most probably, what I have understood, is going to be more and more complicated. So what we need is that we have a situation and we have to perform in that situation. So we are basically getting almost twice the stipend on the taxpayers' money. And it's always our responsibility to prove that we are doing much more than the normal PhDs. So it's not about the problem, it's about the situation and figuring out how to perform in the best manner in this situation. So I think that you guys have also the responsibility, including myself, to perform and to show that why we have been chosen, and that like in each and every year and each and every semester, And you guys know that how much money we are getting as compared to the normal, or my friends are getting, like none of them are PMRF. So it becomes very difficult to show them that why we are getting this much of money, what are the extra responsibilities that we are performing, and under what circumstances we are doing that. And I'm very fortunate that you can see that how fast PMRF support team is working, which is not in CSIR, UGC, or even in Inspire or DST. So we are very lucky that we are having this much of smooth processes, and we should focus on the problems and try to mitigate or getting more and more from in any given situation. So that is a very important thing that we should have a progressive mindset, attitude, and a leadership quality. So thanks for coming here, and it was a really nice interacting with you all guys, and maybe we'll see in the next year probably. Okay, thank you everyone.
If there are specific issues, you can always write to, as I told Praveen and Bhargavi, they're extremely quick in response. I'll tell you this, because all the nodal coordinators, we bug them a lot, but they're very patiently, they always respond to everything. So there is a very good support team. If you have any specific issues, you can always write to them, as Deepa is pointing out. Yeah, with this, I think we'll not take any specific individual questions because it becomes like a problem. Anyway, so with this, I think, Professor Deepa, can we conclude this PMRF 2020 Symposium 2024? Yeah, with this, I think we'll conclude the PMRF 2024. All the best who are in the final year. I think all the best for your thesis submissions. And those, again, probably in the next year, we'll see somewhere in some place as decided by the NCC committee. Okay, thanks a lot. Yeah.
Thank you.